Okay. So just know that if you open up the AWS console, you're going to see a lot of services. So please, you can be intimidated, but just let it go. If you open up and you log into your own account, or if someone gives you access to labs and you see a bunch of services in there, just know there's like 300 services in AWS. It's okay. We all look at that and get completely overwhelmed. It's totally fine. Just know that we're really only going to focus on things like computing, networking, and storage. Those are really like what all those core exams really focus on, is how to deploy those kind of services related to that. We're not going to talk about quantum computing. We're not going to talk about augmented reality. We're not going to talk about ground station, which I don't even think is listed here, like satellite. We're not going to talk about that. But just know that mainly we're focused on services, the same services that we've been using for 20 years. So Amazon's corollaries are kind of what we're talking about. Just because I just started recording, I'm just going to go back for just 1 second to make sure this shows up on the recording. Is that, remember, cloud-based deployment is one model, all into cloud, all onto the data center, which is an on-premise deployment. That's one model of deployment. And then hybrid spans between the two, which is where a lot of established companies find themselves. Companies usually started after 2012 are pretty much completely cloud-based. So, and you're saying, well, Michael, why not 2006? Yeah, there's reasons for that, but typically.
Got a question, Michael?
12. Yes.
Doing a hybrid deployment and mixing with AWS, is there like tools that exist to make that seamless, or is there preferred vendors if you're going to do something on-prem that AWS only works with, or is it pretty easy to just, whatever flavor you got on-prem or technology you have on-prem, you can work with AWS?
Pretty much whatever technology you're working with on-premise, you can either at least run in your own virtual machines out on AWS, or AWS has a higher level analog, like they have a copy of it, like MongoDB, or like usually data stores, the technologies. But yeah, AWS usually has it. The funny thing is that most of the vendors also have their own deployments onto AWS via the AWS marketplace. So like, even if it's a technology that's not offered as an official AWS service, AWS has partnered with the company so that you can actually find it in their marketplace, and you can just run it natively on AWS using the marketplace to kick it off. So, but there's no, like, an operating system in a data center is pretty much the same as an operating system inside of AWS. The only difference is the underlying like operational overhead. So as long as you can support running your application inside of a virtual machine, then it's definitely going to run on AWS, which is pretty much everything, frankly.
Thank you.
Yeah. Okay, so not being intimidated by services and the 3 deployment models, those are things we just talked about. Okay, so then let's talk about the 6 benefits of cloud computing. So this used to be, by the way, called let's trade capital expense for operational expense. And then AWS realized, they were like, hey, we're not really describing this accurately. Because the truth of the matter is that your bill in AWS, remember I said billing was one of the harder things, is going to be variable, because you're going to try different things, you're going to experiment, but typically it's going to be plus or minus within a certain range. So if you're spending $10,000 a month, you're usually not going to grow like to $20,000 unless you just launch a new project. I think the highest bill I've ever worked on is $6 million a month, which was kind of fun and a little crazy. And then the highest I ever saw someone personally handle is that I worked for a student learning company, and the company bill was about $800,000 a month, and it was all on this one guy's credit card. I was like, how did you convince American Express to take an $800,000 bill a month? And it wasn't like he had like a diamond card or some other thing. And so, yeah, I was like, man, you're just racking up mad points. What happens when the company misses a month of payments? What's the interest on that? Anyway, so one of the key benefits here is that, capital expense is typically you buying hardware, right? That then gets depreciated over time for the business. So you make a massive investment, you buy hardware, that hardware comes to the data center, you depreciate it over time, 3 to 5 year, whatever the devaluation schedule is. And so instead, you're now paying for services, right? Is that you're now paying for operational services. You're not paying for, investment in fixed, like hardware, like an actual fixed entity, usually capital expense. So now they refer to it as variable expense. So, no, like fewer upfront expenses, and now you're focused more on variable expenses. And by the way, you can turn that up and down. If it's December and it's your slowest month of the year, and you only need to maintain for 5 users or 50 users, you can turn all your consumption down. And then in April or spring, when everything goes crazy and you've got 50,000 users, you can turn your consumption up. So that's another reason they refer to this as variable expense. So a second benefit of cloud computing is cost optimization. So it's very similar to what I just mentioned, except I was just highlighting variability, is that if you only need 2 servers to run your business needs at 3 o'clock in the morning on a Saturday, you can turn your stuff down. Monday morning at 8 a.m., if you need 50 servers, you can turn it up. And so just know you can optimize for costs, right? You can just stop focusing on running data centers, you know what I mean? And stop only focusing on, not only having the capacity you need when you need it, but really just focusing on your applications that are relevant for your customers instead of becoming really good at running data centers. So you can stop spending money on that and lean it out by letting AWS run it. Let's see, Ruben, clarify that for me. Is that typically a manual adjustment? Does it happen automatically? Which adjustment? Clarify
So
for me.
when you talk about like turning up and turning down, like users and capacity, is that something that, you're charged for how many people or what you're using? Or do you have to actually go in and manually adjust the services?
You can do both actually. So if you want, you can have it set. So let's say, for example, latency was your thing, or maybe it was a number of active users. You can actually set it so that, like for virtual machines, for example, there's something called auto scaling. So you can set it so that if your active users is 50 and you only need 2 servers to do that, you can have auto scaling turn your servers down to 2. But let's say all of a sudden active users grows to 50,000, it will keep adding servers until it can actually, match whatever like per metric capability you want to set. So it's mainly recommended that you do it automatically. Some people like to turn the dials manually. That's not recommended, but you can there's plenty of tools out there for you to just do that automatically.
Awesome, thank you.
Yeah. Requires a little bit of upfront code, like not coding, but just like setup. But not much at all. But yeah, so usually automatically is recommended. All right, so variable expense, cost optimization. Those are 2 benefits that we talked about thus far with AWS. The other one is capacity. You can really optimize for capacity. What does that mean? Well, it's exactly the reference I've been making. Turn it up when you need it, turn it down when you don't need it, right? So you can literally stay a little bit ahead of demand. So capacity can stay a little bit ahead of demand instead of you having to make guesses of like, well, I think I'm going to need 50 servers. And those servers are sitting at 1% utilized. That's not ideal. So capacity can scale in or scale out as needed. When you give that capacity back to Amazon, you stop paying for it. So if you're like, I need 50 servers and you give 40 of them back because you want to scale back to 10, you stop paying for those servers, those 40 you gave back. The other thing is that Amazon is constantly getting better based on like levels of consumption because they're getting better at running large scale systems. And so every time they get better at running S3 or they get better at running virtual machines, they actually lower the cost for you on a per unit basis. So for example, I think like S3 has dropped prices like 7 times in the last like 3 years, meaning the price per gigabyte for you to store data has gone down by at least 2 pennies every time. So that it's like dropped by like 14 cents over the last 3 years, something ridiculous. The price per virtual machine per core has also dropped tremendously over the last few years because as Amazon grows and you start to consume more, the price per unit goes down. So for example, in storage, your first 100 gigabytes might be like 5 cents, 0.005 actually. So actually it's not even 5 cents, it's like 5 1,000ths, right? Might go down to 0.005. And after your first 100 terabytes, it might go to, 4. And so what will happen as you go up in consumption of total space, your price per gigabyte will go down. In addition, as they improve their system, you're also going to get a price break. Now, that's not guaranteed, but I got to tell you, their track record for this is ridiculous. At least once a year, they're lowering prices on something, if not multiple times a year. So, variable expense, cost optimization, capacity, and economies of scale are our current 4 benefits of cloud computing. The last 2 are speed and agility, which is really all about, you not having to basically wait on resources to show up inside your data center. But the other piece that's awesome is that you want to test an idea in 15 minutes, you can have the servers up that you need, or less, actually. So this really, it gives you a tremendous amount of business agility, because you're no longer waiting 6 to 8 weeks for hardware to show up at your door, right? You just spin it up and go. And when you're done with it, you give it back. And then last but not least is that, we keep talking about, cost optimization, right? The fact that you now have variable costs instead of these huge upfront investments, that you can now stay ahead of capacity, right? And that it's like really easy for you to focus on your core aspect of your business, on the innovation and the agility, instead of having to wait for servers to get provisioned. The other thing is that you can go global in minutes. You can literally create a copy of your website and span it the entire world within about 15 minutes. And so, that's a powerful driver when you need to accomplish something quickly and you need to get it to a global audience. This is the infrastructure that does that for you. So AWS is spectacular at this. So just to make sure we've reviewed, variable expense is one of the advantages of cloud. Cost optimization is really easier to do if you're tagging. Just to say this, if you're tagging, it's easier to do inside AWS. Staying ahead of capacity needs is really easy in cloud. Economies of scale, where you benefit from cost reductions and optimizations on the back end with AWS, that's here as well. Being able to drive a lot better business speed and business agility, and technical speed and technical agility, that is probably one of the purest benefits. And then being able to take your services global in minutes, very easy, very true, especially if it's a web-based service. Any questions about AWS's perspective on the 6 benefits of AWS? All right, here's a question for you. What is the cloud deployment model, not the benefits that we just covered? What's the cloud deployment model that I said Gartner said everybody would be at in 2020? What's the cloud deployment model they said they would be at?
Hybrid.
Hybrid. Yeah, good. Right. And hybrid is comprised of 2 particular deployment models put together. One of them is all in cloud. What is the name of the one that's actually in the data centers?
On-premise.
On-premise. Good. Good. So we've got cloud computing, we got on-premise, we got hybrid. Okay. Don't worry. I'll ask you about the 6 benefits here later. Do note that AWS likes to stick their services into general buckets, like security, identity and compliance, management and governance, storage, networking, content delivery, database and compute. These are really the core ones. Obviously, there's data analytics, there's machine learning, there's like customer communications, there's space-based like satellites, there's quantum computing, there's blockchain-based ones, there's augmented reality ones. We're not going to talk about those unless you really want to. Okay, now here's their knowledge check. 1, what is cloud computing? So everyone type their answer in the chat if you don't mind. Just give me a letter. Which of these is their definition of cloud computing? Good. Yeah. We didn't really phrase it this way, actually, right? Because I said, this is self-provisioned on-demand software-defined infrastructure. That was the phrase that I used. So it's interesting because we know that backing up files that are stored on desktops, and that sounds like something completely, that's not cloud computing alone. Deploying applications that are connected to an on-premise infrastructure, well, that's not required because we saw that there's cloud-only models, so on-premise isn't necessary. And then running code without needing to manage or provision servers. Well, I mentioned that was one of the 3 ways you could host applications. That was serverless. So then C makes a lot of sense because it's on-demand delivery of basically IT services and applications through the internet, right? And that's one kind of important aspect that I didn't necessarily emphasize, is that it needs to be connected to the network in order for it to really function. So it's got to have internet connectivity, or at least some kind of network connectivity, for it to really happen. Good, excellent answers. All right. What's another name that they like to throw around in the industry for an on-premise deployment? What's another name for an on-premise deployment? I actually take deep offense at this, but I see where they're coming from. Okay, so private cloud deployment. By the way, in most enterprises, what would you speculate is the most common piece of software that's used for private cloud deployments? Anyone know? What do we run in our data centers that host our virtual machines? I'll give you a hint. They released their first product in 2001, and it completely revolutionized virtualization.
Is that VMware?
VMware. Yeah, that's exactly right. That's what most of us equate with our private data centers, with our on-premise data centers, is we think about VMware, right? Because they're the ones who basically created the whole market for virtual machines, right? For virtualization. I would argue, though, that VMware does not offer nearly the features that AWS or really any cloud provider offer. So the private cloud is kind of a misnomer because you don't have that level of API interaction and self-provisioning. But regardless, that's how they refer to it, is that on-premise is often referred to as private cloud deployment. Okay. Okay, mention this in one of the 6 benefits. How does the scale, like the growth of cloud computing, help you save costs? Why is that beneficial to you, that Amazon keeps growing? Good, I'm seeing some good reach outs here. That's perfect. Don't be afraid to completely just swag a guess. It's totally good, right? So A, you don't have to invest in technology resources before using them. I'm not sure how that helps you save on costs, but okay. Let's see. You can quickly develop applications to customers and provide low latency. I don't know if that's related to the scale, right? I think that's a benefit, but I don't know if that's related to scale, how cloud computing grows. Accessing services on demand helps prevent excess or limited capacity. Well, actually, no. Having it on demand actually is probably going to promote, you basically, like, you're going to consume extra capacity. I got to tell you, in the last few years, I've never seen anybody request more servers than Amazon had available, but I don't think that necessarily relates to the growth per se. It really, what happens is that as Amazon grows, it really is actually B, in the sense of that as they get better and better at, cloud usage from a large number of customers, your cost per unit goes down because they get more and more efficient at hosting storage, more and more efficient at hosting networking bandwidth, more and more efficient at hosting virtual machines. And so your price per machine, per gigabyte, per gigabit goes down because they're getting all this experience from all their various customers. They're getting more efficient about it. This is how, when the cloud grows, we all benefit because they lower costs. Now, if you feel like you're being marketed to a little bit, you are, but it is true, actually. But, it's kind of like a soft benefit. It's like, hey, if you use me more and tell all your friends to use me more, things are going to get cheaper, which is true, but also very businesslike. Okay. Now, let me ask you my own questions. Which one of the 6 benefits related to you being able to copy a website and have a copy of that website available across the entire world within minutes, right? And Ginter, you were dead on, by the way, with the buy more, save more. Which one of the 6 benefits? Was it cost optimization? Was it variable expense? Was it like capacity? Was it economies of scale? Yeah, it was global in minutes. Good, Brian. Yeah, so go global in minutes, right? That's the one that if you need to go global in minutes, if you need to get a website over the entire world, that's the benefit that you can do in AWS really quickly. Which one did I say would avoid you having these large upfront capital investments in order to buy hardware for 3 to 5 years? Which one of the benefits matches that? Is it, well, and capacity is definitely a benefit, but capacity is more about customer experience. How do we make sure that our capacity stays ahead of demand? Yeah, so variable expense. Perfect. So variable expense is the one where it's like, hey, we don't have to make these large hardware investments. Instead, we're just going to switch it over to an operational expense. So it's a software line item where we're consuming somebody else's service. We're no longer running our own hardware. Good. Okay. And which one was related to the question that we just saw, where every time Amazon gets bigger and bigger and better from learning all about all this customer data, that they lower the price per unit, the price per gigabyte, the price per gigabit? Which one of the 6 benefits was that? Good. Excellent. Economies of scale. Definitely. Right? As they get bigger and better, the price per unit gets better, right? Gets lower. Okay. Questions of any type about the 3 models or the 6 benefits of cloud computing? Let's see. Is there something I was gonna? Oh yeah, you know what? I was actually gonna copy something out of the speaker notes. Hold on just 1 second. Here we go. That way you can see my screen. I'm gonna paste this into chat for you. This is how Amazon refers to these 6 benefits. Oof. Hopefully you can read that. Hold on 1 second. Let me trade that up just a little bit. Make that a little bit more palatable, because that is weird. Bear with me just 1 second. All right, there we go. Better formatting. I just wanted you to have that for your notes in particular. This is how Amazon talks about those like particular sections. So that does show up on the exam, just like, hey, do you understand like which of these 6 benefits applies in this scenario? So be prepared. All right, let's talk about compute in the cloud. Don't worry, we're gonna take a break here. It's not gonna be too long. We're gonna take a break here in a second. Give your brains a break. Okay. Here are our objectives now. Man, this is, I gotta tell you, this is like, it's like an eye full of objectives. Here's what's really gonna happen. We're gonna talk about EC2, how EC2 charges, the different like t-shirt sizes of EC2. We're gonna talk about how to scale EC2, how to like make it highly available using a load balancer. And then oddly enough, we're going to talk about 2 like messaging options that work well with EC2. EC2, by the way, is the virtual machine service. So we're going to talk about virtual machines, all the t-shirt sizes for virtual machines, securing virtual machines. We're going to just talk about a few aspects of virtual machines. And then we're going to talk about services that work well with virtual machines. Like, for example, you wouldn't have an Egg McMuffin without egg, right? So we're going to talk about some of the things that kind of work well with virtual machines. But it's funny, it's not the fundamentals. So it's not, we're not going to talk about networking because that's later. We're not going to talk about storage, so that's later. We're going to talk about applications that work well with virtual machine applications. And there are other compute options, because I said, you know, there's virtual machines, there's containers, and there's serverless. So we are going to mention the other types just briefly, but we're not going to deep dive into them. Okay. So let's get into it. Okay, so we're back to our coffee tea shop model. Customer's going to make a request. They're going to say, hey, you know, I'd actually like a you know, Hochima green tea, right? And so how does that apply here, right? Well, in this case, what we're asking for is we're asking for the ability to host an operating system. Now, I want you to guess for me, because you may not know, right? What are the 3 flavors of operating systems that Amazon can host? Does anybody know? Let's take a guess here. Like in broad strokes.
Linux,
Linux, yes.
Windows.
Windows, thank you. And then we've only got really one left because they're the only one with a walled garden, right? Who's left?
iOS.
Yes, Mac OS, right? That's it, right? It's Mac OS is what we got left, right? We got Windows, we got Linux, we got Mac OS, right? Mac OS, by the way, didn't actually come available until last year. Now, most people run Windows and Linux. Mac OS is typically reserved for certain edge use cases, like maybe developers need access or whatever, because, Apple doesn't play super well in the enterprise. People have come up with solutions, but they're not necessarily like opening to support that. But Windows and Linux has obviously a strong ecosystem around it, depending on who you're talking to. Now, that being said, virtual machines in Amazon are pretty amazing. You can boot a virtual machine in about 15 seconds in Amazon if you've set your configuration up correctly. I got to tell you, that is incredibly fast from the 2 to 10-minute boot times that we were seeing with with virtual machines in our own data centers, right? Now, there's kind of a misnomer there. It says pay only for what you use, and that's not correct. You pay for what you ask for. You pay for the capacity that you've asked for. If you're only using 10% of that capacity, that's on you. You asked for 100% availability. You asked for 100% capacity. If you only use 10% of that capacity, you're still paying for 100%. So just want to make sure that's clear because it's kind of a misnomer. Now here's how it works. You launch a virtual machine by simply saying, I want to launch it. I want to launch a Windows box. I want to launch a Linux box. I want to launch a Mac OS box. And it asks you a bunch of questions. How do you want the networking to work? What's the firewall setup look like? What kind of storage do you want? It asks you a bunch of questions. You answer them, and then it basically launches it up. That's all that happens. So it's a really simple process. And most people, by the way, don't do it through the web console, which is one of the 3 ways that you can access AWS. Most people do it programmatically, meaning they use the command line, or they use their favorite programming language to launch it up, or they use a tool like Terraform, which some of you may have heard of. Terraform is a multi-cloud provisioning tool that allows you to declare in a file what you want, and it boots it up. Now, AWS also has their own tool that allows you to declare into a file and boot up a virtual machine. That's called CloudFormation. We'll touch on CloudFormation just a little bit later. But just know there's lots of ways to get this done. But basically, you launch a virtual machine. The virtual machine shares its security information with you. And then you log into the operating system. So you can log into Windows, you can log into Linux, you can log into Mac OS, and do the stuff that you want to do all inside that operating system that is actually running out on somebody else's hardware, in this case, AWS's hardware. So if you're used to VirtualBox or Hyper-V or Zen or any of the type 1 hypervisors that allow you on your laptop or desktop to run a virtual machine, this is the same concept, but it's running on server hardware just like VMware does. So it's called EC2.
So, Michael, excuse me. So you said most people launch virtual machines either using the command line, Terraform, or what was the other?
Or CloudFormation. Yeah,
Or
CloudFormation.
CloudFormation. Okay.
Yeah, CloudFormation. CloudFormation is the native tool, right, that AWS
Yeah.
provides
Okay.
for that. Yeah. Terraform is actually done by a company called HashiCorp. So HashiCorp is a third-party tool that's actually pretty much the industry standard on provisioning. But most people won't necessarily go for Terraform unless they anticipate that they're going to be working on multiple workloads on multiple clouds. But it is a great tool to use. CloudFormation is considered kind of the de facto tool when you're just working natively with AWS. Sorry, I was logging into my console because I wanted to show you just really quick what it would be like to launch a virtual machine. Apparently, I chose an unsupported region, which is kind of cracking me up because I'm kind of wondering what region I was in. All right, so this is a little blown up. So let me shrink this down just a little bit. Okay, this is the management console for AWS. How did I get this? Well, I literally typed in, I want to create an account on AWS. So, right, I want to create an account on AWS. And literally, like one of the first things it says, hey, you can sign up for an AWS free account, right? And then it's going to show you how to create a free account. Now, please do not let this mislead you. That account is not free. There are free tiers inside the account, but you can go beyond those tiers and spend $1 or whatever. Again, don't be scared of this. It's going to be hard for you to spend a lot of money on AWS, like even like $10 to be frank about it. If you don't leave anything running, if you don't leave anything running, you're going to spend nothing, right? So just, just word of caution is that don't let free, it's free as in puppy. It's not free as in beer. For those who mentioned beer earlier. Once you're logged in, by the way, into the console, up here at the top is a little search bar. So if we type in EC2, what will happen is that EC2 is the virtual machine service. So this gives us virtual servers in the cloud. If I click on this, I just wanted to show you the first question it asks you. And so I'm in this like relatively complicated console and you're kind of like, oh, Michael, wait, what's happening? Well, first of all, I've only got one virtual machine running right now and it stopped on purpose because I've set it to turn itself off if I don't log into it in every 30 minutes because I use it for a very explicit purpose. Notice that it actually has a size, like a t-shirt size listed here. I'm going to talk about those t-shirt sizes in just a minute. But the main thing I want you to see is that in the upper right-hand side, it says launch instances. This is the first question it asks you once you click on launch instances. What operating system do you want? The first thing it asks you, it says, look, I want you to choose an Amazon machine image because I want you to choose your operating system. Oh, and by the way, Amazon has their own flavor of Linux. Here's Mac OS. By the way, notice it has Big Sur, Catalina, Mojave. Here's Red Hat Enterprise Linux, so RHEL 8 for those of you working in that enterprise, which is, I think, most of Booz. SUSE Enterprise Linux, and then here's Ubuntu server, and then notice here's the Windows servers, right? So your Windows boxes are down here. These images, by the way, if you didn't notice this on the left-hand side, are all part of the Quick Start tab. These are all Amazon provided images, which means they are security scanned, locked down, right? And you'll have to read the documentation to find out to what level of lockdown they're at. But just know that these are safe images for you to use. Most enterprises, by the way, will pull these images, scan them themselves, and make their own copies for their own use. And they'll strip out software that they don't think is relevant. So that's the first question, though, that this virtual machine service is going to ask you. It's going to say, what operating system do you want? Do you want Windows, Linux, or Mac OS? What flavor of Linux do you want? What flavor of Mac OS do you want? So just know it's going to try and guide you through the process. Notice also on the right-hand side that there are x86 and ARM architectures. So you can choose different processor types if you want to. Do most of us want to do that? No. But you might be one of those people who's doing IoT devices and you need ARM because that's going to be a low power processor that runs great on the edge. So you might need an ARM version for whatever reason, okay? So just know it's there. Notice that some of the options don't have multiple processor like the Mac because Apple. Yeah, we're moving on. So that's the first question. Notice at the top, it's going to ask you a bunch of other questions like choosing the size of instance that you want. So by the way, I'm just going to choose a generic instance. So this can get really overwhelming really fast. I'm going to show you my favorite website that I like to use to figure out what size, what family of virtual machine I'm going to use. So there's a website called ec2instances.info. I'm going to post that link, and a company just bought it called Vantage, which is, it had been free for years, and it's still free actually, but it had been like unowned for years. It was actually an individual who took donations. So this is a site that allows you to find out of the plethora of t-shirt sizes that you can find for your virtual machines in EC2. This helps you find it. So for example, Ruben, let me just ask you a question here. if you were going to run like your favorite database on a system, how many processors would you want on that system? Just give me a swag guess. How many processors would you want on your virtual machine?
4?
Okay, good. I think 4 is a great start, actually. So we got 4 CPUs. Okay, so Ruben, another question then, and then you're off the hook. How much memory would you want for that database? If it had 4 processors.
Let's go with 512 gigs.
Ooh, 512. That's impressive. Okay, now notice what happened. So what happened here is that Ruben gave me something that said, hey, you know what? I need 512 gigs of RAM, which is a really like interesting ratio to processors. So Amazon got strange and said, hey, you know what? That's not going to work. So why don't we take the 4 out for a second? I have systems out here that have 512 gigs of memory, but they have at least 32 processing cores, right? Notice you can see it right here in the middle of the page. So that's usually what happens, is that the vendor will come to us and say, hey, for my database for 50,000 users, I need 512 gigs of RAM and, you know, at least 8 processing cores or 4 processing cores. And Ruben's like, okay, that sounds great. So let me come out here and find the virtual machine that matches my vendor specifications. Now, I kind of just lied to you all in case you weren't paying attention. How many of you actually get accurate numbers from the vendor about the sizes of your virtual machines? Has that ever happened to anybody on this call? Yeah. I didn't think
No.
so. No, I haven't either, ever in 25 years of working. I've gotten numbers, but they all turned out to be lies, right? It was like little like Mark Twain. There's like statistics, right? And so is that storage memory or is that RAM? So Cordero, that would be in-memory RAM, right? So definitely memory. Storage wise, notice that some of these have storage attached to them over here under instant storage. Let me highlight that really quick. And some of them say things like EBS only, right? So a lot of them don't actually have storage. There's a reason for that, by the way. EC2, the virtual machine service, has a hard drive service called EBS. They are distinct services, but they only work with each other. So when you launch a virtual machine, you have to tell EBS what size hard drive you want. That's a disk thing, not a memory thing. Right now, we're just talking about memory things. So disk things, right? You can actually set whatever, up to 16 terabytes of disk. You can actually set your own volumes onto a virtual machine. So if you're like, hey, I need a virtual machine that runs Ruben's database, and Ruben needs 8 terabytes of disk space, not a problem. He can add that on a single volume. We could put it on multiple volumes, but EBS, which is that column in the middle where it says instant storage, EBS would be the service that provide that. And it's going to ask us that when we actually go through the wizard. It's going to say, hey, what's your disk space look like? What do you want there, right? So just to say this also, instant storage. So this little column here, this is temporary storage, which means if this instance crashes, any data on those instance storage is going to delete itself. Like, so don't use instant storage, use EBS storage only. Let me say that again in case you missed this. Some of these EC2 instances, these virtual machines, come with what's called instant storage. Do not use it. Or if you're going to use it, make sure you really know what you're doing, because that storage is temporary. It's ephemeral. EBS storage is permanent. If that virtual machine crashes, that disk is going to persist. With instant storage, if that virtual machine crashes, all that data is gone. So I just want to make sure that's super clear. If you launch a virtual machine, do not rely on the instant storage that comes free with that virtual machine, because it's super fast and it's super ephemeral, super temporary. Okay. So Ruben, we got a great, let's say a 64 gigabyte, 512 virtual machine. Let's say that we're going to use the, you know what, let's choose the R5B. So this one, like right here, we're going to choose this one. Notice, by the way, that this has a 20 gigabit network backplane. I want everyone to take that in for a second. That's a 20 gigabit connection to the internet. If you can saturate that, I want to talk to you because I really want to know what you're doing, actually. What that means, Cordero, is that 20 gigabit backplane, that server alone has a, God, what is it? let's see, 20 times 5. So it's 100 times faster than most people's internet connection. So most of us are running 100 megabit or 200 megabit connections at most, because we're using Xfinity or some variation thereof. Maybe we're using fiber. So that means that that box is going to operate at 100 times faster network speed than our home internet. So that's what that means. It's the network bandwidth. Okay. Now, just to clear my drawings out, let's say that someone else comes in here and says, you know what, I don't need 512 gigs of memory. You know what I need? I need 448 processors. You might say, Michael, that's ridiculous. Why would you need 448 processors? Good, you should be asking those questions. This was just to illustrate that you could get 448 processors, and not that you should. I do want to mention, though, by the way, that these are bare metal boxes. So these are boxes that are actually allow you to get access to actually physical hardware in AWS's data center. So just know it's not just virtual machines, it's servers. So you can actually get physical servers in here as well if you want to. Let's see, Cordero, is that network performance not based on your network speeds? Oh yeah, if you were trying to transfer data to that server, if that server can go to 20 gigabits and you can only go to 200 megabits, then it's going to be a 200 megabit connection. So yeah,
it's just what's inside of AWS. It's
yes,
operating as if.
but
it's a
just to
super
say
fast.
this, if 1,000 people with 200 megabits were connected to that system, it could handle it all simultaneously. Right?
Gotcha.
Right? Because it has that bandwidth to it. But yeah, you know, you're right. If you've got a 1-lane highway and the other guy's got a 10-lane highway, your 1-lane highway is going to limit the speed transfer. So yeah, that's what happens. So bottom line, Amazon has every size of virtual machine that you're looking for the most part, except for like odd and weird numbers, right? But like this is the caps, is that you can get up to 24 terabytes of memory and 448 CPUs. So there's a lot out there. If you're like, hey, Michael, I don't need that. Can I just get one with a gig of RAM? You know, if I just want like a gig of memory, I want a really small box with maybe like 1 CPU. Oh, guess what? They've got one. It's called the T2 Micro. One of my favorite boxes for just messing around with proof of concept. All right. So that whole expose was just to show you that there's a lot of richness to both the sizing and the depth of EC2 virtual machines, and that website that I posted, instances.vantage.sh, that is a great website to use when you need to actually look at machines based on specification, CPUs, memory, your networking speed. Now, to focus this down a little bit more, Michael, you keep talking about t-shirt sizes, and there was like an R6 and there was like a T2. What does that mean? What does those R's mean? What does the T mean? Why is there a C5 up there earlier? What does that actually mean? So imagine you've got employees and they are making coffee, they're taking money, and they are taking inventory as well, because they're trying to keep the shop going. And you got everybody doing everything, which is kind of okay, but there's a lot of context switching, and maybe you need someone to maintain inventory while someone else is taking money, while someone else is actually making the coffee, because you got to keep the system flowing, right? You can't just have everybody doing everything at the same time. You want them to specialize because they all play a part in the system. Someone's taking care of the customers and taking the orders. Someone else is making the coffee while that guy's or gal is taking the money, and someone's on the back end making sure that everything's restocked and that things are ordered. So this is where specialization comes in, is that we design virtual machines for certain purposes. So virtual machines have different what they call family types, because some of them are just optimized for general purpose workloads. Some are optimized for CPU heavy workloads. Others, like a database, for example, is optimized for a memory heavy workload. And then we've got other workloads like GPU computing, which means we're using a video card instead of using a processor on the motherboard. And then we've got storage optimized systems, where what we're trying to do is optimize for disk operations. Now you might say, but Michael, hold on. How do we figure that out? Like if I want a CPU, how do we know what that is? Well, first of all, AWS has a thing called the AWS instance types, which is great documentation about how to see and find let's see, where are you? I think I chose the wrong link. Hold on just 1 second. There it is. There it is. So notice that on the left-hand side, Amazon has general purpose, compute optimized, memory optimized, accelerated computing, which means GPU computing, so video card based computing, and storage optimized. So Amazon designs these virtual machines to be purpose built. Is this going to be a great virtual machine for something that requires a lot of memory? Is it going to be a great virtual machine that something requires GPUs? So what actually ends up happening is you start, after a while of like playing with these, you start learning what these little codes are. So notice that over here, earlier we were looking at a T2 micro. Well, the T2 family is a burstable performance instance that's actually part of the general purpose family. And it comes in all these sizes. So Amazon, when they test you, is going to tell you that the T series is a general purpose designed virtual machine type. The T series is a general purpose designed type. But the funny thing is that they've also got other things like the M6s, the M5s, the M4s. And of course, Mac is here because I don't know why. And then we got the compute optimized series. And here's the funny thing. The compute optimized series all starts with C. The memory optimized series, for the most part, starts with either R or X. They've also got H's and Z's in here, but mainly it's R's, or the RAM, right? So the memory optimized types are R for RAM. And then the accelerated computing types usually start with either a P or a G, which are the primary types that we use for GPU computing. And then the storage optimized types are also pretty funny, is that they're pretty much I's and D's. I, when you want high IO, D, when you want like colder disk storage, like for data warehousing. Now, do you need to memorize all that? No. All you need to know is that when you see a virtual machine and it says R5 extra large, that R is the family type, meaning it's a memory optimized instance. The number says it's the 5th generation of this instance. And the t-shirt size means that it's not a medium, it's not a large, it's an extra large, right? So it just denotes the size. You're still going to have to look it up. Why? Because we all look it up and nobody has this memorized, and nobody requires you to have this memorized for the exam. You just need to know that if someone says, hey, if you want a compute optimized instance, you're probably going to pick a C box. If you want a general purpose instance, they're probably going to ask you to use an M or a T. If you want to take a memory optimized instance, they're going to ask you for an R. Now, here's the cool thing. We're going to cover some of this at the end of the day as far as the practice exam questions. They're going to help you memorize these things. But just know, no one's going to ask you to just rattle off the numbers, like the letters and the numbers right off the top of your head. Okay. But just know that there are sizes. In some cases, it goes nano, micro, small, medium, large, extra large, 2x large, 4x large, 8x large. You get the math, right? You can figure it out. So just know there's t-shirt sizes as well. That's a lot of information. Are there any questions about the 5 general types, family types of EC2 instances inside our systems? Okay. A few more slides, then we're gonna take a break. Here's your question. It's a little challenge, right? Which one of these, A, B, C, or D, is ideal for high performing databases? When we talk about databases, what's the one subsystem we typically emphasize out of CPU, memory, disk, or networking? When we want fast access to data, where do we stick it?
C.
Good, Cordero. Yeah, with memory optimized, right? We stick it in memory. Good. Now, which of these remaining 3 types are optimized for data warehousing? I actually said that it has a letter that's optimized for data warehousing. Yeah, good. Yeah. So storage optimized, right? Because it's going to hold a bunch of data that's at rest. It's not going to be in memory. Excellent. All right, which one of these is going to balance compute, memory, and networking resources? Which one of these sounds like of the remaining two would describe balancing out the subsystems? Right? Probably general purpose, right? Just going to be balance all the subsystems. So we're going to balance those out. Of course, the last one is the last one, which is offers high performance processors. That's obviously going to be compute optimized because that's dead on. That's a dead ringer. Okay. All right. So you may remember me telling you before that billing and security are a little harder in cloud in general, not just with AWS, but with all of the cloud providers. So, but it is currently 9:55 and I'm feeling like we need to take a break. Does anyone have any questions for me before we stop and take a break?
How long for the break again, please?
Oh, we're going to take 15 minutes. So we're going to come back at 10 after 10, actually. And I'll put a little timer up so you can see.
Okay, thank you.
All right.
I have just a general question, not
Ask
on
away.
anything that we've gone over. How it says that this you have like 300 and something days for the slides if you know online or perpetual if you download it to your computer or a mobile device. How do you download it to? How do you download it? That's my question. I have it on my iPad, but I don't see where I could, I guess, download it. I still have to log into the website, put my username and password, and then the slides show up.
Yeah. So Eric, what they're talking about is if you download the mobile app, like the Bookshelf Vitasource app, and put it
Yes,
on
I
your
download
desktop.
the app on my iPad.
Yeah, if you put that in there, and then what should happen is if you sign into the application and you have access to the document, it'll
Uh-huh.
show up on your device,
Uh-huh.
and then it is downloaded to your device.
Oh, it is?
Yeah. And
So every
when you
time
when you open it, it's downloaded to your device.
Oh, okay. And so that'll always, now that I have the app, like a year from now, I go to the app, put in my username and password, it will still be there.
Only if
Yeah.
you've downloaded it, right?
The app?
Yeah, if you downloaded the app and you've looked at it inside the application.
Yes. Okay.
Yeah, then
That's
it's
what
there.
I'm doing right now on my
Yeah.
iPad. Okay.
Yeah.
Thank you. That was it.
Okay, cool. Yeah. So enjoy the break. There's a timer up. So we got about 14 minutes left. And so we'll see you at 10 after. All right. Welcome back. Questions for you? Because I know that you just let all that information just sink into your bones while we took a 15-minute break. All right, here's a little quiz. So what is the letter for the family type that is optimized for CPU or compute? Someone type that in chat for me. Good. So whether it's a C5 or a C6, that is optimized for compute. Okay. What is the letter for the family type that is optimized from high memory instances? Good. Good, Donna. RX, that's exactly right. Yeah, but yes, Ruben, Brian, Ramesh, excellent. R, the R series, yes, perfect. Good. All right. What's the two letters that are part of the storage optimized type? What are the two letters that could possibly be of that storage optimized class? There's more than two letters, but let's just say two letters. Good. I or D. Perfect. Okay. Last one, last question for 1 billion points. Which drive letter, Brian, are you just guessing? I haven't said anything. You're like, which, yeah. So which one is the general purpose one? So T is one of the letters. What's the other letter that's for general purpose? I also call it median. Yes. M's and T's according to Amazon, are general purpose. I am going to tell you that T's are for testing, because you really need to know how T's function to use them in production. But M's are T's according to Amazon. Okay, so I didn't mean to, but I deceived you. One more question. Which two letters generally govern the ones that are GPU accelerated, the ones that are like video cards? Which ones are those? Yes, the accelerate class, yeah, family type. Good. So the P's or G's. There's others hidden in there. Amazon kind of went all over the place there for a while. Just so you know, after the numbers, sometimes there's letters. Those mean different things. So bottom line, read the documentation if you want to get into fine granularity on the EC2 machine types. Amazon's not going to quiz you on that. Okay. Good. All right, so let's talk about the different licensing models that can happen with EC2. Because obviously, oddly enough, you can pay full retail price if you want to, or you can get discounts if you're willing to get into a relationship with Amazon. As you can imagine, if you're willing to give Amazon money, they'll give you discounts. Or if you're willing to be inconvenienced, they'll give you discounts. One of those two things, right? If you're willing to give Amazon money ahead of time, they will give you a discount on your virtual machines. Or if you're willing to be inconvenienced slightly, you can get different pricing on your virtual machines. Let's talk about those types. Okay, so first is on demand. What is on demand? Well, this is retail price. This is list price. This is where you're like, you know what? I'm going to give this thing back. You know, we're not in a relationship. I'm not committed to you. I'm going to buy 50, I'm going to use 50 virtual machines. Then when I'm done, I'm going to give 50 of them back to you because we're not in a contract. There's no contract. I've made no agreements, right? Just using your virtual machines. I'm going to give them back to you. This is great for like irregular workloads. In other words, workloads that are going to run for like a couple months. Great. 3 months, 4 months, sounds great. And then that's the retail price option. That's what most people use when they're not in a long-term like project. Then there's spot instances. Remember I said you can either give Amazon money or you can be inconvenienced. Spot instances, which I used to call the eBay of pricing models, which means you could bid on your price and say, hey, Amazon, I know this normally costs $1, but I'll pay you 80 cents for it. If you want that, take my bid. They don't do that anymore. Amazon tells you how much they're willing to accept. You agree to accept that price, and you still put bids in and whatever. And then if you're what you're willing to pay and what their bid, like their offer is, matches, then they do it. The spot instances are weird because if a customer comes along and says, hey, I need an instance, they will take it away from you if you have a spot instance because there's another customer asking for an on-demand instance. Let me say this again. If you have a spot instance, they'll give you a 2-minute warning and they'll take the instance away from you. And you might go, Michael, that sounds horrible. Why would I pay for a spot instance if it's going to get taken away from me? What if it was a 90% discount? No, seriously. Like, what if you could get an instance that costs you $1 for 20 cents an hour? Now, you don't know if you're going to get it for the whole hour. You might get it for 4 hours. You might get it for 5 days. But what if you could get it for 20 cents off the dollar instead of paying a full $1 for it? And you had an application that could withstand interruption because it keeps writing its data out to an external database. And so it starts up, does some processing. Someone else takes it away from you. You get a 2-minute warning. You write all your data out to the database and you do that 100 times. And instead of spending $10,000, you spent $2,000 to generate that report or that oil and gas survey or that genomic genetic analysis. What if you had an application that could do that? That's what spot instances are for. Spot instances are ideal for workloads that can be interrupted, checkpointed within 2 minutes, and then restarted easily. You can literally save up to 90% on the same dollar for dollar cost as you would on demand. So remember, spot instances up to 90%. You get a 2-minute warning. These are ideal for applications that can be interrupted. Okay. So if you're paying $1 on demand and you're paying 10 cents or 20 cents over on spot, well, then what do the other pricing options offer? Well, first of all, there's a reservation. So they call these reserved instances, and you do a 1 or 3 year commitment. Think of this as like you're in a contract with Amazon. So Amazon says, you said, look, Amazon, my project's going to run for a year. Amazon says, we'll give you a 40% discount. So instead of paying a full $1, you're going to pay 40 cents. You're going to pay 60 cents, right? Because you get a 40% discount. Now, if you come to Amazon, you say, look, Amazon, this project's going to run for 3 years. Amazon says, you know what? We'll give you a 75% discount. So instead of paying, right, $1, you pay 25 cents for that same virtual machine. So just know that reserved instances, which actually they themselves come in several subflavors, reserved instances are for workloads that run to 1 or 3 years, and you want a discount over this on-demand billing, which we were just looking at. Now, reserved instances, by the way, are for 24/7 workloads. They're not for interrupted workloads like spot instances are, right? These are for workloads that you expect, like, look, I need these 2 web servers to stay up for 3 years, or at least be restarted every, if they fail, right? I need to stay up for 3 years. This is ideal for what reserved instances are used for. 24/7 workloads that are either running a year or 3 years. Up to like a 70-something% discount. I think it's 75. It might be 72. My memory gets a little fuzzy around that. Now, in addition, instead of reserving capacity and saying, look, I want this particular family type, I want to buy 10 C5 extra larges. That's what you do on the reserve side for a year or for 3 years. You can instead say, look, Amazon, I'm going to give you $10,000. In exchange for that $10,000, you're going to give me $30,000 worth of compute. Amazon's like, that sounds great. Yeah, you go ahead and give us some money, and we'll give you a 66% discount on any EC2 workloads that you run. So, the one on the left is a contract that's based on you picking your virtual machines and saying, I want these virtual machines for a year or 3. The compute savings plan says, look, you can pick any virtual machines you want. Just give us a bunch of money and we'll give you a discount on what those dollars will get you. So instead of spending $30,000 for on demand, you're going to spend $10,000 and we'll give you $30,000 worth of compute. Now, you're going to get 66% savings, by the way, if you buy the 3-year bucket. If you buy the year bucket, obviously the savings is going to be less. So don't be fooled, right? The more money you give over a longer period of time to Amazon upfront, the deeper your discount. The less commitment you make to Amazon over time, then they're going to give you a more shallow discount. Okay, just keep that in mind. Okay. Now, in addition, Amazon has more expensive ways that are above retail price that you can pay them for if you have security and licensing requirements. What are those more expensive ways? Well, let's say your security team's like, no, you cannot run your virtual machines on the same hardware as other customers of Amazon. So Amazon's like, cool. You want your own piece of hardware that you can run your own virtual machines on that is just for you? We'll give you a dedicated host, or we'll give you a dedicated instance. What's the difference? Well, with a dedicated host, they actually give you an entire host. With a dedicated instance, and this is really funky to think about, if you ask for a 2-processor, 8 GB virtual machine, they actually, for a dedicated instance, stick you on a 2-processor, 8.25 gig machine. Isn't that weird to think about? Amazon has tiny little pieces of hardware in their data center that are sized perfectly for all the different virtual machines types. And they basically will literally put your virtual machine on a system that is like exactly sized for the virtual machine, which I find fascinating, right? I find that absolutely fascinating. That they not only have these huge hosts that you can just host your own virtual machines on, but they have tiny little hosts that will size your exact virtual machine, right? Which just blows my mind somewhere. Like that they have both. That's a really complicated data center. So just know that this is the most expensive way to use Amazon. The only reason people ask for dedicated hosts and dedicated instances is because they have security or licensing requirements that require it. Meaning they can't be hopping around off of different pieces of physical hardware. They have to stay on the same piece of physical hardware. Now, I can't even tell you what the cost of this is because I've never had in my 10-year career with AWS a single customer use dedicated instances or dedicated hosts. But I've heard that sometimes it's 2 to 3 times more expensive. So instead of paying $1 for a virtual machine, you'll pay $2 or $3 for a virtual machine. But those are the security requirements. Okay. So just to review, I've got on-demand licensing types for virtual machines. I've got spot licensing types for virtual machines. And remember, on-demand is just retail price. You use it, give it back. Spot is the one that has the 2-minute timer on it, where you could get interrupted at 45 seconds in. You could get interrupted 45 days in, right? But they're going to give you a 2-minute warning and they're going to take that virtual machine away from you. And then reserved is when you want to make a 1 or 3 year commitment based on the type and size and location of your virtual machine. Nope, that's a 24/7 workload. A compute savings plans is where you give Amazon money ahead of time and you consume out of that bucket of money when you launch EC2 instances, and they give you a discount for that. You're like, hey, it's like you're prepaying, so they're gonna give you a discount, right? And then the most expensive option is dedicated hosts and dedicated instances, which isolate your virtual machine to its own dedicated piece of hardware. Most expensive way to use AWS.
Michael, quick question.
Ask away.
For Spot, are you picking a time frame, how long you want it, even knowing that it can go up and down? Because you said, hey, it could go on for 3 years.
Well, you can put your bid out there and say, look, I want to place a bid where Amazon, if normally this virtual machine costs $1, I'll pay you 40 cents on the dollar. You can put a bid out there and say, I want this bid to only live for a year, which means you only want them to answer that bid in a year, but you can't control how long you would get the virtual machine for.
Okay.
Yeah. Well, what happened instead, Greg, is if there was a workload where you're like, hey, I've got 30 days to run this workload. So what I'm going to do is I'm going to run a spot bid for the first 20 days of the month. And let's say that you don't make the reporting compute like numbers that you need. The last 10 days of the month, they'll use an on-demand instance to finish out the report. So that way they don't have to worry about like not getting the report done with spot instances. They'll just run spot instances for the first third of the month. And if they don't get it done because a lot of people have been using spot, they'll fall back to on-demand to finish the report. Now it's still cheaper, right? Because if half the report gets done in spot instances and half of it gets done in on-demand, they've still saved 25% or more off the cost.
Okay.
But you can't control how long you get the machine for. You can only control how long you ask for it.
Right. Okay. Thank you.
Yeah. Yeah, it's a good question. Spot pricing used to be a lot more complicated, but Amazon simplified it. So now you can actually see what the current spot price is for everybody. It used to be this really crazy competition of like, well, I want it cheap, but you're trying to like guess the right number. And there were whole ecosystems that evolved. It was like a betting ring a little bit, but it shifted away from that. Okay. So remember, on-demand, spot, reserved, which by the way, reserved has 3 flavors inside of it, just so you're aware. Compute savings plans. And then we have the last, which is really just dedicated instance, dedicated host. Okay. Questions for you. What is the difference between a compute savings plan and spot instances? So what's the difference? Like in other words, if someone says, what workloads would you run under a compute savings plan versus what workloads would you run under spot instances? What would you reflect to them about spot instances? If someone wants to run a workload under spot instances, what would you tell them there are things that you need to be aware of with spot? What's the one thing they need to know about spot?
That it could be shut off within 2 minutes or taken
Exactly.
away.
Exactly. In other words, it needs to be an interruptible application. Okay, so then if we're okay, so they're like, okay, good. So that's spot. By the way, what's the maximum discount you can typically get with spot? What did I say? If it's $1,
90%.
That's right, 90%. Good. Now, if we're talking about compute savings plans, how does that work? Is that for a certain period of time? What is compute savings plans for?
That's where you pay up front,
And what term can you pay up front for?
1 to 3 years or 1 or 3 years.
1 or 3 years, yeah. Yeah, good. And this is this for 24/7 workloads, or is this for workloads that are gonna stop and start and whatnot?
Stop and start.
Actually, honestly, it could be both.
24/7.
It's ideally, it's like kind of built for 24/7, but since it's a bucket of compute, you could probably actually get away with stopping and starting, right? Because especially if you have more than one like workload that is going to eat out of that bucket, you could have a bunch of ones that just stop and start as long as they're eating out of that bucket. In other words, if you bought one computer's worth of a year of compute savings plan, but you got 2 computers and they eat 50% apiece, then you could stop and start easily. But if you want one computer to have 100% discount and you want it to eat out of the bucket, then you'd have to run it 24/7 to make that happen. But you could run 2 computers at 50%. You could run 4 computers at 25% of the time. You can get the math from there. Good. So just to reflect kind of what I said, compute savings plans are ideal for consistent amount of compute usage over a 1 or 3 year term. Spot instances are ideal for like things that can withstand interruptions. Let's see. I think the official number right now is that for compute savings plans, the maximum discount I think you can get is 72%. I think that's the exact number, 72.
I have a use case question. Might help me
Sure.
relate. So my team has a need to run like a license server on the cloud. You know, people will be needing to go in and get their licenses served to them during business hours, but like not on weekends, not after business hours typically. What might be the ideal plan for that?
So just to make sure I'm clear, you're running it at scheduled times, like kind of Monday through Friday.
For the most part, granted, you know, there's the off chance that somebody working some odd hour might need to get their license. And you know, it's something that will be running for years potentially.
Oh, so it's going to be running 24/7.
Yes, yeah,
Okay. So if it's 24/7 workloads and it's going to be running for years, right? Then you're definitely going to be looking at either a reserved instance, because that has to just be up and it's going to be up on a single virtual machine. It's going to be up for that entire duration of time, or a compute savings plan, because those are the ones that have the longest duration attached to them. Now, the licensing, it's feeding out licenses, right? It's like a licensing service, right? Is
Yep.
that correct?
Mhm.
Yeah. Yeah. So in that case, you'd either look at reserve instances at a 3-year plan, if that was the duration, or you'd look at a compute savings plan at a 3-year plan.
Okay, cool, thank you.
Yeah. Yeah. If you said, oh, it only needs to run Monday through Friday between 8 and 8, reserved instances actually have a sub flavor called scheduled reserved instances. You don't get as deep of a discount, but you can go to Amazon and say, look, my peak usage is between 8 a.m. and 8 p.m. Monday through Friday. I don't need a 24/7 workload. I need basically 5 times 12, right? Because that's 8 to 8. So I need 60 hours worth of compute. Can you give me a discount? Amazon will give you like a 40-45% discount, sometimes 50. And then you can actually run the workload at a discount for that 8 to 8 Monday through Friday runtime. But in your case, it's a 24/7 usage. So just a straight up standard reserve instance is going to be best.
Awesome, thank you.
Excuse me, Michael, are you finding that clients are shopping a quote from one cloud provider to another? Like, you know, one is saying, hey, I'm getting this discount from Google. Can you match it or beat it or?
Mm-mm.
No? Okay.
No, and the main reason is that people will run different workloads in different cloud providers, but they won't span the same workload across cloud providers. So they'll like, what's the term? Multi-cloud, right? For example, that's sometimes the word that's used to talk about it. When people
Yeah.
say multi-cloud, typically in an enterprise, what they're doing is like, this workload is ideal for Azure, this ideal is for Google, this ideal is good for AWS. But they're not taking a single workload and running it on all 2 or 3 cloud providers at the same time. That's not happening because there's too much latency between the cloud providers. They all operate very distinctly in terms of like the details, the low level details. And so people aren't doing that. So usually you don't see people shopping. Now, when a project starts, then you can see shopping, right? Where somebody's like, well, we really need the best, like, performance price ratio. And so you'll see people shopping cloud providers before the project launches to determine which cloud provider they're going to use. You'll see that. But you typically won't see people spanning workloads across cloud providers.
Okay, thank you.
Yeah. It's funny. A gentleman named Corey Quinn, who runs a newsletter on AWS called Last Week in AWS. He like a couple months ago, he put on a whole thing about multi-cloud, and I was shocked because everything he was saying, I was like, man, we've actually experienced that. Like, you can't run spanned workloads across the cloud because they just operate so distinctly. So, yeah. One day, when I actually just saw, by the way, that the other day that they launched a new kind of like a networking type, and it uses quantum entanglement. Like, it's basically teleportation. It's mind-blowing, actually. And I knew about quantum entanglement from 10 years ago, but the fact that they're using it to create networking connections, fascinating. I just can't wait to see in 5 years what kind of network speeds we have, because this is a faster than light limit which that just blows my mind because, right, Einstein, Newtonian, I can't even begin. So I can't wait to see where that lands in 10 years.
Doesn't AWS have direct connect?
It does, but that's 100, that's a 110 or 100 gigabit connection.
Oh, okay,
These connection speeds were like exabit,
okay.
which is crazy. Okay. Good questions, by the way. Thank you. So let's talk not about virtual machines, which we just kind of skimmed. So you got the family types, that virtual machines are out there, they run in certain types of OSs. They're designed for certain purposes. Let's talk about things that can enhance the virtual machine experience. Now, this is what I like to call the secret sauce of AWS. Because if you take your data center and you lift and shift it in AWS, let's be frank, it's just expensive data center 2.0. But if you use the tooling that we're about to talk about, which is auto scaling and elastic load balancing, then what happens is AWS becomes 100 times better than your data center, because now you've got automatic scaling in and scaling out, which is where the cost savings and the optimization and all these other pieces come, is these next 2 technologies. So let's talk about them. So auto scaling is the first of the technologies, and it works very much like this. We're at our coffee shop. I got 2 customers. I got 1 barista. No problem, right? All of a sudden, I got double the customers. This 1 barista is getting overwhelmed because he's doing 4 orders a second, which would be a lot. Let's say 4 orders every 5 minutes. Now, instead, I'm going to add 2 baristas to make sure that I can handle, because I'm pretty sure I have a 2-to-1 ratio between turning the coffees and drinks around in a reasonable time versus customers complaining because they're having to wait 10 minutes for their drink, right? Now, auto scaling solves this challenge with virtual machines. And just so you know, this is Amazon EC2 auto scaling. There is auto scaling for a bunch of services inside of AWS, databases, all kinds of stuff. So just know this concept of staying just ahead of customer demand with capacity, this concept that we're applying to EC2, it applies to a bunch of Amazon services. But let's talk about EC2 in particular. So, like, for example, in the good old days, back when we used to climb uphill in the snow both ways to school, notice that at this top line here with the gray and the purple, like this line up at the top right here, this was the $1 million of hardware that we used to buy in our data center to make sure that we could meet this peak capacity day. Can you imagine? That means that the other days here, this is all lost money because we bought hardware that's actually just sitting there unused. This is the problem, by the way, that plagued Amazon, because as you can imagine, they sell 10 times more between Black Friday and January 15th when all the returns get processed than they do the remainder of the year. Actually, they used to. That shifted a lot. But they still sell more over the holidays than they do any other season. And can you imagine they spend $10 million on hardware and $8 million of it would sit there and do nothing for 9 months out of the year. This is the reason they started making AWS, is because they were like, how do we solve this problem? Then they didn't realize that was going to be a $54 billion business in 2021. So this is the challenge, right? Is that we don't want to buy hardware, have it sit there unused. And I don't want to go to Amazon and ask for $10 million worth of capacity if I'm only going to use $1 million of it. So how do we solve that problem? Well, this is where autoscaling comes in. So autoscaling says, you know what? If you want to grow your virtual machines automatically, I can do that for you. In other words, if you just tell me what your metrics are that you don't want to get compromised, I can make sure that I increase the number of baristas, or servers in this case, to whatever minimums and maximums you tell me you want. So let's say that for business continuity reasons, you're like, my website cannot have less than 2 web servers, but my website can grow up to 1,000 web servers. Autoscaling will automatically add and remove web servers based on policies you define. So this tool is used to make sure that you can grow your business when your customers are demanding more from you, and you can scale it in when your customers are saying, look, I'm good. It's 3 o'clock in the morning on a Saturday. I'm asleep. I don't care what you're doing with your shoe shipping website. I don't need that, right? So autoscaling allows you to elastically scale out and scale in, and it can be based on CPU metrics. It could be based on latency. It could be based on number of logged in users. You can do any metric that you can track. So it's pretty nice. You might say, well, Michael, why is there a maximum? Because what if some Russian, oh God, this actually happened to me. I actually had somebody at a company I was working for call up a Malaysian click farm and get 1,000 people to click on our website. And they took our website to its knees, not because we didn't have capacity, because it started costing us $1,000 a minute to run this website, which by the way, was more than what we were usually paying for this, right? So just know that you want a maximum, because I'm so glad I didn't have it set to $10,000 a minute, because that would have been a whole different discussion. So my point being is that there's maximums so that someone can't financially break you either, right? Because if someone misapprehends your website, right? Because you might not be willing to pay that much to keep it online. You might be actually just be willing to let the service go offline. So it's a security measure. All right, so that is autoscaling, one of like the 3 components of the secret sauce, right? Because this allows you to scale in and out. Now, the other question you might ask is that, Michael, it's great that you can just add web servers. How do the users find the web servers? If I have 2 or 1,000, how do the users find the web servers? Do they like go to the server directly? And the answer is no. They don't go to the web server directly. What they do is they go to this. This is called an elastic load balancer. Elastic load balancing's job is to be the landing point when someone types in www.amazon.com, it lands on a load balancer. The load balancer in turn distributes that web traffic to whichever servers are active. If there's 2 servers active, the load balancer is going to talk to those 2. If there's 1,000 active, it's going to distribute the load across 1,000 boxes. Let's conceptualize this. 2 baristas. I've got 3 talking to 1 barista, and I've got 1 talking to another barista. Elastic load balancing's job is to make sure that the load looks like this. And by the way, if I add baristas, it'll redistribute the load across the baristas. Pretend these are servers. I got 2 servers with 50 connections, 25 go across. I've got 5,000 servers and 50,000 connections. Each server is going to end up with 10 connections. So a load balancer's job is to distribute workloads evenly across the servers that are active at any given time. And that's what a load balancer does. This is a network device. It sits on the network in front of your virtual machines. And it is a single point of contact for your like www.amazon.com, www.michaelrishiforrester.com, whatever your website is, it's a single point, right? And so you can see on the left-hand side, I've got this low demand period where I'm hitting this load balancer and it is distributing across the two servers. Now, all of a sudden, users go up. My load balancer talks to the auto scaling system and says, hey, auto scaling, I just got double the users. Can you add more servers for me? And the auto scaling group says, oh yeah, that's okay. We can do that actually. And so the auto scaling engine adds double the number of servers, puts them behind the load balancer and says, here you go. Later on, by the way, if we go back to the low demand period, the auto scaling engine will say, hey, by the way, if you've only got 2 users, I'm going to take 2 servers away because you don't need them. How do I know that? Because I've got metrics. In other words, the auto scaling engine, if you say it's okay, we'll see that everything's cool as far as metrics go, and we'll pull those 2 servers out of rotation so that you're paying less money for the same, for good performance. So to rehash that, auto scaling handles the addition and removal of virtual machines. Load balancing handles the distribution of network traffic to those virtual machines. So the load balancer is a networking device that handles distribution. Auto scaling is an additive or subtractive engine that adds virtual machines as you need them. Does anyone have any questions about that concept of either auto scaling or load distribution to the systems? What you really need is a magical unicorn. Just kidding. All right, no questions? Hey, where's my squeaky unicorn? Okay, let's do a quiz while I pine restlessly for my squeaky unicorn, which is now gone. I think someone stole it. One of my kids took it. Okay, so let's ask a question here. In the upper left-hand box, the one that starts with the number 1, removing unneeded Amazon EC2 instances when demand is low, is that auto scaling or is that elastic load balancing? Either type in AS
Scaling?
or ELB. Let's see, Stanley, you said auto scaling? You are correct, sir. It is auto scaling, right? So remember, auto scaling handles the addition and removal of instances. So that's perfect for that. Okay, number 2, adding a second Amazon EC2 instance during an online
Auto
store's
scaling.
popular sale. Stanley's like beating everybody. He's like, you guys can type and I'm just gonna verbalize it. So good. Yeah, you're right, Stanley. It's auto scaling. And I see the rest of you typing auto scaling as well. All right, distributing a workload across several EC2 instances.
Load balancing.
Good. Some people are like, we're gonna race Stanley. We're gonna type it. Yeah, so it is load balancing. Perfect. All right, ensuring that no single EC2 instance has to carry the full workload on its own.
Auto scaling.
Ensuring that no single EC2.
Load balancing.
Yeah, this is load distribution,
Okay.
right? Yeah. So load distribution, making sure that load is
Oh,
spread
workload.
evenly. Yeah. Good. Good. Number 5, automatically adjusting the number of EC2 instances to match demand.
Elastic.
Scaling.
Also scaling.
That's right. Also auto scaling. Remember, if it involves adding or removing instances, auto scaling. If it involves load distribution or load evenness, it's going to be a load balancer. Providing a single point of contact for web traffic into an auto scaling group. Well, I mean, that has the name in it, right? So I think we know it's the opposite. No, that kind of gives it away. That's elastic load balancing. I didn't write that question. Moving on. Okay. So that was all just auto scaling and elastic load balancing, which are enhancements to EC2. And remember, EC2 is just virtual machines. So this is just one of the 3 ways we can host applications, with either virtual machines, containers, or serverless. Now, I promised that I would confuse you by adding in really confusing messaging services that are adjuncts to running applications on virtual machines. And I'm going to keep my promise is that we're going to talk about 2 messaging services, which I will tell you frankly, has an Amazon authorized instructor. I don't really know why these are here. They are actually super powerful and super relevant, but I'm not quite sure why they're here in this slide deck, other than Amazon really, really wanted you to be aware of them because they are 2 of the most established service inside of AWS, and they are very widely used. And there's kind of sister services to each other. Before we do that, does anyone have any questions about EC2, auto scaling, or load balancing? Okay. Okay, so let's talk about 2 of the most established, like I would say oldest services, but that kind of implies that they've been abandoned. No service in AWS has been abandoned. AWS is spectacular about iterating and maintaining their services. And I say that with a lot of pride, not because I'm just a fan, right? I like all the cloud providers, but AWS does a good job of this. Okay. Now, does anyone ever see the video of Steve Ballmer like talking at one of the conferences, and he's like, developers. And he's just like, because you got to say this, is that Microsoft is spectacular at wooing developers, and they are really focused on the developer journey. And I say that kind of a little bit with tongue in cheek, because I'm going to say the word microservices at least once here. And there's a lot of hype and a lot of substance around microservices, but people do throw this around a lot, right? And I mention this to you because there's nothing wrong with running monoliths, but if you want to use cloud and you want to use, particularly you want to use containers and you want to use serverless and you want to have cloud native scale because you want to be like Netflix or, LinkedIn or Microsoft or Google, and because quite frankly, who doesn't want to have those problems? Because then you would have the same revenue problems they have, because I'd like to have those revenue problems. Just know that microservices are a great design pattern that everyone should at least know a little bit about as you move into cloud, because microservices really are a design pattern that allow you to scale independently and fabulously on a cloud infrastructure. Now, you can use microservices inside of a private cloud, but it really works exceptionally well on public cloud. So, kind of like tongue in cheek there, like microservices, woo, but microservices has a lot of tremendous benefit to it. So it's really great to know just a little bit about it as we move into these messaging services. So here's the gist. Here's the gist of the things you need to know about microservices. There's 3 really important things that you need to know about microservices. 1, notice how we've got components listed here, right? I've got component 1, and I've got component 2, and I've got component 3. Each of these are business concerns. You're like, Michael, you lost me. What do you mean business concerns? For example, if you go to Netflix's homepage, they've got the billing profile. They got the account profile in the upper right-hand side. They've also got billing under that profile. And then they're going to tell you the top 10 things that are trending in the United States, things that you've already watched, things that are similar to things you've already watched. Each of those is actually a business concern. It's like a product within their product, right? It's like a sub-product. Because you go to their website, what's their business? Their business is streaming, which in and of itself is a product, right? But their other business is they want to tell you what's trending in the United States because they want you to feel some social pressure to watch it. Because you're like, what are people watching? Let's connect with everybody else. They want to show you specific recommendations. They also want you to be able to pay your bill, which is a billing concern. And they want you to manage your account, which is an account concern, like a profile concern. Each of those could be these components that you're seeing on this slide. Let's say the orange one is billing, the blue one is account, and the green and the red ones are all recommenders of some type. Hey, Michael, watch this because you love Spider-Man. Hey, Michael, watch this because you loved Avatar, right? Let's say instead of running those in one code base on one server, and when we wanted to scale it, we just added another server. Let's say instead that we made those independent business concerns, we actually made those services or components. So now what's going to happen is that I've got my own billing service running on its own server / container / serverless. And I've got my own account service and it's running on its own space. And I've got my 2 recommenders down here and they're running on their own spaces. So the first thing that's happened, the first characteristic of a microservice is now I've separated the business concerns for the entire product. So now I've got billing in its own process. I've got account management in its own process. I've got the 2 video recommenders in their own processes. And so they're now independent to each other. And what's cool about this is because I've separated them, now I can deploy them independently from each other and I can scale them independently from each other. That's the second characteristic. First is that I've now separated the business concerns for a single product into a bunch of different services. Second is that these services are all independently scalable and deployable from each other. And third, they now talk to each other across the network using these little interfaces called APIs. So they're no longer operating in memory. They're now talking to each other across the network because they're no longer on a single server. That's the third characteristic. They're using APIs to talk to each other. Now, I don't expect you to memorize that. That's not going to be on the test, but I just want you to be aware of that, is that measure of independence allows microservices to scale better. But when someone looks at this, by the way, can someone tell me when you look at this, you're like, but Michael, what have you done? You took a monolith, which was very simple, and then what did we do with the microservices? What did we just add to microservices? What did we just add to our product? Someone take a guess for me.
Manageability.
Yes. Sorry, I was laughing because Kendra said a lot of arrows. Kudos, Kendra. Right on. But Cordero, you had it right on the head. You said, basically you said manageability. You said complexity. We just added a lot of complexity, did we not? Now we went from this simple little application over here that was all on one server, and now I've got 4 independent servers over here. That sounds like a lot more headache. And the one on the left is talking through memory. And what you're telling me is the one on the right is now talking across the network. Isn't that less reliable? Could be, but networks have gotten pretty good, right? So other than a lot of arrows, Kendra, what we've added is we've added complexity to our application, which might be worth it if we can manage that complexity. Now, notice I just said something key. It might be worth it if we can manage that complexity by letting somebody else handle the complexity. And that's what we're about to talk about. How do we create independence, asynchronicity, loose coupling between these services so that if one fails, it doesn't take down the whole ecosystem? How do we do that? And that's where these services come into play that we're about to talk about. But remember, complexity can be the cost of moving from a monolithic application to a microservice. So how do we manage that complexity so the gains are worth it, right?
You hire AWS.
Well, of course, Brian, that is the official answer, right? Is that you have to hire AWS for this. Now, I kind of like to take tongue in cheek, but AWS actually does make this easier. And you know, they're not necessarily a consulting firm. They're just going to offer services going to make this easier for you, right? Now, that being said, the first service that could make that complexity easier is called the simple notification service. Why? Because one of these concerns might be notifications. So instead of you having to write a notification component here, instead, you let AWS handle that for you, right? Let AWS handle notification for you. And what do I mean by notification? Well, we all know notifications because we see this in our email, which is still getting spammed, right? We subscribe to a topic, and when we subscribe to a topic, we give consent to receive messages from the poster. Well, this is exactly what the simple notification service does. Has my coffee shop. I want to send people notifications about coupons and coffee trivia and new products. But do I really want to send it to all the people? No. I want to tailor it because I want people to subscribe to specific topics that are of interest to them. And this is what the simple notification service does. And whether it's a mobile push, a text message, an email. You could even do an HTTP post if you're familiar with that. I can actually only send the relevant messages to the subscribers who actually want them. So the simple notification service could replace one of those components, because instead of you learning how to write SMS text messages and write emails and run an email server and all that, just get SNS to do it. SNS can replace one of those components and do it for you. And since it's all API driven, it fits nicely into that microservices model. Now, SNS is a push model. You subscribe and it pushes messages to you with your consent. There's a sister service for this called the simple queuing service. So we're now moving off of SNS, the simple notification service, and we're moving on to SQS. SQS is different. SQS is not a push model. SQS is a pull model, right? Or as my son likes to joke about it, which he knows a surprising amount about SQS. I think he listens to most of the time when I'm teaching. He talks about it as a trough. He's like, oh, that sounds like a trough, Dad. Like a trough. He's like, yeah, you know, like we feed the pigs, we put, you know, slop in there and the pigs come and they, you know, get into the trough and they pull out what they want, right? I'm like, well, yeah, actually, that's technically accurate. So SQS is a queue and you put messages on the queue and then the consumers come and they pull those messages off and they read them and consume them. It's just that simple. So what's cool about this is that let's say you have a bunch of web servers in the front who are all of a sudden getting hammered with orders. They can dump all those orders into the simple queuing service and your application servers on the back end can just pick them up and they won't get overwhelmed. Right? Now, I'm not saying the orders are going to get processed in a timely manner. You might need to add more application servers to make that happen, but you're not going to overwhelm the application servers by dumping a million messages on them. You're going to dump them into the queue instead. Now, we've seen this work at a coffee shop because when we go and order a coffee, we go and pay the cashier. And then what happens is that an order is automatically generated and put onto the barista's queue or backlog. And the barista makes the drink to give to the consumer. Now, if the barista is backlogged because he's got 3 or 4 drinks ahead of you, then it goes into a queue. And we know this. We do this all the time. We watch the tickets pop up. We're like, oh, we're 4th in line. So we're used to queues. Now, obviously, in computing, it's a little bit more advanced, but the concept is the same. When you have a bunch of like items that you need processed, but they don't need to be done like in real time, just put them in order in a queue and have somebody come and process them off the queue one at a time. Just straightforward. And that is the simple queuing service. So SNS is the simple notification service and SQS is the queuing service. Now, where these fit in our original design here is that the simple notification service could replace one of these components. The simple queuing service could sit in between one of these components to make sure the component doesn't get overwhelmed. So SNS can replace one of your microservice components. SQS can help facilitate communication between components. That's what the queuing service is really for. Now, don't get me wrong, SNS, the simple notification service, can also facilitate communications between components, but it is usually used to replace a component. Little bit of trivia. SQS was the first service ever published in 2006 by AWS. It was not S3. Even some of the Amazonians get that wrong, but SQS was actually the first service ever published. Okay. Questions about the simple notification service or the simple queuing service? Wahaha. Okay. Sorry, that was a semi-maniacal laugh. All right, let's talk about serverless compute services, and then we're going to move on to networking and storage and other things. Guess what? I know your brains are like, man, we just want to keep going all day, Michael. I know, I get it. But just know that I am going to force you to take a break in about an hour because I know you need food and sustenance, and your subconscious needs to dive in all the information and need to digest all my jokes and plucky comedy. But meanwhile, let's talk about serverless. Okay, so bonus question. I said there were 3 ways to host applications. I said virtual machines. I said serverless. What was the middle one, by the way? Not serverless, not virtual machines. What was the middle one that I said you could use to host applications? Nope. Kendra, I'm glad you mentioned that, but microservices is an architectural style. But here's the funny thing about you mentioning that, Kendra, is that this style of application hosting goes really well with microservices. So I've got virtual machines, I've got blank, and I've got serverless. What does that mean? Oh yeah, there you go, Kendra, you got it. Containers, there you go. Just so you know, microservices and containers go like together like peanut butter and chocolate, right? So peanut butter is good by itself, chocolate's good by itself. Together, they're spectacular, okay? Oddly enough, we're not here to talk about containers. We're here to talk about serverless, which is the most abstracted way of hosting. Now, here's how this works. If someone says that the service is serverless, what that means is that there are hidden servers that you don't have to manage. That's what that means. That means that you magically do not have to touch these servers because, right? Amazon's going to manage them for you. That's all that means. So instead of having computing with servers with code, all you need to do is just put your code out there. Now, Amazon's serverless service, also known as functions as a service or code as a service, is known as Lambda. I know the marketing team is varied and spectacular over at Amazon. It's just called Lambda. Just roll with it, right? Here's how it works, by the way. You give Amazon your code. You set the trigger. What's the trigger? Is it another service? Is it time? Is it a manual push of a button? And then what happens is that code's only going to run if it gets triggered. Either someone uploads a file to S3, your application tells it to go, you get somebody to go in and push the button. So the Lambda code's only going to run when triggered. By the way, if you tell it to run 1 billion times, it's going to run 1 billion times. Well, don't get me wrong, there's account limits. So let's say 10,000. If you ask it to run 10,000 times, it's going to run 10,000 times, right? So you only pay for the compute time that you use, by the way. So if it only runs for like 10 milliseconds, you pay for 10 milliseconds. If it's only going to run for 2 minutes, you pay for 2 minutes per execution. Now, you might be saying to me, Michael, Michael, wait, what? Hold on. Why would I run anything in a virtual machine if I can just run my code inside of Lambda? Well, Lambda has at present just a few limitations, such as you can only run a process for 15 minutes before it's shut off. Now, just to be clear, you can chain Lambdas together. So at 14 minutes, you could call another Lambda if you wanted to. So you could get a continuous 24/7 run, just so you know. So it's not like that's a horrible problem to have. The other thing, though, is that this is really built for what's called event-driven programming, event-driven architecture. So what this means is that this thing isn't going to run until somebody does something. There's an event, like I uploaded a video file to S3. That triggers a Lambda that then takes that file and converts it into 7 different video formats. And then once that's done, it triggers another Lambda that sends a notification to the owner that says, hey, your file's been uploaded. And then that sends another trigger to a user who wants videos of this type and gives them an email because another Lambda is going to run. So this is for event-driven programming. If you don't know what event-driven architectures are, relatively also new design paradigm that's been out, Lambda's been out since 2013, 2014. So it's, 8 years old at this point, 7 years old. So just know that it's a style of programming and architecture where instead of running a server 24/7, you only trigger your code when an event happens. So it's a relatively new style. So this, by the way, you just give your code, answer a few small questions about how much memory your code's going to take up, and then it runs based on the trigger you've defined. It's really
Michael, can I
simple.
ask a question?
Of course.
This seems like the different styles here seem to be like a set it and forget it. If I'm somebody that's in the weeds and wants to dictate and, micromanage how many processors and how much, memory, and I want to track every penny I'm putting into this thing, this wouldn't be for me, because this seems to be like, yeah, here's my code. AWS, you decide how many processors, the memory, what happens, what type of TRX, type of thing to assign to it, and just send me my bill.
Right. And so if you want low level control, you're gonna have to use a virtual machine. This is the most abstracted way to run code, by the way. So you're absolutely right, is that if you want that control, Cordero, this isn't gonna be the service for you. But like, just to say this, you do get to control things like the size of the system. So for example, let's say we use a blueprint and we're gonna choose a S3 get objects, right? I'm just making a quick Python function. No, we're gonna use an existing role. I'm gonna write some code, create a function, all these other pieces. You do actually get to configure like the size of the system in question. So for example, if you only want it to grow to like 1.5 gigs of memory, you can actually set that. Sorry, I'm actually using the blueprint here for a second. Create the function, right? So you get to actually set the sizes and what code are actually being run, but you're right, you're not going to get control over the server. You literally only get to specify the code and some of the t-shirt sizes of the code as it's run. That's it. You don't get to like really set or change anything else. So you're absolutely correct, Cordero. This is the most abstracted way to run it. You don't get fine granular control. If you want that, got to use virtual machines.
And as far as price goes, I'm assuming this is got the best rates. Is that kind of because you're letting Amazon decide everything?
Well, let me show you. So for example, some like this is x86. If you choose a system that has 4 gigs of memory, this is what it's going to cost you per millisecond. So notice, what is that? 1, 2, 3, 4, 5, 6, 7 zeros in front of 667, right? So that's like what? 667 billionths of a cent, but that's for 1 millisecond. So if it runs for 100 milliseconds, then that's going to go up 3 decimal points, right? So
Yeah.
The problem with that, Cordero, is that it's really hard to predict what your stuff is going to cost on Lambda because it's so abstracted. You actually just have to run a test and see how much it's going to cost. Do you know what I'm saying? So again, if you want predictable costs with predictable control, you're going to use virtual machines or containers. For this, you're actually going to have to run it several times and do some tests to actually see what it's going to cost. And again, you're not going to get the level of granular control that you're suggesting. It's going to have to be a virtual machine or container for that to happen. But I will say this is that this is actually really cheap because you only pay for what you are actually using. You're not paying for what you ask for. By default, in most use cases, virtual machines are going to cost you way more than the same code running on Lambda. So if cost is a factor, Lambda could be a stronger option. Notice, by the way, that you can run up to 10 gig processes in Lambda. That's a pretty large process, by the way. Good question. All right, so that's Lambda. Oh, by the way, what languages can you use? You can use Python, .NET, C#, Ruby, Java, obviously, Go. What else is there? And then PowerShell. PowerShell will run. Okay. So we talked about virtual machines. We touched on serverless. Let's just talk about containers for just a second. Okay. So we're now moving to the second type of hosting, which is process virtualization, not operating system virtualization. So here we've got one host that has one container on it. What does that mean? It means that someone has taken, for example, a Java application, packaged it up into a Docker image, and we're running 2 copies of that Docker image, app1 and app2, on this system, on this single host. But I'm just going to tell you this, we don't do this in production. We're not going to run everything on one host because that's not redundant. And so we don't do that, right? So what happens when we want to run it on a bunch of hosts? Who's going to manage the complexity that we were referring to earlier with microservices? Because remember, I said containers and microservices go together like peanut butter and chocolate. Who's going to manage running 1,000 applications on, what is this, 20 servers? Who's going to manage that? Well, I'm not going to manage it manually. We can't. We're human beings. I can't track 1,000 applications on top of 20 servers. Who's going to do that? Well, Amazon solves this for you by offering 2 services that can run containers in production. One of them is the Elastic Container Service, which is an Amazon proprietary service for deploying Docker containers at scale. The other one is the Elastic Kubernetes Service. Kubernetes is an industry standard software published by the CNCF, which can also be run inside of AWS. This is 2 ways in which you can take your Docker containers and run them at production scale out in AWS. But here's the catch. If you need industry standard compatibility, or as you were referring to earlier, someone was asking me about running things on multiple cloud, like doing a cost comparison. If you want to run Kubernetes on all 3 cloud providers, and you run different workloads on different cloud providers, but you want to use Kubernetes to like homogenize everything, you're going to need to run the EKS service. ECS is an Amazon proprietary service. It's way easier to use than Kubernetes, but it is proprietary to Amazon. So it's got incredible integrations. It's a great service, really simple to use, but it's not an industry standard piece of software. So you got to pick your use case. If you're just messing around, you just need to run a container, I would use ECS. If you're like, man, I love Kubernetes and I want to run Kubernetes at my house and I want to run it in the cloud, you're going to have to run the EKS service. That EKS distribution, by the way, that Kubernetes distribution, which Kubernetes, by the way, is a container orchestrator. So it is a service designed to deploy, maintain, and scale containers. Kubernetes is completely certified by the CNCF to run on Amazon. So this is a official distribution of Kubernetes. But general use case, you love Kubernetes, you want its complexity and you want its power, run the EKS service. You just want to run Docker enabled applications, use ECS, and you don't mind being locked into Amazon. Now, both of these container services have a serverless version, and for some reason, someone at Amazon decided to call it Fargate. I have no idea why. I think that's a shopping district inside of London, but like I don't know anything, like I don't even know. But Fargate is basically, when you see the word Fargate, you should think serverless, because that's all it is. It's not a separate product. It basically allows you to run ECS and EKS without having to manage EC2 virtual machines underneath it. Because most people aren't aware of this, but when you run containers, you have to manage virtual machines underneath those containers. If you decide to use Fargate, you don't have to manage the virtual machines. Amazon does it for you. So when you see the word Fargate, think serverless, okay? Now, one other cost difference distinction. When you run ECS and EKS in what we call EC2 mode, you pay for the full price for all the virtual machines that you're running. If you're only using those things 10%, guess what? You're going to pay 100% for those virtual machines. If you run in Fargate mode, both ECS and EKS, guess what you pay for? You pay for only the size of the container that you launched. If that container is a 1 processor, 2 gig container, that's what you're paying for. If you run it on EC2 and you launch a 4 processor, 16 gig machine for that 1 processor, 2 gig container, you're going to pay for 4 processors and 16 gigs of RAM, even though you only needed 1 processor and 2 gigs of RAM. Okay. So it's a general rule of thumb, Fargate is going to be cheaper than the EC2 options on ECS and EKS. So ECS and EKS have Fargate options and they have an EC2 option. The Fargate option is going to be cheaper. but there's limitations for Fargate, so make sure to read the documentation if you decide to go that route. Okay. Any questions thus far about either ECS or EKS plus the EC2 versions versus the Fargate options of ECS and EKS? Okay, here's a question for you. If I need to just run a really simple container and I don't want to do industry compatibility, which of these two am I going to run? Good, good, ECS. If I'm afraid of vendor lock-in and I don't want to use Amazon's proprietary system, which one of these two am I going to run? That's right, EKS. If I am super concerned, I want to make sure that I'm using the service that is the most compatible with the industry. Which of these am I going to run? Good. Yeah, EKS. Good. All right. And for 1 billion points, what is the name of the non-EC2 version, the one that doesn't use servers? What's it called for either ECS or EKS? Yeah, it's called Fargate. Excellent. Good. Now let's do Amazon's official knowledge check. All right. Clear your senses. Take a deep breath in. Bring in all that knowledge that you just got on EC2. Here we go. Ready? Customer wants to use an EC2 instance for batch processing workload, which means, by the way, that's going to be data computational heavy. Which Amazon EC2 instance type should they use if they are computationally intense?
Compute optimized.
That's right. Could I have beach balled that up any further? Yeah, compute optimized. I mean, because batch workloads could be memory intensive, they could be computationally intensive. So I just thought I'd give you some guidance there. Okay. All right. If you get this wrong, you're out. You have to leave the class and go take the rest of the day off. I'm just kidding. You can't. I don't have that kind of power. What are the contract length options for Amazon EC2 reserved instances? What are the two terms? What are the two time frames?
1 and 3.
That's right. 1 or 3 years. That's right. Just so you know, if I remember correctly, when doing the math, if your workload is going to run for like 6 months, 5 months, you want to go ahead and buy a reserved instance because you're going to break even at month 6. If your workload's going to run, I think it's for like 18 months, 19 months, you're going to want to go ahead and get a 3-year. Like, you know, because you're going to pay the same price, but you're going to get more time and you're going to get it cheaper. So just go ahead and buy the 1 and 3 year options at that point.
Seems crazy to me in this technical course where contract length is a testable item.
Hey, we don't want to blindside Cordero, right? Because every design decision you make is going to have a cost implication. So we got to let you know how to optimize, right? Don't worry, there's no talk about cost inside the developer class if you were worried about that. And I know you were. You seem concerned. Yeah. By the way, for all of you, there's actually a cloud. There's a financials class that you can take for those of you who are ever responsible for managing bills or whatever. They actually last year just released was it last year? It might have been this year actually. They just released like a cloud financials class from AWS. If you ever, there's no certification for it, but there's a class for it. All right, 1 and 3 years is correct. Okay, a customer has a workload that will run for a total of 6 months and can withstand interruptions. Oh, see, that's like a key thing. They just said they could do it, right? So which one of these is it? Forget the rest of it. Yeah, what's the most cost-effective option, right? Of course, it's going to be spot instances. By the way, any exam question that you take, if it says it's a workload that can take an interruption, you should just ignore everything else. It's going to say spot. I'm just kidding. Don't ignore everything else. You should read the entire question. There might be other qualifiers. But usually if they state that it can withstand interruptions, then it's going to be spot instances is going to be the answer. Michael Forrester is not advocating that you don't read the entire question. When you take an exam, you should. Okay. Okay, customer wants to give users messages for the specific topics to which they have subscribed. Stop. Don't even look at the answers. You know what service they're talking about because we mentioned subscriptions and topics. We deal with this in our email all the time. There's only one service out of the two we talked about that deals with this, right? Good. I see it. I see everyone putting A, SNS. Good. By the way, which of these is the sister service to SNS that does the opposite? That's one of the oldest service that was ever published. Good. All right, which of these is an industry standard container orchestrator? Pardon me just one second. Sorry, I just knocked over a glass of water. Bear with me one moment. All right, so D, Elastic Kubernetes Service, that's correct. Okay, and that leaves the last one, by the way, which is, which of these is the service that governs serverless? Which of course is Lambda. That's the last answer. Okay. We just spent a good amount of time making sure that we covered EC2 in all of its glorious details, including the container service, right? That's SNS, SQS, including load balancing and auto scaling. And we covered the family types, talked about virtual machines, covered it in detail. Does anyone have any questions before we move on to our next module?
I could have used more of an explanation of what containers are before we just jumped into all the services.
Yeah, they don't really like peel that back, do they? So let me just offer this little soft kind of explanation. So when you take a Java app or a Python app or a Ruby application, just the application itself, what ends up happening is that you usually package it in whatever proprietary format is available for the language. So for example, for Java, it could be a jar file, a war file, an EAR. Ruby, has its own like distribution frameworks. Python, it could be a zip file, right? And what happens is that then that gets passed to somebody who then has to figure out how to unzip it and then run it. And there might be other libraries that it needs inside the zip file or system library needs. In other words, there might be other dependencies. This is what containerization does. Containerization basically acts like a shipping container. Because if you can imagine the shipping industry before 1958, if you wanted to ship monkeys, tires, and bananas, and let's say the monkeys are going back home just for humanitarian rights, right? For animal rights. And so you're trying to get everything back to where it belongs, right? Shipping tires, bananas, and monkeys without some kind of standard way of doing that, like, putting the monkeys in a refrigerated cage, making sure they've got food, making sure the bananas are refrigerated, putting the tires outside of one lump, it would be really hard to stack that onto a container ship, right? It would be really weird. And then in like 1958, someone patented shipping containers. And what ended up happening is that you didn't actually need to know what was in the shipping container as long as you had a way of dealing with the rectangular shipping container itself. Well, that's what containers are, is that they're trying to take this disparate landscape of Python and .NET and Java and Ruby and and they're trying to make a standard packaging format so that I can just hand you this container image. And as long as you have the software to run this container image and the process that's contained inside the container image, you can download it and run it, and it's going to work. So that's what containerization is that's just taking an application, putting it in a standard container format, and then shipping that container to other places that have the containerization software. So it's really just process virtualization. instead of virtualizing an entire operating system. So we did jump right into like the shipping software, you know what I mean? Like the container, like management systems, which is what ECS and EKS are. But we really didn't talk about how like the container itself is nothing more than an application or a process that we've packaged in a certain way. Docker is the most famous containerization software in the world. It's kind of like Kleenex, right? When we say Kleenex, people know that you want a tissue. If you say Docker, people know you're talking about a container. But Docker is not the only brand of container, but it is the most famous one. And it's the one that put containerization on the map, actually. Does that help explain containers as far as it being a process, like application virtualization?
Yeah, a little bit. I just feel like I need to actually develop or understand or see how an application is made, and then how it's, like you said, it interacts with a library or another process.
Okay. Well, if you'd like to do that, just to say this, let me throw this out to you. Oh, hold on. If you'd like to play with Docker, first of all, obviously, you know, we have classes, so we'd love for you to come to one of our classes, and we teach this frequently for booze, so it should be on your degree or in page if you want to see it. But just know that if you really just want to hop right into it, there's this great Play with Docker playground that has tons of like good tutorials to kind of get started with Docker, including a playground that you can just like hop into. And I want to say, here it is. Here's the Play with Docker lab. I'm actually going to post this link in the chat. So for, you know, if you want to play around with that, that'll give you a feel for building your own Docker container. But, you know, obviously also like come take a class with us. I think we're teaching the fundamentals of Docker and Kubernetes here, actually, I want to say within the next 30 or 60 days. Yeah, but otherwise kick the tires on this. Both that website and this playground website will both help you understand the concept a little better. I also want to warn you, you're right to ask the question, Brian, because it's not an easy concept that just like rolls off the brain. So you're right to like, I really didn't get that just from your simple explanation. Other questions? Okay. Bear with me just 1 second. I need to grab something to make sure that I don't start an electrical fire. Okay, so the next section we're going to talk about just for the next like 30 minutes, because, you know, as promised, I got to give your brains a break, right? Got to give your brains a break, take lunch, all that stuff, right? So we're going to talk about Amazon's global infrastructure. So Amazon is either going to host your data or your services somewhere. Where does that happen at? Let's talk about it. Because I know we joke about like cloud being other people's servers, and it is other people's servers. Where do those servers live? Like if you were like trying to point on a map, where is my data, right? First of all, Amazon's not going to tell you where their data centers are, but you can guess a general region, right? So let's go take a look at that. So we're going to talk about the way Amazon's global infrastructure generally works. We're going to talk about the data centers themselves, which is, they're called availability zones. We're going to talk about CloudFront and edge locations, because outside of Amazon's data centers, they have servers scattered all over the world that act as a huge caching network for content. And then like, how do you talk to AWS? What are the 3 ways that I keep joking about where you can actually provision resources inside of AWS? Now, let's say that people are trying to get to our coffee shop, but it's a horrible Atlanta road, which if you've ever been in Atlanta, that might be true because I'm in Atlanta. And someone's got a parade going and you literally cannot get past this parade. Your coffee shop is isolated. So instead, what ends up happening is that if people can't get quickly to your service, you can redirect them to another nearby service, Now, this is exactly the way like Starbucks, right, for example, works. Seems to be like a Starbucks on every corner, right? So if you can't find that one or it's not working, you just go to the next one. No issue. Right? Now, AWS has a great little map. Called the AWS infrastructure map. And what you can do is you can actually go out here and take a look, and it's fully interactive. And this shows you where the AWS regions are. Regions are comprised of data centers called availability zones. So for example, if we go and hover our mouse, I know this is kind of an eye chart, so let's blow it up a little bit. If we hover our mouse over Canada Central, which was launched in 2016, so 5 years ago, notice it says it has 3 availability zones. That means it has 3 clusters of data centers inside somewhere in Eastern Canada. You don't know where, but it's there. In Brazil, in Sao Paulo, they've got 3 availability zones, 3 clusters of data centers that make up this region in Brazil. Notice, by the way, there's some orange ones here. These are ones that are coming soon. But like Bahrain, which was launched 2 years ago, it has 3 availability zones. We've got them in Tokyo. We've got them in Osaka. We've got, AWS has got regions all over the world. Well, I don't know why people are ignoring Antarctica, but I'm about to start a protest. How come Antarctica doesn't get a data center? It's because there's nobody there. So notice the United States, Asia, Europe, Australia, right? And then of course there's one in Africa and there's one in Sao Paulo. That's growing relatively quickly. So you're going to see more and more footprint. These are the regions.
Quick question.
Yes.
Could an availability zone equal 1 data center?
It can, it doesn't often.
Okay.
Yeah. It doesn't often equal 1 data center. If it is 1 data center, it's going to be a big data center. Like it's going to be like a large footprint building, right? Probably bigger than a football field. So most of the time it's a cluster of data centers. And those clusters, by the way, are highly interconnected and they're fault tolerant to each other. So what that means is that they'll have independent power and cooling. So that way, if an availability zone goes down, it won't take the other availability zones down. And so that's why Amazon does it this way, is that their availability zones are clusters of data centers that are independently powered and cooled with each other and connected to the internet. And that makes up the entire region. That's why every region has at least 2 availability zones for redundancy purposes, for high availability purposes. So when you select a region, what you're saying is, this is where I want my services to live. This is where I want my data to be hosted. Can you go multi-region? Of course you can. You're going to have to handle replication yourself, but that's not hard to do, frankly. It's really easy. But if you want to run anything with a network card, just so you're aware, which would be a virtual machine, you're going to have to run that inside of a data center, which means inside of an availability zone. Remember, regions are made up of availability zones. Those are the clusters of data centers. So notice here, they're highlighting Northern California, which has 3 data center sets, right? 3 clusters of data centers, US West 1A, US West 1B, and US West 1C. The letters are what make those availability zones. The region is US West 1. Let me say that again. The letters at the end are what denote the availability zone. Everything else, if it's US West 1 or US West 2 or US East 1 or US East 2, those are regions. The letters after the region are what make it an availability zone. So if there's 4 availability zones, there's going to be 4 letters after the name. If there's 6 availability zones, which Virginia has that, there's going to be 6 letters after the name. So just be mindful that a region is comprised of availability zones, and availability zones are clusters of data centers. Now, just so you know, availability zones are usually located tens of miles apart from each other. So, usually 10 to 30 miles apart from each other. Is that enough for DR requirements? I don't know. Depends on what your disaster recovery policy is. If you need 50 miles of space between your data centers to meet your DR requirements, you're going to go multi-region, not multi-availability zone. Okay. So for those of you who have to like be aware of this kind of thing from a disaster recovery standpoint, going multi-AZ or multi-availability zone is not going to meet most disaster recovery requirements. You're gonna have to go multi-region, which means you would use Oregon and Northern California, or Oregon and Ohio, or GovCloud East and GovCloud West, which is what Booz usually does. Booz usually doesn't operate in the public AWS infrastructure. It uses the government regions, which is GovCloud West and GovCloud East. And Booz has a portal for that, which I'm sure some of you have seen if you've had to provision infrastructure.
Yeah, obviously a question from Cordero, who's always watching the almighty dollar, Michael. Yeah, so I was gonna say, if I was in California, do I want to even be on the West? Why wouldn't I? Does it matter if I got? Obviously not, because the government's doing East and West. So there's quite a big region there. But
Yep.
why wouldn't I want to go international where maybe AWS rates are cheaper out in Istanbul, let's say? Do I have that liberty, or does it fluctuate like that? As far as, I'm a business and what rates am I going to pay? Do I care?
Oh, yes.
Does distance make a difference as far
It does. It does.
Okay.
Yeah, let me touch on that, because I think you're headed in a great direction, Cordero. Is that hold on. Oh, it's not listed here. Here it is. There are 4 reasons to determine to pick a region. The first one is compliance. For example, if you operate a company that can't operate outside the US because you're doing Department of Defense contracts, you're not going to leave US soil. Or you're in the EU and you can't leave the EU. It could be anything like that, right? So the first is legal compliances. That's the first box over on the left-hand side on the screen.
Well, let's just start with the first one there, Michael. I mean, are we kidding ourselves when we say my data is on US soil?
Yep.
Versus what difference does that make when everything's electronically connected? What's the difference between my data being stored on a US soil versus, hey, I'm going to go store it in Israel?
Oh, a lot of difference. And the US actually draws a very clean distinction, as do most governments, that says, look, those servers and their data better be sitting in this location owned by this entity. If they're not, you can't do business with us. Booz runs into this all the time. You can't even get a Department of Defense contract unless you adhere to their data housing requirements. So it is actually a thing, right? And even with it being connected, just because someone gets a window into your data doesn't mean they can copy it, right? It just means they can see it, right? And I know that sounds weird, but like there are ways of obfuscating the data so no one can copy it. Plus, if the servers are up on the internet, just because they're up on the internet doesn't mean you can't control how they're accessed, right? Right? Which is what we do with web services. So it's definitely, it's a valid thought. And just know that like it actually does matter to a lot of entities who are in that space. In the public sector, not so much, right? Doesn't really matter so much, right? They're like, they're like, hey, we're gonna house our servers over and wherever. They don't really care. But just to say this, there's the other considerations. If most of my customer base is in the US or in South America, I'm probably not going to host my servers in Tokyo. So outside of the legal compliances, there's also the latency compliance. Like, how well is this going to perform natively? Now, if most of my customers are in Japan, I better be in Tokyo. So that's the other reason they offer all the regions, is that, you're going to host it basically where your customers are. And if you need to go global, by the way, there's tools to make that happen, or you could go multi-region. Let's say that most of your customers are in Japan and the United States. You could be in Ohio and in Tokyo. So you could host them at, in both places. The other thing is just to say this, is that, is the service you're looking for available in the region? So for example, you might not go to Istanbul because Istanbul just launched and it doesn't have containers. It's going to have containers in 2 years, but it doesn't have containers right now. So you may not be able to launch in Istanbul because it may not have containers yet. Now that's unlikely, but maybe you're trying to use quantum computing. Istanbul doesn't have quantum computing. And the last reason, by the way, to choose your region, other than legal compliances, other than proximity to customers, other than is it too new to have the service that I want is pricing. So like Cordero, because like you mentioned this, you're like, I'm trying to keep an eye on the dollar, right? In every continent, unless there's only one service, there's always one region on the continent that is more expensive than the others. So in the United States, for example, California is a little bit of a joke because California is 20% more than any other region in the United States for the same unit of capacity. So for example, if I buy a terabyte of storage in any other region in the United States, it's going to be $23.44. If I do it on California, it's going to be like $26.55, which you like think, well, Michael, that's only like 15%. Who cares? Well, multiply that times 100, 100,000 terabytes. Next thing you know, you're like, right? That's a lot of money. 10 or 20% more is too much. So Cordero, you're thinking the right way, is that price does matter because there's always a region somewhere on every continent that's a little bit more expensive than the others. Like for example, Tokyo used to be more expensive than any other region in Asia. Germany used to be more expensive than Ireland and Milan and all the others. Proximity to customers, and then of course, legal compliances. Service availability typically isn't that high of a priority because most of the services that we use are not that fringe. But if you are looking for like quantum computing or augmented reality, please make sure it's available in the region you're deploying into. Because if you don't, it's gonna tell you it's not available if it's not there. Does that answer your question, Cordero?
Yes, thank you.
I know, good question. All right, other questions about why you would choose one region over the next? Okay. Now, one question no one asked me. Why would I run my services in two availability zones? Can one speculate with me? Why would I want to run with a load balancer, 2 web servers in 2 data centers? Why would I want to do that? Or maybe 2 databases that are replicating to each other, or 2 application servers. Why would I want to do that?
Redundancy.
That's right, redundancy. Straight and simple, high availability, redundancy. Because if one of those data centers goes down, which by the way, it will. Why? Because everything fails eventually. And it might fail for 5 seconds, it might fail for 50 minutes. But it will eventually fail given the course of time over like 3 to 5 years. There's going to be at least one small blip of an interruption. And if that really matters to you, then run your stuff over across 2 data centers. Best practice inside of Amazon is run your stuff across 2 availability zones. If it has a network card, run it across 2 availability zones. Okay. Notice here, by the way, they've got an instance running in US West 1A. It fails, and they just have another instance running in US West 2B. By the way, quiz question worth 1 billion points. What service is going to allow me to distribute load across those 2 availability zones?
Elastic load balancing.
Yes, Stanley, perfect. Which service, by the way, is going to allow me to scale more instances across those 2 availability zones? Ruben, I see it.
Auto
Go ahead,
scaling.
Auto scaling. There we go, Brian. Perfect. Yeah, so auto scaling, right? So just so you know, elastic load balancers look like they're a single device. They're actually virtual devices that exist across all availability zones inside of a region. Auto scaling is the same way. Auto scaling is going to scale your servers across all your availability zones that you specify. So just know, don't be fooled. You're going to think of load balancer as a single non-redundant networking device. You're not looking, this is not your data center. This is AWS land. Almost everything in AWS land looks like a single device, and it's actually 3. Why? Because they don't want you to go down. They want you to have a really good experience with their service.
I have a question.
Ask away, Eric.
You said availability zones are located tens of miles apart, correct?
Yes.
Okay. And you said you would have your network card and servers, I guess, in 2 availability zones for redundancy purposes, because eventually something will go down, whether it's for a minute or 50 minutes or whatever, right?
Right.
Okay. So what are the chances of a whole region going down? So my question is, you would have redundancy in one, you'd have set up in one zone A and zone set up in zone B. But if that region goes down, then you've lost both. Wouldn't you have a setup in one region and then maybe another region?
You
That's
can,
my question.
if the business requires it, yes, you will. If the business is like,
But,
look, we can't
how
go.
likely is it that a region would go down? That's my.
I'd like to tell you that in the 10 years I've worked with it, that no region has ever gone down, but AWS has gone down as a whole. Now, let me be clear. This was like 8 years ago. In the last 5 years, I can't think of a time that AWS has gone down as a whole. And I can't think of a time when a region has gone down in the last 5 years.
So
But
that's pretty unlikely, but it's more likely that a particular zone would go down, but not a region.
Well, what happens is that if Amazon sees a failure and that failure is cascading, they'll shut an availability zone down. So in order to prevent the region from going down, they'll drop an availability zone. I know they've done that at least once that I'm aware of, right? But I gotta tell you now, they've gotten so good at uptime that you'll see blips and you'll see like services get interrupted, but you won't see a region go down. And rarely do you see even an AZ go down now. But don't get me wrong, it happens. And I probably just jinxed AWS by even saying that.
I know.
Right? I'll be like, hey, guess what, Forrester? It's down right now. Right? Yeah. So just know, never say never, but it really depends on what the business needs. If the business is like, look, if they're maintaining 4 nines worth of uptime, then just run 2 servers. But if the business is like, no, I need 6 nines of uptime, yeah, you probably better run across 2 regions. But just to be clear, once you go from AZ to AZ, that's really fast networking. When you go region to region, it's still fast networking, but you could have tens of seconds of latency added to your network traversal, depending how far the other region is. Because in the United States, it's going to be nothing. If you decide to replicate to Tokyo and you're in the United States, that's going to be a little slower, right? So, and remember, when you start adding data replication into any architecture, it's going to get inordinately more complex. So just something to keep in mind. Let's see, Stanley, is there any data visualization that shows usage volume based on region? Not that I'm aware of. I don't think that Amazon publishes those numbers, but my answer is I don't know. So not that I'm aware of. That might be worth looking up, actually. Bear with me 1 second. Usage by volume. Yeah, I don't know the answer to that. I haven't seen that one. Okay. So what's the relationship between regions, availability zones? What goes inside of what? Who is inside of what in this particular case? Who's the macro and who's the micro?
AZ goes inside a region.
AZs go inside of regions. That's exactly right. Perfect. Okay, now let's say that Cordero and I are launching a business and he's like, okay, Michael, look, I don't want to run stuff in the United States because it's cheaper for me to run it, inside of, Hyderabad or Mumbai. I don't know if that's true, by the way, just made that up. And he's like, and plus that's where our users are. So, we've got a great service that's going to go over in India and Pakistan and that whole region. I'm like, okay, that sounds great. But then I'm like, well, hold on though. Right now our website's in the United States. And he's like, well, that's not going to work. So one, we could move our website over to Hyderabad, right? Over to Mumbai, either one of those 2 data centers. But let's say we also have a strong US contingent and we want to keep it here for other reasons. We could replicate the website over to those other systems, or we could actually create a copy of our website automatically and have it be hosted automatically by these, what we call edge servers that are scattered all over the globe under Amazon's network. And so what happens then is that now I've got a server or a copy that's closer to the users who are consuming it. Let me give you a more simplified example. Let's say I'm running my video company in Sao Paulo in Brazil. And I've got somebody in Russia who wants to watch my video. What's going to happen is that the first thing that's going to happen here is that the customer is going to have to go all the way over here to get the source. But if I turn on this product called CloudFront, here's what happens instead. Instead, they go to this edge server, which is an Amazon-owned server that the user gets redirected to the minute they request anything from Brazil. Then the server runs across Amazon's high-speed backbone, grabs the video file, brings a copy of the video file back to the server, and then serves that video file to the user. And then the next time another user over here or another user over here comes to grab this file, they only come here to get it. That's it. So if all of a sudden 1,000 users in Russia decide they want to see that video file, they don't go all the way back to Brazil. They go to the server that's in Russia that has a cached copy of that file. And you might say to me, but Michael, what if I update the video file? That's fine. What will happen is that when you update the video file, if you version it, the new version is what's going to display on your website. And so new users are going to go grab the new version that's going to be out there. If you don't version your files, by the way, then you're going to have to do something called busting the cache, which means you're going to have to go out to that server and say, by the way, this is no longer invalid. Or you can actually set something called a time to live that says, hey, you know what? Just expire it after 5 seconds. It's no longer valid after 5 seconds or 5 minutes or 5 hours. So you get to control how fresh that cache copy is by specifying a time to live, right? You can also force it to expire that cached file if you want to by sending a web header that says, hey, I only want a fresh copy of this file. So you get to control that through a number of different mechanisms. I think the longest you can keep a cached file is 36 hours, but I don't remember the exact number. They keep changing the upper limits on that.
So Michael, so we could say that the edge servers, they bring the source closer to the customer.
Mhm.
Is that always the case?
That's always the case. Their job is to
Okay.
reduce latency.
Okay, thank you.
And just so you know, you might say, well, where are these cache servers? They are all over the place. If I were to draw a line of every major ISP in the world, Amazon has put a caching server at every major ISP in the world. So every major ISP has caching servers. So if I were like to throw pepper on this map, if I had it as a piece of paper, that's probably where a caching server is. Actually, in one of our last classes, we actually had one of the installers for the edge servers from AWS was actually working for another company, and he was inside one of our classes. And I said, hey, is this, I know you can't talk about it. Is this accurate? He's like, that's accurate. He was like, we put them everywhere there's a major ISP. So anytime there's an internet service provider, Amazon puts either a server or a rack of servers to act as caches for this content delivery network. These are called edge locations.
So they're not within their data centers or availability zones?
No, they're actually in the ISP's data centers.
Okay.
Yeah. Now, don't get me wrong. They do have caching servers inside of their data centers, but most of these edge locations are actually in the ISP data centers. So they got a relationship with like Comcast and AT&T and all these people where they've put their servers in there. By the way, Netflix and a bunch of other content providers do the same thing. They actually stick servers inside the ISP so that they can bring the video files closer to you.
Do we know how many of these edge locations there are?
I think at last count, it was like north of 320, but not more than 400.
Okay.
Yeah. They don't, they kind of release a general number, but they keep adding and removing them all the time. So.
Okay, I see.
So this is a content delivery network. This concept, by the way, is not unique to Amazon, but CloudFront integrates really well with AWS, and you don't pay any exit data charges if you use CloudFront. If you use one of the other third parties like Fastly and Akamai and Cloudflare and all that, you're going to pay data charges. So just so you know, it behooves you to use CloudFront if possible, because as you can imagine, if you're copying a bunch of data outside of AWS's network out to other locations, you can pay a decent charge for that. Using CloudFront, they don't charge any data exit charges. Just so you know, Amazon does not charge you to stick data inside their networks, but when you pull it out, you pay a tiny fee per gigabyte, which can add up if you get to petabytes of transfer. Ramesh, did I answer your question about how to control the copy cache? Okay. I thought so. I just want to make sure. Yeah, I think 36 hours is the max, but by the way, if I ever quote numbers at you, just consider them to be lies. You probably want to read the documentation. And not because I'm trying to mislead you or that my memory is sometimes horrible. It's just because they change it all the time. So if I missed it in the latest update, I might be misquoting it. Okay. Okay, last few pieces before we break for lunch. So just know that if you don't want to run services inside of a region, inside of an availability zone, inside of a region, and you don't want to push content to the edge locations, which just to say this, that's usually a caching mechanism. So you don't really control where your data goes there per se. But if you want to run AWS's services in your data center, this is where the coffee shop and so imagine you got a factory, right? And you don't want people going all the way out to Starbucks. Although, sometimes getting out of the building clears the mind and all that. So what you do is you actually bring the coffee shop inside the place, like the factory. It's like, like a Walmart or whatever. It's like you've now put the coffee shop inside. Well, this is what Outpost is. Outpost is where Amazon gives you hardware pre-configured and built, and they install the whole thing for you based on whatever parameters you specified, and they run it in your data center. And you get to control it as if it's an extension of your public cloud, or you can run it independently and connect to it privately. So it can be air gapped. It doesn't have to be connected per se. Although I will tell you, you have to have a mechanism for connecting it occasionally so it can stay updated and connected, because it doesn't run really well air gapped. Just to throw that out there. Okay. That's called Outposts. I can't remember who their partner in crime is for that. I think it's their own proprietary hardware. It used to be Dell. I think they're using their own proprietary hardware now. This is called Outpost. So you run a stack of servers inside of your data center. They run things like EC2, S3, RDS. They run the standard services, but they don't run everything. There's only 7 services, if I remember correctly, that run inside of Outposts, which includes, by the way, the Elastic Container Service, EC2 virtual machines, S3, EBS. You have to look at the list, right? But it's not everything. It's just a few things. Okay. What is the #1 single word that will describe why you want to choose a region that is in proximity to your customers? Why do we want to do that? What does that matter?
Latency.
That's exactly right. Latency, right? You want your customers to have a good user experience. You want it to be fast as possible. Latency is going to be the thing that you want to solve by running your services closest to the customers who are going to pay you to consume them. Okay. So just a quick review. Here's Amazon's global infrastructure. There's a region. Inside of a region is availability zones, A, B, and C. And then know that there are edge locations at every major ISP on every continent except for Antarctica that basically house servers that Amazon uses for caching. Okay. That's it. That's the global infrastructure. Does anyone have any questions before we break for an hour for lunch?
Yeah, so like so within an availability zones, there could be like 1 or more data centers, right?
Correct.
And then so like I guess like within that there is also some sort of like redundancy that is being applied.
Not really. So the only thing that's redundant typically is that there's multiple data centers. They'll each have their own like independent power and cooling, but they might share an internet connection. Like one of the data centers might have an internet connection.
Oh, okay. I
Right?
see.
Because they wouldn't make that redundant because other availability zones have redundant connections. Now the
Okay.
interconnect between those availability zones might be redundant, but the internet connection might just be one data center. And so everybody's going to route to that data center to get access to the internet.
Okay, got it.
Yeah, but it's all low latency, Stanley. So you don't like performance wise, Amazon's really keen on latency. So we're talking about, sub 10-second response times, usually single digit, regardless of where you are in the availability zone.
Okay.
Good,
And
okay.
I have a question. What is the use of extend AWS infrastructure?
Wait, say that again, Ramesh.
Yeah, what is the use of extend AWS infrastructure on premises? Like, it's an AWS outpost.
Oh, what Outpost? Like, what is it used for?
Yeah.
So it's when you want to run Amazon's hardware, like inside your data center.
Oh,
So
okay.
the use case is that you can't use the public infrastructure, or you have workloads that actually have to run inside your data center for security reasons.
Oh, okay.
But you want to use AWS, that's not a problem. And so what happens is that you can actually bring hardware into your data center, but it's managed like by you as if it was AWS infrastructure.
Oh, okay.
Yeah.
Thank you.
So it's really a security or a licensing use case.
Oh, okay.
Yeah.
Thank you.
Good. Yeah, of course. Other questions? Okay, let's give it a clean 60 minutes. So currently it's 12:03. So I love odd times. So let's come back at 1:04. I'll put a timer up. Get away from your desk, grab lunch, get some water, get some fresh air, take in this winter time. And then we'll come back. We'll finish out with a little bit of connectivity stuff and we'll move on to networking and storage. Okay. So I'll see you in 60 minutes.
Great, thank you.
Absolutely. Welcome back, everybody. Okay. So here we are back after lunch. Excuse me. Okay. So we're going to cover this last section on how to connect with AWS services. But before we do that, who has any questions at all about EC2, regions, availability zones, edge locations, outposts, any of the topics we've covered thus far?
What's a container? No, just kidding.
What's the container? That's a good question. Docker's the answer. Okay. Okay, well, let's talk about this next section then. Okay, so I love these like analogs over here. So like in the coffee shop, we're probably gonna do a few things. We're probably gonna order a cup of coffee, ask for a refill. There's a reward system. We're gonna ask for a rewards balance, that kind of thing. Same actions, right? Is that I defined it as self-provisioned on-demand software-defined infrastructure, right? So, you can launch an instance, you can launch a load balancer, you could launch all that stuff at once. You can invoke a Lambda function, you could start a database. There's 3 ways though. There's only 3 ways to interact with AWS. One is through the web interface, which you saw me touching earlier when we were messing around with EC2. The other is with the command line. And so, here's command line options. So let's say that there's an AWS binary called AWS that you use to do things like you can launch instances, you can describe instances. And so in this case, you may remember that I had a box up there that was stopped called Triceratops on AWS. That's a bad DevOps pun. But I just ran a command that actually went and talked to AWS and told me what boxes I have running in Ohio. That's one of the ways to do it, actually. And the third way is to actually do it in code, where you can actually programmatically define, your objects like virtual machines, S3 buckets, You know, you can define it in code, actually. There's a lot of different ways to do that one. But Amazon uses an SDK, software development kit. It's basically an importable library of different code functions that you can use to talk to AWS. So just know that you have the management console, you've got the command line interface, and you've got importable libraries called software development kits that you can use to manipulate AWS in whatever way you want to. All three of these, by the way, are talking to the API or application programming interface that AWS exposes for this purpose. So AWS wants you to use their like contractual programmatic software interface. It's called an API. And these are the three vehicles by which you can do that. Now you've seen the console already because I showed you earlier when we were over here messing with Lambda, for example, or when we were touching EC2, right? You saw that this was the console. And so we just go in here, and the console, by the way, is great for like verifying things and maybe provisioning things that you're just messing around with. The console is not a great way to scale. If you want repeatable, reusable, like consistent infrastructure deployment, you're not going to use the console. You're either going to use the command line or you're going to use the software development kit, because both of those can be checked into a document that you can then share with other people. You can't do that with a command line. So there's a little demo of the management console, but you've already seen it. So no demo necessary per se. Okay, so here's a knowledge check to test your knowledge of the pre-lunch topics. Question number 1, which of the following is true for the AWS global infrastructure? Does an availability zone consist of a single region? Does an availability zone consist of 2 or more regions? Does a region consist of a single availability zone? Or does a region consist of 2 or more availability zones? Who sits inside of who? That's really the answer to this question. So the smallest unit sits inside the larger unit, right? So in this particular case, a region consists of 2 or more availability zones, because availability zones are the clusters of data centers, and a region is a cluster of clusters. It's a big cluster of data centers, right? So the region is the bigger unit. The availability zones sit inside the region. Remember our map. Okay. When you select a region, we talked about 4 factors, right? One of those 4 factors was costs, which is not listed here. What were 2 of the other 3 factors that we could have here? Because cost isn't listed here, and neither is service availability. Which 2 of these factors were options when selecting a region? So proximity to customers is 1, so that's dead on. Go ahead, Stanley.
Oh, A and B.
A and B, that's right. The other one was compliance with legalities, right? Whatever security or compliance restrictions you have, that's the other one. I was looking at the others for validity. Okay. All right, so then what best describes the CloudFront service, which I described has a way of doing globalization, to go global, right? So
D.
Yeah, good, D. I might have given it away when I said global. Right? So this is a content delivery service. A content delivery network or content delivery service is not unique to Amazon, but CloudFront is the premier service for that inside of AWS's ecosystem. By the way, what's a service that allows you to send and receive messages through software components through a queue? Which service is that?
SQS.
Good, SQS. All right, so what's the name of the serverless compute engine for containers?
Lambda.
Well, Lambda
no,
is a serverless engine. What's the one for containers?
The EKS.
Well, and that's the name of the Elastic Kubernetes service, but what's the serverless version? And Ruben, I see that you put that in there, Cordero as well.
Oh, Fargate. Okay.
Yeah, Fargate. Fargate is the serverless engine for containers, right? Now that gets a little confusing because just so you know, Lambda actually will accept Docker containers, but they're referring to EKS and ECS there. Okay, which is the service? So that service that allows you to run infrastructure like Amazon's infrastructure inside your data center in a hybrid cloud approach. What's the name of that service that allows you to take AWS hardware and run it on your data center?
Outpost.
Outposts. Yeah. Good.
It should be in post, but anyway.
In your data center. That makes sense, actually. We just need to hire a new head of marketing over at AWS. They actually haven't had one until just in the last year. All right. Which site does Amazon CloudFront use? Which kind of like unit does it use to copy content? It's not a region, although there are edge sites inside of region. It's not an availability zone, although there can be edge sites inside of an availability zone. I see that 2 of you posted it. It's the edge location. By the way, it's kind of sneaky that they put origin in there because that's what CloudFront calls the sources. When it copies something from, say, like an S3 bucket or a website, it says, what's the origin? Where do I get these files from? So that's really sneaky of them to do that. But technically the answer is an edge location. Okay. What actions can you perform with AWS Outposts? What would the marketing team say? Good, Donna, against your measure. I see that. It's like zip. C. It allows you to extend AWS infrastructure and services to your on-premise data center. Exactly. Okay. So in this module, our focus was to talk about the different pieces, the basically regions and availability zones and edge locations for AWS's global infrastructure, the 4 different factors around regions that you want to think about when choosing a location to host your data and services, the 3 ways to act with, interact with AWS, and of course a slew of little facts in between, right? Okay. Questions of any type as I'm transitioning over? Okay. Let's talk about networking at a very high level. So for those of you who are like, man, I really want to get into the bowels of IPv4 networking and do subnetting and all that stuff, no, we're gonna skim this topic because even people who have done this for decades forget this information. But we're going to talk about how AWS does networking so you can know how your virtual machines are, where they're going to run at. Okay, so we're going to talk about basic networking, how to connect AWS's networks to your data centers or corporate networks, kind of just some thoughts around how to do security in this kind of space, and just describe the services that like the customers use to interact with AWS as kind of global network. Now, in this picture, customers give their orders to a cashier who gives them to a barista. So suppose somebody tries to skip the line, like I'm gonna go straight to the barista. Like we don't want that, right? Because maybe that's a part of our flow, but it's back in, it's deep, and we don't want people like going, skipping our workflows, right? So how do we make that happen? How do we protect them? Well, the way we do that is that we kind of like wall off the barista. Like the barista is like behind glass, no one has access to him, he doesn't respond to queries. You can't talk to them directly. You talk to the barista talks to the, you talk to the cashier talks to the barista, right? Now in real life, we don't really do that, but you get an idea. So this is where Amazon's networking segment is called a virtual private cloud. This is where this comes in. This is an essential part of using AWS if you launch virtual machines, because this actually creates a networking segment or section inside of your account. So think of this as like the counter area that's only isolated to the cashier and the barista. Everybody else is outside this network, but if they want services, there's only a couple of key entry points, like the cashier area or the coffee serving area for exit, right? So VPCs are a way of you creating networks inside your AWS account. And these are macro networks. So think of these as networking pies, because you're going to create slices of these pies, and you're going to kind of like subdivide these pies into public pieces like the cashier station or private pieces like the barista station. So in this particular case, you're going to take this whole area and the cashier is open to the public, but the barista only jumps coffee off. That's it. So we can do this with AWS as well by creating what we call subnets. Subnets are just slices of VPCs. Now, all of us use subnets. How do I know that? Because your home network that we're zooming across right now is a subnetwork. It's a slice of a network. Which slice? Well, it depends on which router or cable modem you're using. But it's usually created for you, right? In our home networks, someone puts a router up. One side is the internet, the other side is our private home network, and that private home network is a subnetwork. So what's interesting about this is that our subnets, our networks are actually private. Like in all our homes, they're actually private networks. They're not actually out on the internet, thankfully, because the internet's not a safe place. So I wouldn't want my Windows box to be accessible from the internet because it would probably get hacked in about, I think last time we tested it was 37 seconds before your Windows box gets hacked if you stick it out on the internet. It doesn't matter what kind of software it has on it, by the way. 37 seconds on average for a Windows box to get hacked. It's a little bit higher for Mac and Linux, but it's not much higher. So just know, most of the time you want stuff on a private subnet, not a public subnet, right? And then let Amazon defend the public subnet. So in order for this to work, by the way, in our houses, our routers are typically connected to a cable modem, if you're using cable, or a DSL gateway or a fiber gateway. These are devices that act as internet gateways, and Amazon does the same thing. Inside your virtual private network, your VPC, you've got subnetworks, these slices of this network pie, and they have to talk to a central device to get out to the internet, and the internet has to talk through this central device to get to your networks. This is where, like your cable modem, your DSL gateways, your fiber gateways, this is where it sits in your home, and you have the exact same thing inside of AWS. And so that's what an internet gateway is for. This is a virtual device that connects your account's networks out to the internet and vice versa. Now, just because you're connected to the internet doesn't mean the internet can get to you. Amazon by default wraps a bunch of firewalls around everything. And you have to go in and open up those firewalls for you to be exposed to the internet. So one key difference is that when you launch a virtual machine, one of the questions that AWS asks you, it says, hey, do you want to expose this in some form or fashion to the internet? And if so, how? Do you want to do port 443? Do you want to do port 80? It asks you exactly how you, and do you want to expose it to the world or only to a certain number of people? So just know that just because you're exposed to the internet doesn't mean the internet can get to you. AWS has 2 firewalls in play at all times, one of which is always active. So let's say you created your VPCs, you've got an awesome subnet, you've got virtual machines sitting on that subnet, and you want to connect to your corporate data center because you've got an office and you got data in that office and you want to connect it to AWS. Well, one cool thing that you can do is you can create what's called a VPN connection over your internet connection. And it creates this private encrypted tunnel over public internet airwaves, if you will. And so VPNs are very common. And if you work for Booz, I know you know what a VPN is because you have to deal with one all the time in order to get access to corporate resources. And so you can actually VPN into AWS as well if you want to. And you can create all kinds of VPN connections in this case. Now, in order for this to work, you have to have a VPN capable router in your data center that can actually talk to a VPN endpoint called a virtual private gateway, which is listed right there. This creates an encrypted tunnel across the internet where all of your data is encrypted. And so even if someone captures it, unless they have the keys, they can't decrypt it. How do they get the keys? Well, they'd have to hack your system. And even then, if there's a passphrase on there, they have to have the keys and the passphrase.
The day program or evening?
So, yeah. So that allows you to connect your corporate network to AWS. Now, another way that you can do this is that you can actually run a physical cable from AWS to your data center. Now, to make sure that I'm clear on this, you actually don't see where AWS's data center is. You actually connect to one of AWS's partners. They know where the data center is, but you don't. And you run your cable to them, and they'll run the cable over to AWS. These come in 1, 10, and 100 gigabit sizes, and you can fractionate the 1 gigabit if you want to go lower. This, by the way, does not run over the internet. It is a dedicated cable. You get dedicated bandwidth. And it's not encrypted, so it's not necessarily more secure, but you can encrypt it if you want to encrypt data back and forth across the wire, right? So just know this is called Direct Connect, and this is for consistent bandwidth. If you use the VPN connection over the internet, the bandwidth may not be consistent because you're subject to internet weather. But here, bandwidth is consistent. Okay, let's do some matching just to like drive home what I just talked about. If I want to isolate my databases from the internet because they contain customers' personal information, because databases actually are not that great at defending themselves from attacks, generally, which should one be matched to, A, B, C, or D?
B.
Right, B. As a general rule of thumb, don't stick your databases on a public subnet. Don't stick them on the internet. They're going to get hacked. So that's good. So B is the right answer. Excellent. All right, if I want to create a VPN connection between the VPC and an internal corporate network, what do I need on AWS's side to connect to if I want to connect a VPN connection together? I need to string up. Yeah. So this is a VPN connection. So I'm going to need a virtual private gateway to make that work. Remember, the VPG is what's on the AWS side that connects to your VPN router on your network. So I'm going to need a virtual private gateway. Good. What if I want a publicly facing website that needs to be internet accessible? Good. See some answers there. It's a public subnet, right? Public subnet means public to the internet. So if I want to make one of those, typically I'm actually going to put a load balancer on the public subnet, and I'm going to put the web server on a private subnet. But if you just want to put the website out there on the internet, you got to put it on a public subnet. So that's the right answer. Now that leaves the last one, which is pretty self-explanatory. Dedicated connection with a physical wire between your data center and AWS's, that has to be a direct connect connection. Sometimes the shorthand, by the way, is a DX. Okay. All right, so that's just core networking, right? Public private subnets, internet gateway, and then externalizing that obviously to data centers. What about security? Let's talk about that. AWS has 2 firewalls inside their data centers. Let me talk about like how you manage these firewalls. 1, if you're a client connecting to a web browser, here's here's the interesting thing that's going to happen. 1, you are going to traverse from the client across the internet, and you're going to hit the internet gateway, right? And you're going to hit all of these other different pieces. So packet comes in, hits the internet gateway, and then what happens is that it hits the first AWS firewall, which is known as a network access control list. This firewall actually sits around the subnet. So if this subnet firewall says nobody can come in, all traffic is blocked. By default, all traffic is allowed, right? Because Amazon wants you to be very intentional. Whoops, that's not what I wanted. AWS wants you to be very intentional about how you set these things up. So by default, all traffic is allowed for this. Okay. So a NACL for by default in an account is not turned on. First thing to remember. Now, after this, so network access virtual firewall, this is a stateless, by the way, firewall. And it again, it wraps around the subnet, around the network, the subnetwork, if you will. Not around a host, not around a virtual machine, but around the network. Now, this is a stateless firewall, which means it has to check its rules list if you want to talk or if you want to respond to someone talking to you. You got to have rules for both. If you do not have a rule for both entering and responding, you can't respond. I know that sounds weird, but with stateless firewalls, you have to have two rules, one to receive communication and one to respond to communication. Just remember that. Now, this is a contrast from the other firewall, which is called a security group. A security group is a stateful firewall, and anything that has a network card typically has a security group on it. Security groups, unlike network access control lists, network access control lists can both allow and deny traffic. Security groups can only allow traffic. They can either allow you to come in or they can allow you to go out, but they can't block specific IP addresses. It's either all or nothing. You're either allowing the traffic in by a specific IP address or you're just not, right? So it's not like you can say, look, I want to allow everybody except for this, this, and this, and this, right? All you can do is say, I only want to allow this, this, and this. You can't deny this, this, and this. So security groups are a little different in that they only allow traffic in, but you can be specific about who you allow. You just can't deny any traffic. Now, security groups are also a little different in that if you want to respond to traffic that you've initiated, security groups are stateful, which means they track all the connections. So if I'm talking to Cordero and he has a rule that says Michael can talk to me, it's assumed that Cordero can respond if I ask him a question. With a network access control list, unless Cordero says, not only can I receive communications from Michael, but I can talk to Michael, unless he has those two rules, a network access control list, which it won't work. So security groups only need one rule for bidirectional communication. Network access control list, the previous firewall, needs two rules for bidirectional communication. And just so we're clear, 99% of traffic is bidirectional. It's in both directions. And since the security group is a stateful firewall, it's gonna allow someone to respond if someone initiates conversation. So it only needs, again, one rule for bidirectional communication. So security groups, remember, wrap around a NIC, a network card, whereas like network access control lists wrap around a network. So two firewalls, and by default, the stateful firewall, the security group, is turned on to prevent all inbound traffic from the internet. Let me say that again in case you missed that. Network access control lists are turned off by default, but security groups are turned on by default, and they do not allow the internet to get to anything you launch, even if that thing is on a public subnet. So security groups by default defend your hosts, and they're on by default. So if you're following the traffic flow that we were looking at earlier, what happens is that a packet comes in, goes to the internet gateway, passes the internet firewall, the network access control list, then it has to come inside the subnet, get past the security group to hit the instance. So just know that the security group is on by default and the network access control list is off by default. All right, so based on what I just said, someone tell me one difference between the network access control list firewalls and the security group firewalls.
One is stateless and
What
the
it
other one is
protects.
stateful.
Good. Brian, you also said something. What were we going to say?
What it protects, the NIC versus the host?
Close. So the NIC is actually part of the host. What's the other thing?
Oh, I'm sorry. The subnet.
Exactly. So NACLs protect subnets, security groups protect NICs inside of those subnets, right? So that's how they work together. So you're dead on there. Good. So network access control lists are virtual firewalls for subnets. They perform stateless packet filtering, which is what the two of you said. And then security groups are virtual firewalls that are attached to NICs, which mainly is EC2 instances. But just know if you put a NIC somewhere else, it also has a security group around it. They perform stateful packet filtering. Good. Good. So just forget, at the very minimum, there's always two firewalls that can be turned on at any point in time with your virtual machines. You can turn on more, actually, if you want to. There's web application firewalls. You can turn on distributed denial of service filters. There's other firewalls you can turn on, but those are the two defaults. Okay. Any questions about the two core firewalls? All right. Let's then talk about basically interacting with AWS's global network. Okay, so you may know this, but when you type in www.amazon.com into your web browser, that resolves to a series of numbers, computer addresses that computers use to talk to each other because they don't use the names, right? That's for us. The DNS service's job is to resolve those names into computer IP addresses, networking IP addresses. So what happens is that when a customer says, I want to go to Amazon.com, and let's say I'm on Xfinity, right, formerly known as Comcast, there's an Xfinity DNS server right outside my network, and it goes and it talks to the root servers, which then talk to Amazon.com, and it says, hey, where is www? Because Michael wants to get there. And so what happens is that the company DNS server sends a response back to the customer DNS resolver and says, oh, you're looking for this? It's located here at 192.0.2.0, which is not a legitimate. Well, actually, it is a legitimate IP address, but we're going to skip over that. And so what happens is then that gets returned back to my browser. This happens all within milliseconds, by the way. And so then my computer is like, oh, I'll go talk to the web servers or the load balancer, actually, in this case, here, and I'm going to get access to the www.amazon.com. So Amazon has their own DNS service, and it's called Route 53. Can someone tell me why they called it Route 53 instead of Route 66? Anyone ever run their own DNS server before? That's right, Kendra. DNS runs over a networking port 53, which is why they named it Route 53 instead of Route 66. This is what happens, by the way, when you let geeks name things. Sometimes cool, sometimes not. By the way, the Route 53 is the only service that I know of with AWS that has 100% SLA. Not many of the services, by the way, have SLAs as far as uptime goes, but this one has an SLA of 100%, because if DNS goes down across the internet, guess what? The internet's down, even though it's really not, but it's down because nobody can find it. So, yeah. Okay, now Route 53, which is a DNS service, and CloudFront work together. Because one thing nobody asked me earlier is that, hey, if this person is in Russia and you turn on CloudFront, how does this person know how to find the edge server that's located in, Uzbekistan or whatever? How does that happen? Well, AWS turns on DNS, so wherever a user is in the world, whatever edge server is closest to them is the one that they're going to get redirected to, and they do that through DNS. It does something called geo proximity or geo latency. Which one is the closest to me? Redirect my www.amazon.com session to that system instead of going all the way back to Virginia. Okay. So Route 53 and CloudFront work together to point to things like load balancers, which in turn point to multiple backend servers. So Route 53 is going to intercept any lookups and redirect the user's browser to the closest CloudFront edge server it can find. Any questions about Route 53 as a DNS server or any of the prior pieces that we talked about? Network access control lists, security groups, etc.
So Route 53 service might be hosted in a different region, but that communication is quick because it's just a DNS lookup.
Yeah, their Route 53, from what I can tell, is actually hosted in every single data center, every availability zone, and every single edge location. So from what I've seen, Kendra, they actually are hosting DNS at every single location they can.
Okay, got it.
Yeah, it's all over the place. So, and if I had to offer 100% SLA, I'd probably do the same thing, actually. But yeah, it's all over. And every single location, I think they host servers. Amazon has a DNS server sitting there. And by the way, maybe this is worth knowing, is that when you start a network, like a VPC network with a subnet on it, Amazon automatically puts a DNS resolver on that network for you. It's why they take one of the IP addresses when you start a subnet. They take 5 actually, but only 3 of them are used by them. So just know that when you start a network, they also put a DNS server in there as well. You can't see the server, but you can access the resolution. Okay. Other questions, comments, soliloquies? No? Might be a little post-lunch food coma going on. Let's hope not, because we've got more knowledge checks. They're coming down the pipe, right? We're doing, imaginary prizes for these. Just your pride, self-respect, dignity, that kind of thing. All right. Which component or service can be used to establish a private dedicated connection between a company's data center and AWS?
Direct connect.
Direct connect. What's missing? What's the other one that you could use? No, I mean, this is Booze's holy grail. It's how you are all connected to the corporate network.
The VPN, the virtual private gateway.
Exactly. Good. Perfect, Stanley. And then you added the endpoint, right, as well, the virtual private gateway. That's excellent. Absolutely on the mark. No, Kendra, Outpost is used when you want to run Amazon servers inside your data center. So, which I don't think it has a VPN connection. Wish it should, oddly enough, but another time. All right, so direct connect is the right answer for this one, but VPN with a virtual private gateway is the right answer for the other one. Okay, this one's going to try and trick you. Kind of like the exam, actually. Which statement describes security groups? Are they stateful or stateless? And by default, do they allow all inbound connections or do they deny all inbound connections? Which of these are true?
They deny all inbound connection.
True. Are they stateful or stateless?
They are stateful. Yeah,
that's right. They're stateful. So security groups are stateful and deny all inbound connections by default. Now, if you want to know what NACLs do, just reverse that entire statement. Matter of fact, if you want to look at it, C would be right for network access control lists. They are stateless and they allow all inbound traffic by default unless you change them. Excellent. Okay. Which component is used to connect a VPC to the internet? Not a VPN, a VPC network. How do we connect a public subnet in a VPC to the internet? Good. An internet gateway. Something to be mindful of. I have tried to overpower an internet gateway with like gigabits of bandwidth, and I have not been successful. So those things have like terabit connections or something ridiculous. It's just, they're like super big pipes to the internet. It's amazing. So internet gateway. Okay. Which service is used to manage DNS records for domain names or just host DNS in general for AWS? Which one is it?
Route 53.
That's right. It's not Route 66, it's Route 53. Okay. Okay. Maybe the last question. Which statement describes DNS resolution? What is the purpose of DNS? Why do we care about domain name system resolution? Because we got to have a way for us human beings to remember these computer numbers. And we do that by having these really simple names like Amazon.com or Tesla.com, whatever, right? So D is definitely the right answer. Excellent. Does anybody have any questions about anything that we talked about in this module? All right. Let's keep going then. So we just covered some fundamentals of networking. VPCs, subnets, internet gateways, network access control lists, security groups, DNS, right? How that functions. So let's talk about data. It's like Sherlock Holmes, data, data, data. We cannot make bricks without clay. Remember, data is the new oil. And while we're not talking about machine learning and artificial intelligence rely on data storage and data stores to function. Who's going to set those up? Well, we are. Right? So let's talk about that a little bit. By the way, is it a new phrase? Data is the new oil. I don't know who came up with that, but it's true. Okay. So we're going to talk about hard drive services and we're going to talk about external storage systems. That's really the two things we're going to talk about. And then we're going to talk about database applications. So your traditional SQL-based data stores and your now pretty ubiquitous NoSQL data stores. So we're going to talk about the different ways that you can store data on a system and the different ways you can store data in a structured application. That's what we're going to talk about. So, storage. Okay. So think about block storage like the USB drive or hard drive that you have stuck on your laptop or attached to your system. That's just a hard drive. Now in AWS land, it's over the network, but it doesn't matter. It's direct attached. File storage just means that it's like a block device. So it's like a hard drive, but it's on somebody else's server, and that server is allowing you to connect to it. So you can actually mount it inside of an operating system. Both block storage and file storage are ways of presenting directories that mount as a drive letter or a mount point inside of your operating system, no matter what you're running. If you're running Windows, it shows up as a drive letter. If you are running Linux, it's a mount point that you specify. If you're running Mac OS, it's the same thing. Object storage is a little weird because for those of you who remember FTP servers, object storage is more like an FTP server. It's not really meant to be mounted inside of your operating system, but you use commands to like FTP or push to what's called S3, which is the simple storage service. So let's talk about these three in a little bit more detail and a little bit more granularity. Block storage means that you are storing files in these block-sized chunks, and it's usually on a hard drive. AWS has only one block storage service, and it's called the Elastic Block Service, EBS, right? Now, you may remember earlier is that I referred to EBS when we were messing around with this website and we were on ec2instances.info, and I said, don't use systems that have this NVMe, like it has storage listed here. If it says EBS only, that's what you want to use, is you want to use the Elastic Block Store service. EBS is what that service is. This allows you to create hard drives up to 16 terabytes per hard drive that you can attach to your virtual machines. But you're like, Michael, then why do they have 150 gigabytes of SSD backed storage for free on this system? It's just there for caching purposes. Doesn't necessarily mean anything. So that's block storage, where you're basically attaching a hard drive. EBS is the service for that. But we saw earlier that some of these systems have what's called instant storage attached to it. What did I say was the big problem about instant storage? Does anybody remember? What's the issue with instant storage?
Temporary.
That's right. If that system fails, that data is going to get wiped. And I can explain why that is, but basically it's because that hard drive only exists on that physical host. If that virtual machine gets restarted on another host, it no longer has access to those hard drives. Data's gone. Don't write Amazon. They can't get it back either, right? Data's wiped. So just know that if you have an option to use instant storage, if you just want to use it as a scratch volume, great. If you want to store data on it that you expect to be permanent, no, don't do that. All right. If you want permanent data storage, then you're going to use EBS. Hands down, that's the way to do it. You might say, well, Michael, why do they have instant storage? You know, honestly, I don't really know, frankly. I think they're moving away from it, but sometimes they make moves that fool me. Now with an EBS volume, EBS, since it's its own data service, you can attach it to an EC2 virtual machine. You can take it off of an EC2 virtual machine and put it onto another EC2 virtual machine. Here's the catch. Virtual machines and EBS volumes are tied to one and only one availability zone. Let me say that again, in case you missed that. EBS volumes and EC2 virtual machines can only run in one availability zone because that's a data center. You've ever heard of virtual machines running in two places at once? No. Neither do their hard drives. So if you have an EC2 instance and you want to attach a hard drive to it and it's in the first availability zone of Virginia, then that's where it's going to live until you decide to copy it or migrate it. You might say, Michael, how do I copy a hard drive? Well, AWS calls those snapshots. So snapshots, by the way, are basically incremental backups. It's an incremental backup, meaning it just takes what's changed, but it keeps all the previous backups in order to build a full picture of a disk. So notice that day one, only the green got copied in. Day two, purple did. Day three, blue got copied in. So every time I took a backup, it made a copy of what changed. So just know that snapshots can also be copied up at a regional level and then copied to another region if you want to. So while EBS volumes are availability zone specific, these snapshots are regionally available and can be copied to other regions if you want to automate your replication of sensitive data. So you've got options here on how to use these EBS snapshots, but you can also, by the way, set up a policy to just take a snapshot of your hard drives. Okay, so what's the one difference, the one key difference between instant stores and EBS volumes?
Temporarity.
Wait, say that again, Stanley, did you say priority?
No, temporarity. Temporarity. I don't know if that's a word, but yeah.
You know what? It's now a word. So temporary. Yeah, I got it. Right.
Yeah.
How ephemeral it is, right? How persistent it is. Yeah. So that's the difference. So instant stores are made for temporary data. EBS volumes are made for permanence. Hopefully that says the same thing. I'm just not making stuff up over here. Okay, that was block storage. That works no different than your hard drive inside of your laptop, desktop. The only difference, by the way, I just want to say this. you know, they don't really talk about this in Cloud Practitioner a lot, but just so you know, these EBS hard drives, they are ridiculously fast. Like unbelievably fast. For example, they've got 4 flavors of hard drives and they just added a 5th. They just released, it's called Block Express. That hard drive, a single volume, just one disk, can do 256,000 IOPS a second. So IO per second. You're like, well, I don't know what that means, Michael. It basically means that 256,000 times a second, you could either write or read 256K kilobytes of information. So that's really fast. So just know that while we're not getting into the details about how fast the volumes are and all that other stuff, that EBS volumes have a lot of like depth to them as far as like their variety. And there's now 5 major types, 3 of which are probably the most frequently used. So in contrast, let's talk about object storage. So unlike block storage, which is direct attach, object storage is like a remote storage system. You don't mount it inside of your operating system. You just push files to it and you pull files off of it. This is just like FTP, by the way, except way better because this is all API driven. And just to say this, the service that does FTP, I'm sorry, that does this actually has an FTP option. You know, the simple storage service S3. This actually has an FTP option, which cracks me up because I thought FTP was dead, but apparently we're still using it. So, because I used FTP back in the 90s, so I just assumed it went away. People were using FTP back in the 70s. Or was it the 80s? I think 80s, right? S3 is the simple storage service, and this is where you push files and pull files, and everything gets web enabled if you want it to be web enabled. Now, S3 is a great location to store just broad swaths of files. You want to put 100,000 log files and you need to keep them. You're going to zip them up and store them out by date. This is a great place. You want to keep, 100,000 image files or video files. You want to just store them out there. This is a great place. This is what S3 is designed for. Now, it has, if my memory serves, 6 storage classes. So it's got standard, which is like hot storage. It's got colder storage called standard and frequent access. It's got less redundant colder storage called one zone and frequent access. And then it has 3 more. So it has intelligent tiering, which is where stuff just kind of moves around automatically. It's got S3 Glacier, which is archival storage. And it's got S3 Glacier Deep Archive, which is even colder archival storage. So be aware that of all these classes that you have access to, intelligent tiering is the one that's the best for like workloads that you don't really know exactly how they're going to do. Because intelligent tiering, what it does is it looks at your access pattern for a file. And if it sees that that file is really busy, it's going to keep it on S3 standard. But if intelligent tiering sees that that file stops getting accessed, and after like, let's say 90 days, it's going to move it into infrequent access. And if it hasn't been touched in like 180 days, it's going to move it to Glacier. Or it might even move it to Deep Archive. So intelligent tiering, unlike the other types of like storage classes inside of S3, intelligent tiering will move files around for you based on whatever limiters you put in place. A word of caution here, Glacier is an archival service. So if you put a file into Glacier, it's not going to be directly accessible until you pull it into S3. So you're going to pull it into one of these S3 types once you put it inside Glacier or Glacier Deep Archive. By the way, by default, Glacier and Glacier Deep Archive will restore files encrypted back to S3. So when it restores files, it'll kick them back to S3 for pickup. Okay. All right, let's do a little knowledge check on this one. You want to store data that is infrequently accessed, but must be immediately available when needed. Which of the storage classes here makes sense for that? Which of the storage classes here are perfect for infrequent access?
One of the
Intel,
IA.
Yeah,
not the
right.
Glacier,
Wait, say that again, Brian.
not the Glacier.
Not Glacier. Yeah, because it's got to be immediately available, and Glacier just sticks it into a vault and says, let me know if you want it, and I'll go get it for you. Right. So yeah, definitely C. So perfect. Which one of these types here did I say is going to actually move your file around based on its access pattern?
Intelligent tiering.
Yeah, intelligent tiering. That's
Ditto.
kind of the oddball out of all these. It uses machine learning to move things around based on how it's accessed. By the way, if it makes a mistake and sticks something in cold storage that needs to be pulled out and therefore it's got to be expedited, you don't pay any expedition fees. So you don't pay any fees if it makes a mistake. So if you don't know what your access pattern is and you want to have data classified and archived and whatnot, intelligent tiering is a great tool.
So real quick with intelligent tiering, do you have a choice of B, C, and D or just B and D?
So if you use intelligent tiering, you do actually get to set parameters and say, look, I don't want you to use this class of storage. So you
Right.
can't actually control like what storage it will use to move things around. In some cases, it'll even ask you to train it and say, hey, do you want me to do this at 90 days or 180 days? What would you like for me to do? Right. So you can even set some breakpoints in many
You can
cases.
set that part. Okay. All right.
Yeah. Yeah. And it'll just do it for you. But you can also just fire and forget if you just like, hey, just do it. And Amazon will use its own rules. And in the documentation for intelligent tiering, it'll tell you what its breakpoints are, which I believe it's 30 days for infrequent access, 90 days for Glacier, and then 180 days for Deep Archive. So again, I just told you numbers, so consider all those lies until you look at the documentation. But that's what they were the last time I looked at them. Good. Okay, so we just talked about object storage, which is a non-mountable remote system. This is where things get a little strange because this is a mountable remote system, meaning this is on another server, but this one you can actually mount inside your operating system, whereas with S3, that actually just sits somewhere else. You can't mount S3 inside a file system. And don't get me wrong, people have tried and they do it and it performs horribly. File storage is a remote system that's actually designed to be mounted as a drive letter or has a directory underneath your file system. Now, we've been using these for 20 years. We've had what's called NFS and SMB, which is built for Windows. NFS is for Linux. We've had these for 20 or 30 years now. So these are just your file servers. They just share drive letters. They share files out to your operating system. So we're used to this. And so Amazon, unfortunately, has two really great services for this. And there's a little bit of overlap for them. I say unfortunately. It's great that they have the services, but then sometimes the naming convention is a little weird. So first, there's EFS, which is a great scalable file system. It is designed for Linux. This is NFS version 4.1. Now, here's the funky thing about EFS that's different than EBS, which is the block storage service, right? EFS will run across an entire region, whereas EBS can only sit in one and only one availability zone per hard drive. So what's cool about EFS is that if you want to share a file system with 1,000 servers across an entire region, just one region, by the way, not cross region, intra region, EFS will do that. EFS will let you 1,000 servers mount the exact same directory into their file system. So when you make a change to that file system, it goes out to 1,000 servers, not a copy. They see it in real time. So EFS is a really great tool when you need to create multiple copies of the same file system and get it across a bunch of servers. Now, they don't have this in the slides, but the name of the service that does this for Windows is called FSX. And I spelled that intentionally with a lowercase x. So they have FSX for Windows Server. They have FSX for Lustre, which is a high performance file system. And they have FSX for ONTAP, which is an older networking product called NetApp, right? This does show up on the exam on occasion. The Windows Server one does. So just telling you, not for giggles, just so you can know that if they say, hey, I need a mountable network file system for Windows file sharing, your answer is going to be FSX for Windows Server.
That's
They say-
Foxtrot Sierra X-ray.
Foxtrot Sierra X-ray. Yes, and it should be
Okay.
in chat.
Thank you.
So EFS for Linux, FSX for Windows. Main things to remember. Okay, so that's block storage. Sorry, that's not block storage. That's file storage. So that's a remote block storage, like a remote mountable storage. So let me just go back to the beginning for just a second before we talk databases, because I just want to make sure this is clear. These were the three types we talked about. Block storage is directly mountable into your operating system. It looks like a hard drive. That's EBS. Object storage is a remote storage system that is not mountable inside of your operating system. That's S3. And then file storage, which is a remote mountable system, is EFS or FSX. So one is for Linux, one is for Windows. So those are the storage services. This is, by the way, if you want to put a file somewhere. That's what these storage systems are for. You want to put a file somewhere, like a Word document, a video file, whatever. Now contrast this, by the way, with what we're about to talk about next, which is databases, which are applications that are designed to store data. Before we get into this, does anyone have any questions?
Yeah, I mean, do you generally use a combination of those storage solutions, and what's the cost differences?
Oh, that's a great question, Greg. So
I was paying
take a look.
attention.
Thinking ahead, sounds like.
Yes.
Yeah. So block storage is generally the most expensive because it's got a one-to-one relationship between the operating system it's attached to and the disk. So think of it as like almost like an elite one-to-one relationship between the data. And so it's going to be very highly performant. The next most expensive, I'm sorry, the next cheapest, sorry, not the next most expensive, is actually going to be file storage. File storage, pound for pound is not as expensive as block storage, but it's also not necessarily as fast either. Because there's one file system shared across the network with multiple servers. And so there's no dedication there. And so it can actually get fast, but it's not as fast as just having a disk, which is what block storage is. So file storage is a little cheaper, but is also a little less performant. Object storage is by far the cheapest of the three options here for storage. And 1 terabyte of storage will cost you $23 a month. With block storage, I think 1 terabyte of storage will cost you, I want to say it's like $45 or $50 a month. So it's actually a lot more. With file storage, 1 terabyte of storage, and by the way, there's a lot of factors that vary these costs, but 1 terabyte of storage on file storage is about $39, $40, right? So not much cheaper than object storage. Object storage, just to say this, like I said, is designed for hundreds, if not thousands, if not millions of files that you are copying up there. File storage and block storage are really just for operating systems. So when people want to create a data lake, for example, or they want to dump log files, or they want to dump a bunch of images or a bunch of videos, that's all going to be on object storage because it is the cheapest of the storages to use. So. When would you use S3 versus EFS? So Kendra, if you needed to mount something inside of a file system, like inside of an operating system, you have to use EFS, and you wanted it shared across the entire thing. If you were okay just programmatically sending something, like sending a file and retrieving a file, then S3 is going to be your primary use case. Security wise, you know, it just depends on your security parameters. They're about the same as far as security goes. But as far as programmability, S3 has far more flexibility from a programmability standpoint than EFS does. And it's also cheaper. Excellent. Good questions. All right, we're going to go for a little bit longer and then we're going to take a break. Okay. Here we are. We talk about databases. Now, databases in AWS world come in about 19 different flavors, but here's the cool thing about database technologies in AWS. All of them, with almost except like, I think 2 notable exceptions, are copies of open source software. Now, Amazon would be like, oh, no, you did not. No, it is true, actually. It is true. They typically copy open source software and make it into a service, which is a great business model because it makes it easier for us to run the software because we could just spin up a service. Now, that being said, I'm going to talk about at least one service today that Amazon wrote on their own, right? And there's many. And I make that sound trivial. Amazon didn't do anything wrong. I'm just saying is that they took a great idea. We have all these open source projects, but guess what? That's free as in puppy, not free as in beer. But that's a phrase that I borrowed. So if you don't like beer, I'm sorry, replace it with something else. Meaning that, you know, when you get a puppy, you got to take care of it. You got to learn how to train it. We get this open source software and we're like, oh my gosh, running Kafka is harder than I thought it would be. Running Kubernetes is harder than I thought it would be. Amazon's job is to make your infrastructure life easier. So, you know, if you don't want to spend weeks of your life learning how to run Kubernetes, you just go spin Kubernetes up, right? You don't want to learn how to run MySQL or Postgres or whatever, just go spin it up. That's what they're trying to accomplish. So, yeah. Now, that being said, around databases, there's 2 types of databases that Amazon generally categorizes, right? There's the relational database, which has been around since like the 70s, right? And this is where we have structured data that has rows and columns, and there's like a relationship, and we got multiple tables, and the tables all have relationships. And then we have non-relational databases, which basically just have like a search key, like an organizing key. And then when you hit that key, you just get a blob of data back. You just get a bunch of data. So relational databases tend to follow this model, right? You've got like, you know, a column, which has like product name and then size and then price. You got these IDs. And so in a relational database, the data is stored in a way that it relates to other pieces of data. So like you could have a table that has a bunch of users in it, and then another table that has that user's specific information, including their address, other pieces like that. Relational databases almost always use structured query language, which is SQL, which is not really like a full featured programming language per se, although some people have made tremendous enhancements to it. But it's a language that can be used to extract structured data, structured responses from structured data. Now, these have been around forever, which doesn't mean they're not useful. Just to say this, relational databases are still an incredibly strong foundational element for any data strategy. Still remarkably front and center, right? And they've been evolving. So it's not like just because they're 40 or 50 years old, they haven't been evolving. They have. Now, Amazon has a service called the Relational Database Service. Its job is to make it easier for you to run your databases, because that's what Amazon wants to do. Here are the flavors. Now, if you live in this world, you're kind of like, well, hold on, Michael, you just told me that it was open source and Oracle and Microsoft are not open source. Yeah, I know. I'm sorry. I wasn't trying to mislead you. Oracle and Microsoft are obviously proprietary. And Aurora is actually something they made up. But the rest of these are open source. So PostgreSQL, MySQL, Did I just say Postgres SQL? People just call it Postgres. So Postgres, MySQL, and MariaDB are all open source products. So just know that if you're like, hey, I want a Postgres database, you're probably going to use RDS. Here's a catch, by the way. So RDS is not serverless. So just know, remember how I was showing you this eVantage site earlier that allows you to pick your EC2 instances? I want you to take your eyes and scroll it on up to right here. See that little section that says RDS? If we click on that, assuming that I can get to a mouse, if we click on RDS, just know that when you start an RDS database, it launches these kind of faux EC2 instances underneath it to give you the size of the processor and memory. You can't log into these EC2 instances. You can't even see them into your console. So just know though that RDS sizes data, like as far as memory and CPU, not the actual disks themselves. It sizes it off these little database t-shirt sizes. So notice if you're like, hey, Michael, earlier we were talking about getting a 512 gig database. If you want to run that in RDS instead of EC2, that's the, these are the different sizes that you could possibly use, for example. So just know that even though you can't log into the EC2 instance, there's a fake EC2 instance whenever you launch an RDS instance, like a database, that Amazon uses to capacitize these things. So this tab is here so you can actually t-shirt size your RDS instances. So just be mindful of that. So you want a database. So you don't necessarily want a proprietary database. So you're not going to use Oracle or Microsoft. Let's say you want to use Postgres or MySQL. But these technologies have been around for a long time. And so someone needed to make them and update them for cloud so they could actually run faster in the cloud, because they weren't designed for that. They were designed when Big Iron was around, right? So Amazon decided to take on this challenge. And so they created a product called Aurora. Now, Aurora is a subset of RDS. And what it is that if you take a MySQL database or a Postgres database and you have a standard version and you create an Aurora compatible clone with the same data, same queries, everything, Aurora will be 3 to 5 times faster than your standard Postgres or standard MySQL databases. So just know that Aurora is a cloud-enabled version of both Postgres and MySQL. So Aurora is not a different flavor of database. It's a variant, if you will, of Postgres and MySQL. And just so you're forewarned, Aurora does have a serverless version, which has no servers. It does not use EC2 as this underlying thing. But you can also just run Aurora like you run the rest of RDS. It has EC2 instances underneath it. Aurora, by the way, is a spectacular cloud-enabled database. If you're looking to run MySQL or Postgres and you're in AWS, I highly recommend that you look at running Aurora, because it's going to blow your doors off how it functions. It really is really cool, both in replication, speed, backups. It's a much different beast. So just know that it's there. And it is, like I said, a subproduct of RDS. So don't let people tell you it's a different product. It's not. It's just like Fargate. Fargate is a subproduct of ECS and EKS. Aurora is a subproduct of RDS. Okay. So here's a little discussion. One of the employees at the coffee shop is like, we're going to come up with a new inventory management system, and they want to put it into a text file on Amazon S3, which is a remote storage system. Do you think this is a good idea? And if you don't, tell me why it's a bad idea. Or tell me why it's a good idea. Tell me why you think this might work well.
It could be queryable.
It might not take up active resources. It's there when you need to research something.
Okay. You
I don't
said,
think, but I don't think it'll work.
okay. Now, someone said it would be queryable. Is that correct? Did I hear that correctly?
Yes, you could search for terms in it.
Using what?
Basic. Like say it was a text, well, that's available in a TXT, what do you call that? Notepad or,
Or Word or whatever, right?
yeah,
You could just pull it down and then search the file.
yeah.
It'd be
What
good
if,
for
go ahead, Eric,
archive.
you're gonna say something.
archives or something like that.
What if 3 people were working on the file at the same time and they all had 3 separate copies?
Race conflict.
That's right. That's actually what database applications do for us, right? Is they resolve contention, conflict. So S3 is great for storing data. It's not great for like massaging, analyzing, or transacting data, right? So S3 won't really work here because first of all, what if 2 or 3 people want to update inventory at the same time? It's almost like the old like file locks. You're gonna pull the file out, lock it, make your update, and then push it, right? In a database application, like this is a relational database, you would just submit your thing. And if 2 of you made changes at the same time, quite frankly, whoever made the last change would win, right? So, and if there was a conflict that couldn't resolve, it probably would let somebody know, but databases are great at resolving that kind of thing, right? So S3 is not great for shared data sets that need to be like written to or changed by multiple groups, you know, in some kind of like sequential order. But S3 might be a great place to store the export or reports on inventory data. So, but again, it depends on your use case. A text file might work fine if there's only one person editing it. Otherwise, honestly, it probably needs to be into some kind of structured application of some type. Now, we just talked about relational databases. Let's talk about non-relational databases. So these started coming out like 2001, 2, 3, that kind of thing. And then you started to see them everywhere starting in like 2010, 11, 12. I remember administering my first React database, which React is an open source analog to Amazon's DynamoDB, which is what we're about to talk about. Now, what happens here is these are key value stores, which means someone says, hey, I want to search for, you know, where, you know, the key equals Prince, because that's what we did is we did it by artist. And what it returns is all of the values where the key equals Prince, right? Now, that's not a great example because Prince is really not a unique key. But what if you created a composite key between artist and song? And then it returned all the attributes of the artist and the song in question. So here the key is like 1, 2, 3, 4, 5, and the value is just this data dump of name, address, and favorite drink. Notice that there's no columns here except for value and key. This is unstructured data in the sense of that it doesn't, the schema is a lot more flexible. Now, Amazon has Cassandra, MongoDB, Elasticsearch, Neo4j. It's got a bunch of open source analogs, Redis and Memcached, that you can use for this. But Amazon's fastest and most premier service for running NoSQL non-relational databases is DynamoDB. DynamoDB, by the way, is designed to handle 10 trillion requests per day. This is the back end of Amazon's Prime Day. So you know it's battle tested because they use it for Prime Day and they keep advertising statistics of it during Prime Day. So this is a completely serverless. So this doesn't use EC2 t-shirt sizes. This is a serverless key value database. It's, by the way, is going to auto scale automatically based on capacity if you allow it to do so. Otherwise, you can go in and set things manually if you want to. But this allows you to just dump data into what they call a DynamoDB table, and you retrieve that data based on whatever keys you've set up. 10 trillion requests per day. I think the latest numbers I saw is that in like 20, like not the latest numbers. Let's just talk about 2019. So in 2019, they had Prime Day. It lasted 48 hours. This is 2 years ago. They've gotten even better now. There were 7.1 trillion requests made to the DynamoDB API during the 45 hours. At one point, a single DynamoDB database was handling 45 million requests a second. That's how fast this thing is. If it's structured correctly, and you've got what's called an accelerator in front of it, which is an enhancer. So these things can scale, and they're, you know, to use the common vernacular, they're sick. They can scale at a sickening pace. So that's DynamoDB. If you haven't used DynamoDB before and you just want to launch a very simple NoSQL database, it is your best option. And it will scale really fast and really quickly. Okay. Now, in addition to having relational database services and search database services and graph database services and all the database services that are really popular to you, Amazon also has a migration service. What's funny is that you can actually migrate from, say, like MySQL to like DynamoDB, or from Oracle to Postgres. Amazon's got like, I want to say it's like 25 different conversions they can do. And just so we're clear, just so that Amazon's not working themselves out of business, you can only convert onto a service. Like you can't, they won't let you convert out of Amazon. You got to convert into Amazon. Yeah, I know. They're running the business though. I get it. So just know that this DMS service is one of a slew of migration services. They've got an application migration service. They got a server migration service. They have a data center migration service. Just be aware that the database migration service is just one of a bunch of services that you could use to migrate into AWS. This service, by the way, will sit on your data center database and either do a one-time migration or a continuous migration, so you can keep your data center database in sync with the AWS database or vice versa. So even if you're not doing conversion, the DMS service can actually be used for data sync, which is kind of nice, actually. Now, that leads us to a quiz. Challenge. Okay, number one, if you want to store data in a relational database and you want to use SQL, which one are you going to use? RDS or DynamoDB?
RDS.
RDS. Technically, this question can be a little fuzzy because oddly enough, you can actually use SQL with DynamoDB if you want to. It's got a little bit of capability there. Okay, if you want to run a serverless database, I said one of these uses EC2 t-shirt sizes and one of these doesn't. Which one does not use EC2 t-shirt sizes? Ruben, I see it. DynamoDB, that's correct. Okay, if you're storing data in a key value database, that is definitely one of these two technologies. Which one is it? Ramesh, good. Right, this would be Dynamo in this case. Okay, we saw this one earlier. Number 4, if we're using SQL, structured query language, to organize and structure our data, which database technology are we using? RDS or DynamoDB?
Yes.
Yeah, definitely RDS. Excellent. Okay, so now we're into a little bit of a marketing plug, right? We already talked about this one. We talked about 10 trillion requests per day, right? This is DynamoDB, right? So we know. I mean, it is true. It's that performant. But that one we were already aware of. All right, if we're going to store data in an Amazon Aurora database, I said Aurora was a subset of which service? RDS or DynamoDB? Yeah, good. RDS is the answer. In general, just consider this. If you have a system and you need to scale, and you need it to scale without a lot of user intervention, and it's heavy on writes, DynamoDB is probably going to be the thing you're going to go for. If you have something that requires SQL and it requires complex data sets and joins, then RDS is going to be your friend. But just so we know, server for server, RDS is not, like, relational databases are not going to scale as well as NoSQL databases, but relational databases are going to be more consistent than a non-relational database. Okay, so just remember those distinctions. All right, let's talk about additional database services. Any questions about DynamoDB or RDS before we move forward? No. Okay. Okay. So additional database services that might make sense here are, well, what if you need a data warehouse? Well, if you need a data warehouse, then Redshift is going to be your friend. This is based off of Postgres. And it can hold, I want to say it's like 3.2 petabytes of information. This is OLAP, right? So this is analytical processing. That's what Redshift is for. Now, if you need a MongoDB database because you like Mongo and you want to go web scale, sorry, I just had to throw that joke in there. Amazon Document DB is going to be the one you're going to use, right? This is a MongoDB compatible system. Neptune is a Neo4j database. So this is used for graph, like social graphs, relationship graphs. So Neptune is going to be your friend for that. I don't know why it says highly connected data sets. It's graphing, it's relationship data. And then QLDB, by the way, is like a blockchain ledger database. So it's highly consistent, highly transactional, incredibly tracking around changes to the ledger, right? As far as history. Other things to note is that Amazon does also have an Elasticache and an Elasticsearch service. So if you're interested in using either searching or you just want to do caching, they've got services for both. And they do have managed blockchain, which I got to tell you, I don't even know why this is mentioned here. Totally different use cases. And then the DynamoDB accelerator is that accelerator I was referring to earlier that got them to 45 million requests a second. The DynamoDB accelerator is really cool because it can actually get you to microsecond response times, not millisecond, microsecond response times on your DynamoDB systems, okay? Let's see here. Bear with me just 1 second. All right. Knowledge check. Okay. Any questions about any of these services? There's more out here, by the way. You know, they have a managed Kafka service. I know that's not a data store, but still pretty close. They've got tons of other Athena, which is used to query S3 data. They've got Redshift Spectrum, which is used to query S3 data right off the S3 buckets. They've got QuickSight, which is kind of like more of a BI visualizer. They've got a ton of like either database, other data store tools or visualizers for data stores. So,
do we need to remember all of these database services?
No,
I would
this is
say-
marketing.
yeah, I would say honestly, like the only ones you probably need to remember is Elasticache, Redshift, right? Those are the two you probably want to remember. But don't worry. When we provide you access to the practice exams are going to definitely show you which services you need to remember. So even outside of studying this directly, the practice exams are going to reinforce and scope you down to like the things that are relevant for passing the exam. And so it's super informational, actually. Now, I've never touched the QLDB service ever, not even playing around, because it's a transaction ledger. And I certainly haven't touched the managed blockchain. The rest of this I've touched, or actually run in production. But honestly, Redshift and Elasticache are probably the ones you definitely need to remember. The others are kind of, right? Not so much.
Okay, got it.
And you just remember Redshift is a data warehousing tool. Elasticache is actually used to cache database queries. So. Good. Okay. All right. Which two of these S3 storage classes are meant for archival purposes?
Glacier and Deep Archive.
That's right. Glacier and Glacier Deep Archive. Perfect. B and D. Okay. Which option is true about EBS volumes and EFS file systems? Remember, I said there's this one cool thing about EFS that EBS can't do. What is it here? Good. I see a bunch of you put A. So remember, when you create an EBS hard drive, it sits in one data center in one availability zone because that's where a virtual machine is going to live. If you create an EFS file system, EFS shares it with many virtual machines, regardless of the availability zone. So it can go across multiple availability zones. Good deal. All right. Customer wants to store data in an object storage service. What is the one and only object storage service inside of AWS? What is it?
S3.
What? No one's going to answer blockchain? It's not blockchain. I thought blockchain was everything now. I thought everything was crypto and blockchain. No, Stanley, you're right. Yeah, it is indeed S3, right? By the way, what did I keep talking about was one distinguishable difference between how file system and block store work versus how S3 does it. What is the one thing that file system and block store attach to that you would ideally never attach S3 to?
VMs.
That's right. And Kendra, I saw that. That's perfect. Yeah, file system and block store are mountable inside of an operating system. And while you can get an operating system to push files to S3, you can't get an operating system to mount S3 as a file system. Now, I say that, that's not actually true. People have written drivers which perform horribly to try and mount S3 inside of a file system, but that's not what it's designed for, and it just doesn't work. File system and block store were designed to be mountable inside of an operating system. So just know that that's a key distinction. People kind of get that their wires crossed all the time, but S3 cannot be used as a hard drive. Just can't. You can send data to it. You can retrieve data from it, but you can't make it look like a hard drive attached to your operating system. Okay. DynamoDB, what is it? If you got 30 seconds, someone's going to give you $1 million in your elevator pitch. You say, okay, what is DynamoDB? What is it? Right?
B.
Stanley, you said that so calm compared to my kind of like rah-rah excitement about it. I see that a bunch of people posted B as well. Yeah, it's a serverless key value database service. Just that simple. Okay, what is C, by the way? What's the name of that service?
Oh, DMS.
That's right. C is the database migration service, right? Now, I noticed that, Brian, you put RDS, but that would be D, right? Well, actually, it would be A and D, actually. So both of those. Okay. Remember, I said you got to remember this one at least, right? Which service is used to query and analyze data across a data warehouse?
Elasticache.
One of the two. Yeah, it's Redshift, right? Redshift is the one you want to remember.
So how does the Elastic Cache thing work? Because don't all of these database services already have some sort of like a caching mechanism?
Well, yeah, I mean, you can like put an index in top on, obviously in front of a relational database. And if you put DAX in front of DynamoDB, that's a caching layer in and of itself. The way it works is that the application will actually go talk to the cache first. And if it's not in cache, it'll go grab it from the database. And depending on what kind of loading strategy you have, since everything is loaded in memory at the cache, what you're doing is you're actually offloading load, especially for like complex joins and queries, off of the database onto the caching system.
Okay.
So there's a couple of ways, Stanley, that you could solve that, because you could just get a bigger memory footprint inside your database and just load everything into memory. But you can also offload it to the system. So it just depends on what strategy you want to follow and what you're comfortable with, right? But you are technically correct. There are ways to do this without throwing a separate caching mechanism into play. So,
Okay.
yeah. And that is module 5. So just to say this one was dense, by the way. We talked about instant storage and how you shouldn't use it. We talked about EBS, S3, and EFS, and FSX, which I mentioned in passing. Didn't even have a slide. We also talked about the 6 tiers of S3. So we talked about standard, standard and frequent access, standard and frequent. Hold on one second. Pardon me. I have teenagers home for the week, so pardon me 1 second. So we talked about S3 standard. We talked about S3 standard and frequent access. We talked about S3 one zone and frequent access. And then we talked about intelligent tiering, Glacier, and Glacier Deep Archive. So those were all storage classes, of which intelligent tiering was the one that moved them around, right? Then we finally ended with a talk about RDS, DynamoDB, Aurora, which is part of RDS, and then the DMS service. And we mentioned a couple of other database services in passing. So we're going to talk about security services next, but does anyone have any questions before we take a break? Good. Okay. So we're going to take 15 minutes by my watch. Let's say it's 2:40. So come back at 5 till the hour. So that would be 2:55 on Eastern time. I'm going to put up a timer just in case. We're going to talk about security services. We'll talk about monitoring. We'll end with billing. It'll be a good day. Okay. So we'll catch you in just a minute. I see that I thought I was going to repeat module 5 there for a second. Let's talk about security. All right, this section is short and sweet, but before we go through it, does anyone have any questions about compute, networking, storage, any curiosities, global infrastructure? Awesome. Let's get into it. Okay, this is going to be like a broad shotgun around security. Just know that I could argue AWS is primarily a security company, because that was the #1 objection between using cloud back in 2006, 7, 8, 9, 10, 11, 12, 13. Just so you know. People are like, how could they do it better than me? By the way, if you go to AWS's compliance page, it's just a ridiculous hodgepodge of certifications that they've obtained, all of which are thoroughly legit. They have more security certification, I think, than anybody I've ever seen outside of specific government agencies. So there's that. So let's talk about this. So one, Amazon wants you to know that if you can log in or if you can configure it, you're responsible for the security of it. Otherwise, Amazon's going to take care of everything else. In the industry, this is known as the shared responsibility model. What that means is that if you launch an operating system, you're responsible for patching it, but only if you can log into that operating system. If you can't log into the operating system and you launch it, someone want to tell me who's responsible for patching it? Bueller? Anyone? Thanks,
AWS.
Ruben. Thanks, Stanley. Yeah. So AWS is responsible. If you punch a hole in the firewall, you're responsible for the hole. But if someone attacks the firewall directly, that's AWS because you can't log into the firewall. If you put a load balancer out there on the internet and you punch a hole in the firewall, you're responsible for the hole. Sorry, did I say firewall? Did I just repeat myself? This is what happens when you have a birthday. If you launch a load balancer out on the internet and you put a hole in that load balancer and say, I want you to go to these servers, you're responsible for where those, where that load balancer is pointed to. But if someone tries to attack the load balancer, AWS's security team is going to defend that load balancer. And let me just say this, they do a stellar job. Just throwing this out there. AWS's security team is top notch. Now, nobody's perfect. And can you imagine how many millions of hacks are trying to get into AWS every single day, right? Just looking for holes, because if they got in there, there'd be a treasure trove of customer data, assuming they could get past all the defense and depth stuff. So kudos to really any cloud provider that defends themselves that successfully, because man, people are looking to get in there. So AWS wants you to know that you're responsible for security of stuff that you do in the cloud and the stuff you put in the cloud. But if you can't manage it, you don't know where it's at, you can't see it, you can't configure it, you're not responsible for the security of it. Amazon is. We don't know where their data centers are, so that's all them. So otherwise, you're responsible for making sure that you flip the bits on the configuration that's going to like turn on security. That's all going to be you. Amazon will do everything else. So with that short but riveting description, who's responsible for configuring security groups on your EC2 instances? Is that going to be the customer or is that AWS? That's right. You're responsible for configuring your firewalls. So that's going to be the customer. Now, who's responsible for maintaining network infrastructure? Is that going to be the customer or AWS? What am I even paying Amazon for if they're not maintaining their network, right? Yeah, it's going to be AWS, right? Implementing physical security controls at the AWS data centers. Is that AWS or is that the customer? Can you imagine? Hey, you can launch a server, but it's completely physically undefended. So we're going to need you to send a security guard down here to take care of this. No, no, we're not doing that. Okay, if you launch an EC2 instance, who's responsible for patching software on an EC2 instance? Customer, AWS. Me, I think is a good answer, Ruben. Customer. Good. If you're maintaining the servers, like the hardware that runs EC2 instances, who's responsible for maintaining the hardware that virtual machines run on at Amazon? Thank you. Good, Donna. Ruben. Yeah, I hope so. I don't even know where those servers are located. If I'm responsible for maintaining them, and we got a whole different set of problems. All right, last but not least, setting permissions on your S3 bucket so you don't show up in the news because you shared personally identifiable information across the entire internet. Is that the customer or is that AWS?
Definitely let AWS do it.
Exactly. Right. I got to tell you, by the way, if you ever get into the S3 console, the web console for S3, there's like 3 layers of things you have to disable to share S3 information across the public internet. So when people show up in the news and they're like, Amazon did it again, once again, like, I don't know if that Amazon can do anything else to prevent people from sharing information with S3. But technically everyone's correct. The customer is responsible for setting your permissions on your S3 objects, not Amazon. Corey Quinn, if you ever signed up for last week in AWS, that little newsletter, it's a snarky but informative AWS information. He has like a hit list, if it will, of people who have exposed their information every week using S3. It's kind of hilarious, actually, the number of people who show up on there. who for some reason or another have accidentally shared their information. I'm not throwing blame. It's hard to manage a full enterprise's worth of systems. But Amazon does make it hard. So, people kind of throw that shade at Amazon, and it's like, well, they actually make it pretty difficult to not know that you're sharing information. Okay. Thank you for participating in my little shared responsibility exercise. Let's talk about how you secure your AWS account. Now, if it were me and I was emperor, I would actually start with this as the first chapter inside of our cloud practitioner thing, because I think this is actually the most important thing. Because what's the first thing you ask whenever you decide you want to get access to another system? Can I get a username and password? That's literally the first thing we all ask, is that someone says, hey, can you give me credentials? Well, this is what identity and access management is about. How do I get access to an AWS account so I can manipulate resources? Now, in the coffee shop, what happens is we're going to just give a new cashier just permissions to the point of sale system. We're not going to give them access to the coffee machine, although does that have some kind of fingerprint restrictive analysis on it? We're not going to give them access to the inventory system. We're going to give them access to the point of sale system. So how does that happen in AWS? Like this. Identity and access management, or IAM, has 3 core entities or principles that you can attach permission policies to. One of those principles is known as a user, which I think most of us are familiar with because we're used to that, right? Another principle is a group. Users, by the way, can go inside of groups. The other principle is a role. What happens is that permission policies are attached to either a user, a group, or a role, and those policies deny or allow permissions to happen. It really is just that simple. In other words, if you want somebody to have permissions to launch EC2 instances, you have to attach a policy that grants them the ability to launch EC2 instances. Now, the only thing that's confusing is that most of us understand that we're users and that we can be part of groups, like I'm in project A group, I'm in project B group, I'm in the developer group, I'm in the QA group. But roles can get a little weird for people. This is the way I like to explain it. So I have a son and I have a mother. I know, revelatory, didn't come from an egg. Although even then I would probably still have a mom, but let's move on. So I've got a mom and I've got a son, right? Now, if I walk over to my mom and I'm like, hey mom, just so you know, got some guests coming tomorrow. Your room's kind of messy. You left some food in there. It smells kind of funky. Would you mind cleaning it up? Because I got people coming over tomorrow and they might want to come into your room for 5 seconds and I don't want them to die. Now, as you can imagine, if I said that to my mom, if she just so happened to be living me, which would be a whole other kind of Freudian conversation in and of itself, that would be me assuming a father role with my mom. Now, I don't have those permissions with my mom. My only role that I can assume with my mom is either the son role or the son role, right? That's it. I have no other permissions with her. She's not going to accept anything else. She might accept a quasi-adult role since I'm a little older now, but pretty much I have son permissions with my mom. But if I go to my son and I talk to him like that, those are father permissions. He's going to be like, oh, well, yeah, sure, Dad. I'll clean it up, which he really will, actually. He's kind of an awesome kid. So, and of course, I'm not in there barking orders at him. I'm just like, hey, man, could you clean this up? Now, those are roles. Those are societal roles that I have, which gives me a certain set of permissions about how I can talk and interact with my people. Imagine these are services. So, for example, let's say, you're using Linux, for example, and you want to execute a command that updates Linux. Most of you are familiar that you actually have to elevate your permissions using sudo. If you're on Windows and you want to install software, sometimes it says, hey, I need administrative privileges. Can you just say yes to this little placard? That is a role that you're assuming. You are assuming an elevated set of permissions so you can execute a task, and then you're giving them permissions back when you're done, right? Because it's not like I walk around thinking, well, I'm my mother's son, or I'm my father's, I'm my son's father. It's not like we walk around with these identities because I'm still Michael Forrester, but I can assume different societal permissions, societal roles, depending on what agreements I have with people. Some of these agreements, by the way, were made at birth. Some of them are actually implicitly defined or explicitly defined, right? So roles are no different. Roles are just identity, like permission sets that you can assume if you need to. So you can elevate your permissions by assuming a role. Now, only users or services can assume a role. Let me show you this on the console just so you can see this in action. All right, so if we go back to my login, I want you to look in the upper right-hand side. See where it says Spartan Sage and Forrester? Right at the top, right? My son calls me Spartan Sage. So why not? My account is M Forrester. That's my alias for my account. Now let's say I actually want to do something in this account and I need to assume some elevated privileges. See this little switch role button right here? I'm going to click on switch role. But before I do that, actually, I'm actually going to go back here and I'm going to copy my account number. Okay. I don't really know what you were doing there, but that's okay. So I'm going to switch roles. And what's going to happen is I'm going to click the switch role button. I'm going to paste in my account number and I'm going to type in the role that I want to switch to. This role exists inside my IAM service in this account. And so when I switch roles, guess what happened? Look at the upper right-hand side. What just happened? First, my username is now mforrester-admin because I just changed my security permissions to be an elevated user. Also notice that I no longer have an alias because I pasted in an account number, in this case, 067670530788. No, I don't know it by heart. I just read that off. So my point being is I was just plain old Spartan Sage with no permissions, and I assumed the role of an admin inside my own account. Now I can get in here and I can wreck things. Well, that's not what I want to do, but you understand, right? So that's all a role is. Unlike a user, which is me logging in with a username and password, or a group, which you really can't do anything with. You have to have users as part of groups, right? A role is a temporary security identity that I can just assume if I need to. Okay, so just know that you can switch roles, and look at this, I can just switch right back if I want to and go back to being plain old Spartan Sage with a lesser set of permissions. If I go into IAM to show you that M Forrester role, all I need to do is click on here and go over to roles. And then I can search for M Forrester admin and look at it sitting right there, M Forrester admin. Now, when you create roles, by the way, you say who can assume the roles. So there are security boundaries around these roles. It's not like anybody can just come in here and log in as M Forrester admin. But I say when I create the role, who can don that role? Who can assume that role? Right? I do that. The person who creates it. So just know that in IAM world, there are users, there's groups, and there's roles, and permissions are attached to those three entities. So just remember that. Roles, by the way, are specifically used when you need temporary permissions. If you need permanent permissions, you need to use a user. Okay? Just keep that in mind. Temporary permissions are roles. Permanent permissions are users. Just write that down. What was that movie? Van Wilder. Make sure you write that down. Okay. When you create an AWS account, by the way, and you have an email in your username, that's called a root user. In case you're wondering what to do with the root user, here you go. One, create an IAM user and don't use it. Don't use your root account. Don't use it for anything. I know that sounds strange to say, but literally I have seen a company go out of business because someone was using their root user.
Best practice.
Yeah, that's the best practice. So what happened is that someone was using the root user and put the credentials inside a repo. And then someone who was, let's just say disgruntled, got in and deleted just the non-production environment, not even the production environment. Now that's a little like fear based, but like just to say this, the company went out of business in 6 months. They never recovered. So just as a general rule of thumb, if you have access to this, lock it away and don't use it. Okay. Create an IAM user, give it good permissions, and then put the root user away. It's a breaking glass. It's a breaking case of emergency user. Don't use it unless you absolutely have to. By the way, the main reason for this is that the root user cannot be scoped, limited, or you cannot do anything with the root user account to limit it in any way. If someone gets that password or the access key and secret access key, you cannot stop them from doing whatever they want to the account. So you've been warned. Just be aware. Okay. IAM users are users inside your account, but they're not root users. They're not the user that created the account. They're just sub-users inside of the IAM service. Policies, which are sets of permissions, are attached to users, to groups, or to roles. Here's an example of a policy. Okay, so when we look at this, I know that a lot of you are like, Michael, what in the world is that we're looking at? Well, first of all, this is JSON. So this is JavaScript object notation. But regardless of all the weird punctuation and whatnot, ignoring all of that, first of all, does this policy deny or allow you to do something?
Like it allows.
It allows. Good. What service does it allow you to do anything to?
S3.
Good. And is it specific about which S3 resources you can actually touch? Or is it like just open for any resource?
Oh, looks like though there's the AWS doc example bucket there.
Exactly. So even though you've probably never seen this before, if that said deny, you would know that it probably would deny you. If it says allow, in this case, it's allowing you to list objects. It's allowing you to get objects, which means read them, right? So even though you've never seen this before, and maybe you're not a master of JSON, maybe you are, I don't know. You know that this policy is going to allow somebody to do two things: list the objects inside of a bucket and get the object outside of a bucket. And it's going to be two specific things: the bucket itself and the things inside the bucket, which is what that /* is on the very last AWS example bucket. So it can be just that simple. You can say, look, I want EC2 everything, but only if the EC2 instance is named, Del Taco. Wait, do they even have Del Tacos anymore? Anyway, that's an aside. My point being is that.
Sure do.
Do they really not?
Well, I'm in California right now, and it's funny you said that because I just saw one the other day and thought they're still around.
Oh, good. I'm glad I'm not the only one. I thought they were gone. Which is fine because I couldn't eat there to save my life. That's a whole different.
I don't think
story.
I've ever eaten there. So
I have a secret shame about that, probably from 30 years ago. Just kidding. So allow or deny, right? Again, S3 is the service, and then you've got like your resources. That's it. This is a policy. Now, don't get me wrong. We're human beings, so we can make this super complicated if we want to. Remember, it's us. It's not the computers. We make these things. So this is pretty straightforward, but don't be afraid to read these things, because even if you don't even know the documentation, you can probably take a look at it and figure out what's going on.
Is this stuff something that you can also generate for the UI somehow?
Yes, you can actually.
Okay.
There's actually a policy generator inside of IAM that you can use to just click, and it will generate things for you. But just to be clear about that, if you want to do advanced stuff, you're gonna have to write it by hand, and so you got to read the documentation.
Okay.
Yeah. One other caveat, Stanley, that you and everybody else should probably be aware of is that the reason, by the way, it lists the bucket and the actual bucket contents is that S3 is the only service in which you actually have to list the object, like the container, like the bucket, and you have to list permissions on the bucket, what's inside the bucket. Like I mentioned before, S3 was like the second oldest service inside of AWS. For some reason, when IAM was invented, you have to define permissions on the bucket itself and the contents inside the bucket, which is why it's listed twice. So everything else, by the way, you can just say EC2, whatever. You don't have to like list two sets of permissions, one for the container and one for what's inside the container. This one you do. Groups are the other principle I was talking about. Typically, you attach policies to groups and users are part of multiple policies. You might say to yourself, Michael, what if there's a bunch of permissions and they conflict? Just so we're clear, denies trump everything. If you have denied someone access to EC2, no amount of allows will ever let that person touch EC2. So just be aware, an explicit deny will trump an explicit allow. And if you do not allow anybody to do anything, you don't give permissions to anybody, it's like a security group. By default, they're completely locked down. If you don't give somebody permissions, they can't do anything inside of AWS. So just creating a user didn't help you. Remember, the other principle I recommended was roles. These are for temporary access. So we've got users, we've got groups, we've got roles. All three of them can get permissions, but users are for permanent access, so are groups. Roles are for temporary access. The way roles work is that someone creates a role and gives the user permission, or the service, it could be a service, to switch and use the role. So for example, an employee can assume the cashier role inside of our coffee shop. This gives them access to the cashier system. They could also assume the inventory role if they need to mess with the inventory system. Now, could you just give them permanent access to both cashier and inventory? Sure, you could do that. But maybe you want it to be temporary because you want them to be very aware that they have to switch roles in order to do things, so they're not careless with their permissions. This is good practice, by the way, is to give people the least amount of privileges possible and force them to elevate whenever they need to do something that could be potentially sensitive. Here, you're touching money with the cashier role, and then you're touching inventory with the inventory role. That might be a good reason to use roles. Okay, here's the last thing. MFA. You probably saw me earlier logging into my account and it actually said, hey, what's your secret account code? That's MFA. Now, we used to use hardware keys for this. Most of us are using our phones now. The idea with multi-factor authentication is that you have something that you know, like a password, and there's something in your possession, like a phone. If you've ever watched a spy movie, you're familiar with this, right? It's got a password and then we need an eyeball, right? Or a key card or a phone. That sounds weird, an eyeball. That sounds strange. But that's because, you know, your eyeball is something you have, right? So if someone's taking a biometric scan, you know, ideally that's still attached to you somewhere. So multi-factor authentication follows the same pattern. Basically, it's going to ask you what your code is, and you have to look at your phone because that's something in your possession. And it's typically only in your possession. But we've seen enough spy movies to know that may not always be true either, right? So just be aware that enabling multi-factor authentication or two-factor authentication is a standard policy practice for AWS and is considered a best practice. Questions about IAM, either users, groups, roles, policies, or multi-factor authentication? Okay. Let's talk then about organizations. So let's see, when I worked for a company, I'm not even gonna name the time frame because then you can just look at my resume and see when. I worked for a company as kind of their head of cloud, and they were a Fortune 100 company. When I walked in, I said, hey, how many AWS accounts do you guys have across your entire enterprise? They said 700. I was like, so just to check, like, you have 700 accounts across your enterprise? I was like, what happened there? And they were like, well, we gave all the developers access to their own accounts, you know, on a per team basis. And I said, so how do you manage security and compliance? And they're like, we do it by hand. I was like, oh, have you heard about this tool called AWS Organizations? And so what I was telling them is I was like, look, you know, you could actually just take all of these accounts, put them under what's called an AWS organization, and you can actually separate those 700 accounts into business, like different organizational units. Like you could break them up by like different business divisions, right? And then you could apply policies to each of those business divisions, depending on what they were supposed to do, to make sure that certain like services weren't accessed, or to enforce guardrails like logging, no open firewall ports, you know, that kind of thing. They were like, hey, that's a novel idea. So what they did is and we had a huge migration project for this, is that we created a bunch of business units, and underneath those business units were also like production, development, staging, and we created accounts, and we would apply different policies at different levels of organization, depending on what was needed to kind of either open it up or restrict the accounts in question. This, by the way, also consolidated billing for this organization. And I have to tell you, I knew this was a benefit, but I didn't realize how much. Because we consolidated billing for all 700 accounts, the company saved $7 million a year in storage costs, because now they were getting tiered pricing because their volumes were all aggregated. I've never seen that. Well, I've also never seen 700 accounts before. But my point being is that organizations is a great little tool if you have to manage that. I know that sometimes in Booz, you have to manage the customer's AWS account. So just know that organizations can be a great way to kind of scope and organize multiple accounts for a customer if you're having to deal with that. So organizations, there's obviously more to it than just a little skim I've got, but the main thing you need to know is that it's used to manage multiple AWS accounts in a cohesive, organized way. And you can use what these things called service control policies to restrict access to certain services that you don't want people to use, like the augmented reality service. Well, I don't know, maybe that's a defense priority. I have no idea. Okay. Questions about what organizations is actually used for? Okay. Okay. A customer is configuring service control policies in AWS organizations. Which identities and resources can SCPs be applied to? I didn't actually say what that was, so I might have to tell you, but does anyone want to guess? 3 of these are entities that are part of IAM, so we can cross those out. The remaining 2 are entities that belong to organizations. What are the 2? Good. Yes, you were paying attention. That's right. The other 3 are actually IAM principals, so they don't belong to organizations. All right. Last set. So first, I just want you to know that AWS in every single account has a section of the account that's called AWS Artifact. Artifact is a place where you can go download all of the security attestations and evidence documents that Amazon has. Let me show you what that looks like in case you're like, Michael, what are you talking about? I know this is going to sound weird, but excuse me. If you are like, I am very curious about their PCI compliance, every single AWS account has this section called Artifacts. It's a service that they offer that allows you to go and download their agreements around ISO 27001 compliance, PCI compliance. And let me tell you, if you're not a security expert, these documents will put you to sleep quicker than, well, I don't know, let's say a good glass of warm milk. But if you need the detail, because you need to know for HIPAA compliance or whatever, you can go into your artifact service inside each account and you can find the documents you need. So just be aware. So that's artifacts. Other things to note. This is the assurance, like compliance section. Like, these are all the like security compliances that AWS has. ISO 9001, 27017, 27001. And again, they're at varying levels. They've got FedRAMP, HIPAA, there's a bunch of stuff out here. So just know, you want to go to the Customer Compliance Center, which is easily found, right? How do you find it? AWS Customer Compliance Center. Type it in the chat. That's going to take you straight to their compliance website. And they will help you see white papers, any documentation, auditing checklists. I've been through 3 audits with AWS over the course of my career since 2014, 2015. And I got to tell you, they are almost perfect partners to walk through an audit with. So good to deal with. Okay. So you just saw me click through artifacts. What can you do with artifacts? Let's take a moment. Well, consolidate and manage multiple AWS accounts. Probably not. Create users to allow people and applications to interact with it. No. Set permissions for no. So even by process of elimination, we can pretty much say that accessing compliance reports and reviewing and accepting agreements is probably going to be it, right? Which I see that you concur. Perfect. Okay, last few things. 1, application security. So remember, I mentioned there were more than just a few firewalls with AWS. There's other firewalls. There's other security measures. So even if we're not managing users and then we're not managing accounts, how do we protect our applications? Well, first, there's the web application firewall, which, by the way, these have been around since 2009, 10. This is a web application firewall where you can literally block malicious traffic that either is IP based or maybe the traffic itself is sketchy. Like you can filter for that traffic. And so a request from a customer, it says, hey, I'd like to access the application. You're like, the web application firewall is like, yeah, come on in. A malicious request from a hacker and the web application firewall can go, hey, yeah, you're coming from a known bad IP address. You can't come in. Right? That can be very useful when you want to allow legitimate traffic, but block illegitimate traffic. Now, these are usually like cross-site scripted vulnerabilities, SQL injection attacks. If you're familiar with XKCD, little Bobby drop tables. Oh, that's such a great little cartoon. Like stuff like that. If you are trying to prevent a distributed denial of service attack because someone has got a botnet, like a huge network of systems, and they're trying to shut you down by simulating false traffic or real traffic, actually. If it comes from a single source, then it's just a denial of service attack. If it comes from a huge network of servers, that's harder to defend because it looks like legitimate traffic. Just so you're aware, Amazon by default has this product called Shield that's on for every single account. Shield basically is AWS's security team blocking you from distributed denial of service attacks. So they're constantly watching for bad threat actors and blocking them if they go rogue. They also have an advanced version where you pay for it. And that one will give you like indemnity and you get dedicated access to a team. And by the way, you can weave Shield and WAF together if you want to. But the advanced Shield is something you pay for. And I think you have to do an 18-month commitment. It might be a year, but it's a more advanced version of the standard product that everybody has. So in addition to a web application firewall, in addition to Shield, which is included with every account, you can also just use Inspector or any of the other security services that will allow you to proactively assess or be on the watch for malicious attacks. So Inspector, for example, will examine your EC2 virtual machines and see if there's any vulnerabilities on them. Additionally, there are so many security services. There's a security service that encrypts all your hard drives. There's a security service that uses machine learning to watch your network for malicious attacks. There's a forensic service. There's a security centralization service. There's a patching service for your operating systems. There's so many security services. Do you need to know them all for the exam? No. Just in case you missed that. But Shield, WAF, right? And I would say Inspector, you definitely need to know. Inspector is the vulnerability scanner. Shield blocks distributed denial of service attacks. And WAF is used to stop application level attacks. That's it. Okay. Questions about security services of any type?
Where does a WAF fit in relative to a NACL and a security group?
It's outside. So it's outside core networking. So they have to
Okay.
get past the WAF in order to get to the NACL and then to get to security groups. Okay. Knowledge check. Which statement describes an IAM policy? What does that policy do? Good. Yeah, it's a document that grants or denies permissions to AWS services. That's all it does. Good. An employee requires temporary access to create several Amazon S3 buckets. What should we do for this? What's best? What's the best IAM principle for temporary access? Hopefully I emphasize that enough. Ramesh, I see it. An IAM role, right? Ruben, good. A role, either for services or for a user, is the best way to give temporary access. So we like to use roles for that. Excellent. Which option, by the way, describes the concept of least privilege? How do we give somebody least privilege? Like, what does that mean? Good. Granting only the permissions that are needed to perform specific tasks. That's exactly right. Good. All right. Which service helps protect your applications against distributed denial of service attacks? It's included by default with every account. Excellent. Excellent, excellent. Good. Yeah, that would be Shield. And then I said very much in passing that the KMS service, what does it do? Because I actually didn't say what's listed here, but it is what it does in order to encrypt hard drives. In order to encrypt hard drives, you have to generate something in particular. Ruben, looks like you grabbed it. You have to create cryptographic keys, right? So that creating of cryptographic keys is what's necessary to encrypt or protect the data on our hard drive. And that's what the KMS service is. The KMS service is a key management service, and its function is to generate cryptographic keys. Good. All right. So I want to be very intentional about this because this typically happens with the Cloud Practitioner class, is that I'm actually going to talk about the pricing and support module next. And I'm actually going to skip monitoring and analytics. I'm just going to skim it actually really quick. I'm actually not going to skip it. But I want you to know that I'm doing that because you might want to go back and read monitoring and analytics, because the class has 6.5 hours worth of lecture. And typically we don't have time to cover every single piece, but you have access to it. But I want to just cover it really quick as a skim and then dive into billing a little bit more. And then for the last 15 minutes of class, we're actually going to cover some of the training pieces that I think are going to be very useful for you to pass the certification. And we're also going to talk about some of these again on December 7th. So monitoring and analytics. So just know that AWS, its primary metrics repository is CloudWatch. This is where you get metrics about systems and services inside of AWS. So for example, you might have metrics about like how long does it take for users to getting their coffee, or how many pastries are we selling? And you might have thresholds that say, look, if I sell more than 10 pastries, I want you to bake another batch of pastries. This is an event-driven response based on a threshold crossing, right? So CloudWatch is the service that supports this, and it has 11, has 11 subservices underneath it as of this month. So CloudWatch, even though it houses numbers and metrics related to like CPU utilization, network bandwidth, like all the stuff that you would expect to see about servers and services, it also has things like dashboards so you can display them so people can see them. It also has things like CloudWatch Insights. It has all of these crazy services on it, which are super powerful.
Looks like Splunk,
It does, doesn't it?
capabilities.
And it has a lot of those capabilities. But you'd have to do an in-depth analysis because Splunk has some really specific capabilities that CloudWatch doesn't have yet. But CloudWatch has integrations into AWS that nobody has. So it's a really good service. It's a really big service. And it's got like all things from like tracing to logs to log insights to event triggers. It's got a lot. What you really need to know is it's the metric system for AWS. In addition, if you want to track all of the API calls made against your AWS account, so these are not metrics. These are people trying to get into your account and do things like start virtual machines and create S3 buckets. This is what CloudTrail is for. CloudTrail is going to track the execution of all things against your AWS account, much like the events that you would find inside of a coffee shop. So CloudTrail is used to track any user activity against your account, but it's not meant for tracking operating systems. That's what CloudWatch is for. CloudTrail is only for infrastructure changes made against your AWS account. And it can detect unusual activity. So you can detect, for example, when a new user is created, who did it, what time did they do it, how did they do it? You get all kinds of information from CloudTrail. So it really is only there to focus and monitor your AWS infrastructure in like near real time. Sorry, it's used to track user activity and API requests throughout your infrastructure. It actually will, enable troubleshooting and operational analysis as well. All right, so that being said, that's very specific. Which task can you perform using AWS CloudTrail? Which two things? I think I just said these. So hopefully you were paying attention. So definitely B, tracking user activities and API requests. So oddly enough, I do actually agree that I think A is definitely an option, but technically the answers are B and D. So you can actually track user activity and you can filter logs to assist with operational analysis and troubleshooting. I would say the only reason it's probably not monitoring your AWS infrastructure and resources in real time is that it monitors your API calls and resources in real time. It doesn't actually monitor your infrastructure. That is 100% a CloudWatch function. That's what CloudWatch is designed for. Okay. Last few things. Trusted advisor is a guiding advisor that can tell you, like a consultant, what's going on with your account and suggest best practices. Trusted advisor only works if you have an enterprise support contract or a business support contract with AWS. Otherwise, you get a very dumbed down version of it. Its job is to say things like, hey, you've got 5 virtual machines that are 5% utilized. Is that what you want? It does things like this. Hey, by the way, this machine is like 1% utilized. That's a really severe underutilization. Is that what you want? Or, hey, this is moderately underutilized. Or, hey, this is being utilized perfectly. So just know it will tell you things about your service limits, about security. It will try and let you know when it thinks things are going awry. Okay. Again, this is only useful if you have a business or enterprise support plan. Otherwise, there's not a whole lot here for you to use. Any questions before we go into our knowledge check? That was a quick skim, right? Okay. So what can you use CloudWatch for? Remember, CloudWatch is the metrics repository. Yeah, perfect. A and D is absolutely the right answer. Excellent. Good. All right, so then which service can you use to review the security of your S3 buckets by checking for open access permissions? I'm going to give you a little hint. This is the one that requires the support plan to function. Which one of these do you think it is? Good. It is indeed C. Okay. There were 5 categories under Trusted Advisor. They flashed by really quickly. So just so you know, there was cost optimization, there was security, there was performance, there was service limits. Oh, and I actually forgot that one. What was the last one? Let's go take a look. Cost optimization and security performance, fault tolerance. That was the one I forgot. So we're going to give you this one because we didn't really dive into this, but performance and fault tolerance are the 2 that are included as part of that 5 set. All right, so the goal of this module was to let you know that CloudWatch is the metrics repository, CloudTrail is the account API logging tool, and Trusted Advisor is a kind of like automated consultant. If you have the proper support plan, it's going to tell you what's going on with your account. All right. Good. Let's spend this remaining time then talking about pricing and support. And then we'll maybe we do a skim on migration innovation. But let's talk about this. Okay. So there's somewhat some marketing stuff in here, right? So just to let you know, we're going to talk about some of the free tier stuff and organizations and consolidated billing. And I'm just going to let you know that there's a bunch of budgeting and billing tools inside of AWS. So how can I budget and pay for AWS services, and where can I find support and third-party software? So here's the important things to really know. If you type in AWS monthly calculator, there's a simple one, by the way. And you're like, Michael, how did you know that a terabyte of S3 storage costs $23.44 a month? Well, I went to this monthly calculator. I clicked on S3. I typed in 1 terabyte and then see it says $23.44. This is a great way to forecast how much things cost, right? So make this 0, costs go down. By the way, you want to see how much Glacier costs? So this is Glacier Deep Archive. If I put that same data into Glacier, instead of being $23.44, guess what it is? It's $1.02. Now let's be clear, that's archival storage, right? So that's way colder. But notice that it's like 1/23rd, 1/24th of the cost of hot storage. So by the way, this monthly calculator has a bunch of services attached to it. But this is a great way to like forecast your usage by doing a cost estimate. So this is where understanding pricing really comes in handy, because those kind of tools are all over the place. And so we're going to talk about them to a little bit. Now, I've already mentioned the free tier at the very beginning of class. If you want to create your own AWS account, don't use your bah.com email, but know that you get a bunch of things free when you sign up for your own AWS account. And some of them are free for 12 months and some of them are free forever. When you do that, obviously, you get to pay as you go, pay less when you actually do the reservations, which we talked about reservations earlier. And as you use more, as you pay, like as you consume more, you pay less per unit. Now, I don't like that as a cost saving measure, but when I did that for those 700 accounts a couple years back, we saved $7 million a year. So might be worth checking that out, right? Now the pricing calculator, this is the new version. You just saw me looking at the old version. They don't have feature parity yet. A lot of people still like the old version, but if you go to calculator.aws, that's the new version. This one, you create an estimate, save the estimate. But if I was looking for S3, by the way, I would just go over here to S3, configure it, make sure it says standard, enter the amount of storage, terabytes per month. Notice it says 2355. Why does it say 2355? That's weird. Weird. And then I would add that to my estimate. Oh, wait. There's my 12-month cost. There's my standard monthly cost. So there's two pricing calculators. Either one works really well, although obviously there's a little price discrepancy there, so I'm not sure what that is. Things like Lambda, by the way, you're going to need to run to actually see how it works. If you ever want to see your bill, by the way, this is easy to do. You actually just go into your account. Click on your name. Click on billing dashboard. And you will come into this beautiful dashboard, which I don't have a whole lot here. But if you click on bill details, you can actually switch to see details of other months in terms of like details by service. God, what was I doing that I had charts in here? Okay. Simple notification service. Notice that I can actually see what region I'm in. So SNS, whether, how it's enabled, what it's enabled for, who's doing what. So your bill will actually tell you what's going on in what regions. So your bill can actually tell you quite a bit. We looked at EC2 pricing already, including whether we use spot instances or reserved instances. What was the most expensive licensing model or way you could use EC2? Does anybody remember? No?
Something about direct storage to the hard drive.
Close. Yeah,
Was it
close.
at the block storage?
Nope, that's storage. What's the most
Oh, sorry.
expensive EC2 licensing type?
Oh, EC2, right?
So on demand is the second most expensive. What was the one that had all the security and licensing things around it?
Yeah, the reserved one.
Well, reservations are actually one of the cheapest ways to use Amazon.
Oops.
Yeah. So I love these guesses. We're heading the right direction.
Was it dedicated host?
It was dedicated hosts and dedicated instances, right? So that was the most expensive way. It gave you the most security, but it's expensive, right? So the rest of this we talked about on demand and compute savings plans and using spot instances. We covered this. Service charges, by the way, show up like this. So they show you how many hours of compute you have. Did you use EBS? How much did you use? And if you have a load balancer, that actually shows up under EC2, which I think is hilarious because it's an add-on for EC2. So it's going to show up here. S3 pricing, by the way, is going to be based on the amount of data you store, how much you change it, retrieve it, read it, put it, and then any other kind of enhancements, like if you add replication or whatnot. Your bill here is going to look like this. By the way, the bill will teach you how these things function. So even you don't have to memorize all this. No one's going to ask you these questions, at least not at the cloud practitioner level. And so what you really just need to know is where to find these kind of information. So the billing detail is where you find this level of information. Okay. Couple of questions for you. The AWS free tier includes offers that are available to new AWS customers for a certain period of time. What is the duration of that certain period of time? That's right. Ruben, that's exactly right. It's 12 months of services that you get. Now, there's some services that are unlimited, like DynamoDB is unlimited and S3 has some unlimited pieces, but there are some that you only get for 12 months, like EC2 instances, RDS instances. For 12 months, you'll get to run one T2 micro EC2 instance for free. After that, you're going to pay for it. Now, you also get consolidated billing. So remember how I was talking about how you can consolidate the bill of multiple accounts, right? Really easy to do. Organizations is a great way to do it. This allows you to receive a single bill for all of the accounts that are attached to your organization. And then you get to share savings or optimizations or economies of scale across all of your accounts. Typically, the way this works is that you've got a bunch of accounts who are spending money separately, and the total charge to the paying account represents everything that's spent. I gotta laugh at this, right? Does anyone know what 1996 is? What happened in 1996 that might be relevant for Amazon? That's the year Amazon was founded. Anybody know what 1964 is? Excuse me.
It's the year I was born.
Way of the
Well-
worlds.
Well, you know, Greg, just so you know, then you share a birthday year with Jeff Bezos, because that's
Oh, there you go. All right.
that's the year he was born.
You better
the
get to work
crack-
on the rocket ship.
Not yet. Give it time. I'm
Does
sure
that
he'll co-
does that make you feel less accomplished, Craig?
No, not in the least, not in the least.
Good.
how can we feel more accomplished? He's the rich ways. He's like the second richest man in the world or something. I don't even remember. 2006, by the way, 20.06 is you know, the year AWS started. So it's funny how they choose these numbers because it cracks me up. A little bit of trivia there. Okay, the other thing is that whole volume pricing thing that I was talking about earlier. This is a great visual for this, by the way. It normally, if the accounts are being billed separately, then you don't get any volume discounts because you have to cross, like, you know, a 10 gigabit threshold in order to basically get a discount, right? Well, none of these accounts are over 10 gigabits, 10 gigabytes. So like, who cares? No one's getting a discount. But if I consolidate billing and now in aggregate, all these accounts are now at 14 terabytes, then now I'm getting a discount for the last 4 terabytes. This is how that $7 million savings per year happened, is because all of a sudden we started getting volume discounts because we consolidated all of our accounts together, but no single account alone had enough volume to drive us to those discounts. It's only when we aggregated them that everything started happening. Now, there's a couple of other tools to talk about in relation to billing, such as budgets, which is used to restrict and notify you if something goes over budget. I have budgets on my account. If we go take a look at my account and we go to budgets, just note that I get notifications if anything crosses a certain threshold, like if all of a sudden DNS goes through the roof or if EC2 goes through the roof. Now my budget's pretty low just because I just want granularity on notification, but you know, you can set these to whatever you want. So I don't really think I'm on track for anything this month. I haven't really been doing anything but showing things and then shutting things down. So I've been pretty good about it. Now, in addition to budgets, there's also Cost Explorer, which is a fun little colorful tool that you can use to get access to information. Like you can download CSV files of your stuff. You know, most of us aren't going to get access to this, but if you're managing somebody else's account, you'll probably have access to this. This is a great way to track costs inside AWS. You can actually do it by availability zone. You can do it by linked account. You can actually create a lot of granularity in your reporting here. And you can also just pull down the raw data and just do whatever you want with it. So remember that. And then last but not least are the various support plans of AWS. So just know, in addition to Cost Explorer and using budgets and using the bill detail and, you know, just using the billing center to find out what's going on with your bill, there's also support plans. So if you want basic support, well, that comes with every single account. Beyond that, you're going to have to pay. So the developer account is the most basic of the accounts. Doesn't come with a whole lot, but it's better than zero because they actually will respond to you within a certain time frame. But business and enterprise accounts are by far the strongest technical accounts. You're usually going to get a response within an hour or 15 minutes if you're an enterprise account and you've designated the right things. But an enterprise account is expected to respond quickly to any outage. So if you have an enterprise support plan, you most likely have what's called a technical account manager. And that TAM is going to be like your kind of like white glove butler for coordinating and communicating around your AWS account. So great person to have on your side whenever you need to navigate at AWS is to have this TAM who can be a herald for the company on your behalf. So, all right. Which of the following is the lowest cost AWS support plan that includes all AWS Trusted Advisor checks? Okay. So the business is the lowest one here. Sorry, I kind of locked up there for a second. Any questions about support plans? And but you may remember is that I said that you have to have the business plan and the enterprise plan in order to get access to Trusted Advisor. So just know that you need the business plan or the enterprise plan in order for that to function. Everything else, as far as like Cost Explorer and consolidated billing and all those pieces, well, you have your notes on that. But the other thing to note is that this is all found under the billing dashboard. And look at all this stuff on the left-hand side: cost and usage reports, cost categories, Cost Explorer, budgets, budget reports, saving plans. There's so much here. For the purposes of your cloud practitioner, you just need to know the things related to licensing and that how to use Cost Explorer and how to use budgets. So don't worry, we cover those with you in the practice exams. Okay. Last but not least, let's talk about the AWS Marketplace. So the AWS Marketplace is where you can go to get third-party software like TIBCO or Oracle or Checkpoint, like any of the software that you're used to dealing with vendor-wise, you can find it in the Marketplace. So the Marketplace has categories for DevOps, analytics, security, migration. If you're looking for a vendor, you can find it in the Marketplace because everybody wants to partner with Amazon. Be careful if you buy software from here because there's usually hidden charges in it. So just be mindful of what you're getting here. You may be paying not just for the virtual machine, but you also might be paying an extra licensing fee. So just stay aware that that's there, okay? All right. Last knowledge check. Number one, which action can a customer perform with consolidated billing? Think about my great story, right? What happens there? Something merges with consolidated billing, right? I see that most of you chose C. You get to combine usage across accounts. Okay. Which pricing tool is used to visualize, understand AWS costs and usages over time? It's the one that had all the colorful graphs on it. Good. Good, Ruben. Cost Explorer. Because remember, pricing calculator was just a forecast for workloads you don't have yet. Budgets was just to set alerting and thresholding limits for how you're spending. The free tier was just really there to kind of like give you free stuff inside your new account. Cost Explorer is really the only one that's used to visualize, understand, and manage AWS costs over time. Good. Okay. So which pricing tool can a customer use to receive alerts when a service goes over a customer defined threshold? It's the best one for that. Good. See, a couple people chose budgets, and that's accurate, right? Budgets is what we use to define these thresholds that then alert us and let us know. I think they started putting, by the way, hard limits inside a budget so you can actually prevent services from launching if they cross your thresholds. But I think that was a beta feature, but it might be out in general use now. All right. Last question. I mentioned this as being the premier, right? Like part of this premier support plan. Which of these is the premier support plan? What's the highest level of support that you can get here? Good. Enterprise. By the way, that's a 15-minute response time on business critical workloads, an hour response time on production workloads, and you get a TAM who's going to answer your phone calls immediately. Good. All right, what's the name of the place, the service inside of AWS that allows you to pull in third-party services like firewalls, message buses, databases, whatever? Good. Yeah, the marketplace. Well chosen. Yay, that's great. Questions of any type around billing, support plans, any of the pricing pieces? Okay. All right, one quick skim of migration innovation, and we'll get to it. All right. So Amazon does actually want you to know a few things. One, they have a cloud adoption framework. So if you're needing something to kind of provide advice about how to adopt cloud and use some filtering functions or whatever, they've got a great paper on this. It's a framework that helps you identify workloads and where they should go. There's different like perspectives or areas of focus that you can use, right? Namely revolving around business and people and governance and platform and security. And so it talks about these goals and these common roles that fit each of these 6 perspectives around cloud adoption. So, the idea here is how do you take care of all the people involved in the cloud adoption migration policy, right? That's what we're looking for. Now, in addition, there's actually a couple of migration strategies. These occasionally show up on the exam, so they're kind of interesting. So for example, you could have a strategy where when you migrate into AWS, you might just want to like lift and shift. You're just going to rehost it, right? Rehosting is really what like just straight up lifting and shifting. And what you're doing here is you're just picking up your workload and you're just moving it over to AWS. You're not repurposing or changing it in any way. Now, sometimes you might want to lift, tinker, and shift, which is known as replatforming. And this allows you to change a few things, but you're not doing major changes. Then you might decide, you know what? Let's refactor or re-architect this thing. And so let's move it, but let's like redo it to optimize for cloud 100%. So we're not going to change a few things. We're going to change a lot of things. And then you've got repurchasing, which allows you to basically stop paying like someone for like Oracle licenses and maybe bring those licenses over to AWS. Well, Oracle's a bad example because I don't think you can do that, but Microsoft you can, right? You can bring your licenses over to Amazon and just use your licenses. And so maybe you repurchase them or convert them into cloud-enabled licenses instead of using data center only licenses. These final 2 strategies do not have anything to do with about moving applications to the cloud. This is about just keeping things where they are, which is retaining, or retiring, which is just about shutting things down that are no longer useful. So really rehosting, replatforming, refactoring / architecting, and repurchasing are the 3 kind of like models that you want to use for migration strategies. So then one of our last questions is which of these models are going to be ideal to moving from a traditional license to a software as a service model? In other words, which one of these has us converting from a traditional license to a more cloud-based license? So this is repurchasing, right? Where we're actually going to be purchasing a brand new model, a new license model, if you will. Okay. Just so you know, for the sake of time, I'm not going to go through the snow model. I'm not even sure why this is here, actually. it's a really confusing place to put this because this is all of our edge and IoT devices, except there's a big truck here as well. So I'm not sure. I think this is because you can use this for data migration, but this is also where the edge devices live. So feel free to read into this if you want to. This would have been better under storage, frankly. But this is all the devices that AWS uses to transfer data. So just know this is here. It doesn't really show up on the exam, so a whole lot. So I'm not sure why it's here for. So let's just roll with that. All right, last piece about innovation. Amazon is trying to focus on artificial intelligence, machine learning, serverless applications, low-code applications. That is what they believe is the future, is abstracting away as much IT overhead as possible to where people are literally just delivering application values. They want to help you take your data, monetize it, monetize APIs, and derive valuable insights from your information. This is where they're focusing a lot of their efforts. So just know that this is where their innovation path is really leaning towards, is to make it easier for you to code and easier for you to derive insights from your data and act upon them.
So can you give an example of that in today's world?
Well, for example, let's say you've got a bunch of customer behavior data, but you've never done anything with it to actually see what your customers are doing. Amazon has a whole SageMaker suite of services. There's probably 20 services underneath this thing that now will do things like help you create and train predictive models that will allow you to infer what the majority of what your customers like, doesn't like, and what they will do if put into a particular situation. So you can actually start doing some predictive modeling around customer behavior if you had a body of customer behavior data. And so that would be a great example. For example, they also do things like, if you're are trying to detect fraud, they have, for example, have services like the fraud detector, which will help, detect fraudulent online activity. They have voice and text chatbots. They've got discover patterns in text with comprehend. You can do image recognition with recognition, which is spelled with a K, which is a little weird. So those are the specific things that they're trying to help you with services that allow you to transfer images, video, voice, audio into data that can then be analyzed and applied. But the customer behavior one is probably the most applicable one for most people.
Paper surveys to electronic.
Yeah, but basically, for example, if you want to collect what a user does on a website, whether they hover their mouse or whether they click or don't click, that's the kind of they can do clickstream analytics.
Okay.
Yeah, that kind of thing, which is
okay. Thank you.
Yeah, pretty cool. Other things include, by the way, that they have a well-architected framework. So if you are in an architect role or a design role and you need a filtering function for optimizing for security, reliability, operational excellence, just know that they have white papers and deep dives, and including a tool that will help you determine whether or not your workloads are secure, reliable, efficient, cost optimized, etc. So just know that they have these options. Okay. All right. So in this particular set, we talked about the cloud adoption framework as being available for you to help you figure out how to move workloads and adopt cloud. We talked about rehosting, replatforming, refactoring, repurchasing as an example as the 4 of the 6. I skipped the Snow family because I'm not even sure why this is here, other than it's a data migration tool, but also has edge capabilities. And then we talked about a few like Amazon's focus when it comes to AWS services, which is really around, data, and data, right? And that there is a well-architected framework if you need some filtering functions to enhance your cloud adoption or your cloud design. Okay. Technically, that is actually the end of class as far as the official material. Should we talk about Cloud Practitioner for a second and talk about some of our training resources and pieces like that? But before I move forward, I know we really kind of hit those last modules intensely. Does anyone have any questions for me? Okay. First, just know that we're going to talk a little bit about the exam. The exam for Cloud Practitioner spends about a third of its time on the technologies and services, a quarter on security, about a quarter on the general cloud concepts, and about a sixth of the time on billing and pricing. So billing and pricing is not the dominant topic. For this exam, you definitely need to have an understanding of basic IT services and at least 6 months experience with AWS, but it is a trivia exam. So, you don't need to have hands-on experience. The exam is 90 minutes. The passing score is basically a 70 out of 100. It is multiple choice. And of course, you can get it in a variety of languages. I think the only speaker options I've ever seen are either Japanese or English, but written wise, you can get it in a wide variety of languages. There's no penalty for guessing. Unanswered questions are scored as incorrect, right? And you can flag questions to review before submitting the exam. So I didn't mention it costs about $100, but vouchers will be provided for this actually. And you're going to get a 2-shot or double shot voucher, which means that in the unlikely event that you fail the first time, you can, I think it's a 2-week cooling down period, and then you can take it again, right? So it usually takes about 20 hours of study to round out all the information that you got here and still prepare for the exam. There are a bunch of technical papers that you can look at, but when you come on December 7th, we're actually going to provide you with a study guide that's a little bit more simplified that will allow you to focus your studies even more. And we're going to talk about some exam strategies, but like Amazon's got some, like read the full question and see if you can predict the answer before looking at the responses, and obviously excluding incorrect response options. You saw us doing that actually, where I was like, yeah, just exclude the answers, just exclude the ones that are wrong. But we'll talk about some of these exam strategies when we meet on the 7th, if you decide to come and hang out. And we're also going to give you a full set of exam questions that are, in my opinion, in the opinion of a lot of the Amazon instructors, are way better than the practice exams that Amazon publishes. They're not horrible. We just think that these are better because they're more focused, leaner. And so we're going to run through those on the 7th as well to kind of get you like ready to pass the exam. Just know, like I said, it's going to take about 5 hours a week if you got time for that. And so it takes about 4 weeks, usually about 20 hours for people to really be ready to pass. You can go faster if you want, but we'll talk about all those details on the 7th. So hopefully you're going to continue your study, review your notes here, right? And get ready to like really bear down on the practice exams when we see you next. All right, so what's the passing score? Someone tell me.
700.
700 or 700, sorry, 70%.
Yeah, 70%. That's it. That's all you need, right? All right, so which domains are included? So which 2 of these domains? So I don't see cloud concepts. I don't see technology. What are the 2 concepts here, right? So D, billing and pricing. So that's one of them. What's the other one that I said compromised about a quarter of the exam? There we go. Security and compliance. Perfect. Okay. I have one more thing for you. I just want to give you a heads up on this. So you're going to get a study guide from us. You're going to access to practice exams. And, just know that this course is actually available in digital format. Obviously, taking it with me, I'd like to think is a little bit more meaningful, a little bit more colorful. But just know that if you need to re-review this course, you not only have your student guide, but if you go to this last website, it's called, and you can just type in AWS Skill Builder, but I'm going to post a link in here so you can have access to it. It's actually at skillbuilder.aws. If you log into this site, and you do have to create a login, you might already have one, just so you know, if you've ever logged into any other Amazon site. In this case, I'm actually using my just generic Amazon login, my AWS login. Oh, really? That's a first. Is it because I've been logging in as other things recently? Wow, your password's incorrect. Hold on one second. Is that an S? Oh man, this is going to be fun. All right, WFHN33. So that sounds good. Gonna work now? Huh. Well, sorry, regardless, if you can get logged in the skill builder and you're not having the problems that I'm having. Is that an S6YB? What in the world? Huh. Anyway, if you get logged in, what you can do is that once you're inside skill builder, banning, of course, my particular challenges that I'm having, you can actually search for Cloud Practitioner. And you can get access to a really reduced version of this class that could be really useful if you want to just kind of like rehash it. And that's not in the same format that I'm teaching, but this is the class that was taught before there was an instructor-led class. It's a little bit more condensed, but if you enroll in this course, it actually just walks you through a series of videos that are somewhat similar to the things that I walked you through. They don't go into as much detail. So if you need a refresher, just know that there is the simplified digital course available in addition to your own student guide that you already have. So that's the last thing I wanted to cover before I posted up the evaluation of the course. Does anyone have any questions or anything they want to run by me?
Yeah, I have a quick question. That 4-hour study session, will that be during work hours or will it be after work hours? Because I noticed it's during the week.
Yeah, it's 1 to 4 Eastern time.
Yeah, so it is during work hours.
So I know it's
Okay.
not convenient for everybody. We will record the session.
Okay, good.
So anyway, and I did post some information in the chat about how to access your practice exam. There's a link for Tutorials Dojo, and you create your account there. Then you'll get an email to validate that you created an account, which you have to finalize your account with that, because a lot of times people just set it up, but they don't see the email that comes through to, confirm your email address, kind of a common practice. And then within 24 hours, your license to the practitioner's exam will be loaded. It's a multi-use exam, so you can just beat the heck of it out of it over and over again until you feel comfortable. And I think, Michael, your recommendation, you get 90% correct, and then you're good to kind of schedule your actual exam. And quite actually, a lot in the 4-hour session we're going to do is working through those exams, and then focusing on areas that'll be on the test. So anyway, understand if you can't make it, but if you can, that'd be great. But a lot of these other tools will be helpful. And as Michael said earlier, this really comes down to memorization, where other exams with Amazon, be it architecting or DevOps, specialty exams, they really require hands-on practical knowledge, where this really is memorization. So doing the practice exams over and over again can help you with that memorization.
Yeah, and hopefully you can see on my screen right now that the practice exams that you're getting access to, once you get access to my courses, which you'll get an email saying that you've been registered, for example, you'll see the Cloud Practitioner exam show up, and the exams that you want to take in practice. And I would start this immediately. Don't even necessarily wait for us to meet. If you're planning, is to go and take the review mode exams. There's 6 sets and you can pick any one you want to, but start it and start one and stick with one until you can get 90% on the test. Now, here's the cool thing about these exams. Let's say we're doing review mode set 3, and that's the one we're going to work on first until we can get a 90 or 95 percentile. Then let's say I was going to work on review mode set 4, and I was going to do that until I could get a 90 or 95 percentile. We only recommend that you do 2 of the exams if you have prior like experience. If you don't have prior experience, we recommend that you take 3. Now, what happens here is that the cool thing about these practice exams is that one, John has got a photographic memory, and he works with Amazon to make sure he doesn't violate any NDAs or any restrictions there. But these are really close to what he sees on the exam. But he ensures that it's not a test dump. So they're not exact copies, and they're not meant to be. He wouldn't do that. But what happens is that when you take these questions, let's say, which of these following infrastructures correlate to a VPC subnet, right? And so a subnet actually correlates to an availability zone because a subnet can't span more than one availability zone, right? He gives you the correct answer. He tells you why the other answers are wrong. And then he gives you references and resources for where he got it from Amazon. And if he has a video or a cheat sheet, he's going to give it to you. So if you keep missing questions on VPCs, you can go study the cheat sheet and make sure that you can pass those questions a little deeper. So we love these exams because you get rights, wrongs, you get cheat sheets if you need them, you get the sourcing, and if there's a video to help you study deeper, it's there for you.
And we got this from this link you just posted? Or
You register for it through that link. And then the exam, after you confirm your registration, the exam will be loaded within 24 hours. Reason being that John's company is in the Philippines. And I've got to talk to him. There's got to be an easier way to do it because we prepay for them, but they actually have to load them into the system. So even though I give them a list of people from Booz Allen that once they register should get access to it, they manually add the license to it. So it's a little backwards in today's technology world, but anyway, that's just how it works for now.
So
But
do
we
me a
do-
favor. Oh, sorry, go ahead. You were still talking. So I actually just paste the meeting chat into the thing. Everyone, if you haven't saved the links yet, go ahead and download the meeting chat. At the very end of that text file, you'll see all the links that we've saved, including how to sign up for the 12/7 session, the evals link, and then also how to sign up for Tutorials Dojo so you can get registered.
download me. Oh, that's this what you just posted?
Yeah.
Okay.
Yeah. So you can download it and then you can get all of the sign up links that you need. In addition, know that within the next 24 hours, I'll send you an email that will follow up with all these links as well, just in case you need them. Please just do us a favor because we really value your feedback, is that if you can fill out the student evaluation as soon as possible, we'd love to get that today. We just like to make sure that we're getting feedback. Then we can also use this for feedback for Amazon as well as WebAid Solutions. And if you have any like things that you want to see more of, maybe you want more exam practice, maybe you want to learn more about Terraform, maybe you want an architecting class on AWS, let us know in the evaluations, and that way we can capture it. That becomes valuable feedback to inform future classes.
Do we get a certificate of completion for this class for FlexEd?
Yeah. It'll go out by the end of the day. It goes out after the training session's over. So it's all set up. So you would submit that along with your invoice and your receipt showing paid in full. So everything is sent to you electronically for FlexEd reimbursement.
And so we don't need to pass the test to get reimbursed.
No. You just have to show validation that you attended the course.
Okay.
Yeah. If you have any kind of challenges or complications there, you can obviously email me. If there's something of a technical nature, you can always email support@webaidSolutions.com. Greg Wagner is the gentleman who's been talking to fill in the gaps. Greg is a great resource if you have any general questions about programs or upcoming classes or anything along those lines. Greg can also qualify his own asks. So, but I'll post his email address here as well in case you need it.
Thanks. I've got to jump off. Actually, a call that's about to start. But thanks, everybody. If you do have any questions, just let us know. And if we don't talk between now and Thursday, have a great Thanksgiving.
Yeah, have a good one, everyone. I'm going to hang out for a few minutes in case people have questions. Otherwise, we are officially done. You've been fabulous.
Can you make sure his Greg's contact, your contact information are in the downloadable thing? I think I downloaded it, then you posted some more stuff in the chat.
Absolutely. It's already there.
There we go. Thank you.
All right, everyone. Have a fabulous Thanksgiving. Hope you enjoy, or whatever holiday you're celebrating. And I'll
Thank
be
you,
here
Michael.
again. We'll see you next time.
Thanks a
Thank
lot,
you. It was
Michael.
great.
It was fantastic.
Thank you.
Thank you.
Awesome. Hope
Thank
to
you.
see you again.
Oh, actually, I do have a question. Quick question.
Ask away, Stanley.
Yeah. So, I just want to know how many hours actually we can charge towards a learning process for this particular AWS course.
Ooh, I don't know. I'm sorry. You'd have to talk to your either manager or the learning director, development contacts.
Okay.
I don't know the booze backend processes. Sorry.
Okay. Yeah, I was just asking because I know there's already this course, and then I think somewhere I saw like 9, but I wasn't sure if there was a hard number, and there was still like the 4 additional hours that you said next time for in December. So
Yeah.
okay.
I don't know. I don't even know how you guys charge for all that stuff.
Okay, got it. Yeah.
They just tell me to come teach, and then I just do that. The rest of it gets handled by somebody else. I apologize. I sincerely don't know.
Okay.
Generally, I charge like 8 hours for like this training.
Oh, generally you charge 8 hours from us. Is that what you said?
Yes, yeah, 8 hours.
It is technically scheduled for 8 hours, so that makes
Yeah.
sense.
Okay.
Yeah, Michael, I have a question for the evaluation. It's asking the class code. So the class code will be like AWS. It's a AWSCL ESS, right?
Actually, the class code should be posted in chat, but it's that number that I just reposted.
Oh, okay, got it. Thank you.
Yeah. That's our web age code that we
Oh.
use to identify classes.
Quick question, Michael.
Yeah, Brian.
Yeah. Hey, I have a background in system administration for Windows. Like,
Me too.
yeah. And I was retired from the federal government, doing that for 15 years. And of course, I want to get into cloud. And I was wondering what path is recommended. Is it DevOps? Or there's, yeah, it is DevOps.
No, it is DevOps, 100%. Matter of fact, let me point you to this for a second, because you might find this useful.
Okay.
I'm going to post a link for this, and then I'll just share my screen really quick. Is that there's a site, it's called the Ramp Up Guides, and I just posted if I press enter, I would post a link to it. This has a bunch of roles, like Ramp Up Guide roles, and so one of them is actually operations, which is kind of like the first level, and then there's DevOps, which is the second level. You know, for years I was a system administrator / engineer / architect, right? Like, and then the DevOps movement started in 2009, and everybody pivoted over, even if they weren't actually doing DevOps. So just know you might want to start with the operations guide. If you click on this, it's actually a really cool PDF file that gives you a bunch of free trainings on how to become conversant on operational stuff inside of AWS, including Windows, by the way. So including like PowerShell, like you'll see Windows PowerShell here, as far as like getting started, self-paced lab and all that. And so this is a great way to become conversant about how to operate on AWS, regardless of your operating system. This is level 1. Level 2 would be the DevOps guide, and that's the professional level guide. And this one goes a little deeper. So notice that it actually relies on the operations guide to get started. And then it starts going deeper into things like, command line access and CLI, and it's got code commit on Windows, and all the stuff is here. These guides are ridiculously dense, but I got to tell you, if you're looking for a step-by-step guide, Brian, on how to get up to speed,
nice.
This thing is spectacular. And if
Wow.
you actually do even 25% of what's listed in that guide, you will be one of the best Windows cloud engineers in the world. It's ridiculous.
Yeah.
I've actually made it a focus to kind of like complete the DevOps guide, because I actually have to get recertified at the end of the year. They didn't have these guides when I first took the exams.
Right.
oh my God, it has rounded me out so much to like run through these guides. It's also been intimidating because like there's
Okay.
stuff in here that I don't usually operate at.
Yeah,
So,
I mean,
yeah.
because I'm not in an environment or a role to actually have hands-on experience. So I guess there's labs incorporated in these.
Yep. You do not need your own account. You don't need a project.
Oh,
There's
okay.
self-paced labs included in
have an
all of
account.
these.
I
Oh,
did
yeah.
a SAMS course called 488. It was Cloud Essentials. So it gave me a base for AWS, Oracle, Google and Azure. But it's just a basic level.
Yeah. Yeah. So I would say, in this particular case, run through the things that make sense to you. If you need more hands-on, by the way, you can actually, go through the DevOps thing. Oh, God, I totally forgot to mention this. If you go to amazon.quicklabs.com, this is for all of you, and you sign up here with your Booz Allen email address, so you don't use a Gmail address, but you use bah.com, you will get free access to a bunch of hands-on labs that you could use to round out your experience. These all happen in a dedicated lab account on AWS. So you don't even need your own account to do them. But there are some incredible labs out here, such as like working with Redshift, or if you want to see how security works, or if you want to do containers, by the way, there's a bunch of container labs out here.
Okay.
So,
so that's AmazonQuickLabs.com.
Yeah. So I'll post that link in there as
Yeah.
well.
Okay.
Yeah.
And you just sign up with our Booz Allen email.
Yep. Just for this, for the Amazon
just for
Quick
that.
Labs. And if you do that, you automatically get a bunch of free credits.
Okay.
So it's a really kind of great process to follow.
What are
actually,
credits used for? Free credits?
Well, for example, this lab costs a credit, that's $1. Some of these labs cost 8 credits, that's $8. So you don't have to spend the credits, you actually get credits from us.
I see.
Because you took a class with us.
Oh, okay.
Yeah. So this is a way for you to you have unlimited credits here. So there's 10 credit lab, there's 15 credit labs, there's like 20 credit labs. So just know you get free credits as virtue of being a Booz employee and taking a class with us.
Okay, excellent.
Yeah, so this is a great way to get some more hands-on experience if you want it.
Okay, yeah, that's really helpful. I appreciate that.
Yeah. And there is some Windows stuff in here as well. Like they've got databases for Windows and sysadmin on Windows, if you need it to be, some of it to be Windows focused, they've got Windows specific labs here as well.
Okay. Okay, great. Yeah, thank you. I appreciate that. So It's not too late to get in, huh?
No, as a matter of fact, now it's like cloud is assumed that it's assumed that you know cloud.
Yes, exactly.
It's an afterthought.
Exactly.
It's not a forethought. It's like ridiculous. Like how broad can our industry get? It's like, really? You expect me to know all of this stuff, including a programming language and whatnot? I'm like, okay, all right, but I got to tell you what I do is I just end up dropping a skill, that like I used to know Chef Puppet really well. I just use Ansible now for everything. I don't use Chef and Puppet anymore because I can't maintain it.
Yeah, it's like it's like languages in the world. You use it for 2 years and then you stop using it, it's gone.
Yeah. Like I still, people are like, you should move on to Rust and Go. And I'm like, no, I'm sticking to Python until someone tells me I have to let it go, because otherwise I'm not going to be able to use it anymore. Because
right.
So yeah, we'll see.
Okay. Thank you, Michael. I appreciate it. Hope to see you again for another course.
Oh, I'm sure you will. I teach a lot for Booz. So it's great to have you all in class. Stanley, Ramesh, Brian, you all have a great Thanksgiving or whatever holiday you're into.
Have a happy Thanksgiving.
Yep. Thank you so much. Yep. Happy Thanksgiving.